In this demonstration, we will see how to set up Kali Linux. Kali Linux is a Debian-based operating system that is widely used by hackers and penetration testers for security assessments. To install Kali Linux, we need two things: the Kali Linux ISO file and a virtualization platform, such as VirtualBox. Let's begin with downloading the Kali Linux ISO file. Open your web browser, go to the search bar, and type kali.org. You will land on the official Kali Linux website. Click on the download button located in the middle of the screen. You will now see several platform options available for Kali Linux. Let's choose the second option, Virtual Machines. Click on Recommended for virtual machines. You will get several options to download the VM, such as Hyper-V, QEMU, VMware, and VirtualBox. Let's select VirtualBox. Click the download arrow button present at the bottom of VirtualBox option. In the pop-up window, choose the location where you want to save the file and click the Save button on the bottom right of the pop-up window to begin the download. While Kali Linux is downloading, open a new tab and search for VirtualBox. From the search results, click on the first link, Oracle VirtualBox. You'll see the VirtualBox homepage. In the interface, click on Download button under the Get Started section on the right. Next, under VirtualBox Platform Packages, click on the first option, Windows Hosts. Choose the file location in the pop-up window, and then click Save to begin downloading the installer. Once both files are successfully downloaded, you will have the Kali Linux zip file and the VirtualBox installer. To extract, right-click on the Kali Linux zip file, select Extract All, and then click Extract in the pop-up window. While the extraction is in progress, note that it may take some time, so let us proceed with installing VirtualBox. Double-click on the VirtualBox installer. Then, follow the setup instructions by clicking Next, accept the license agreement terms, and click on Next, and now, click on Yes, Next, and finally click on Install to complete the installation. Click on Finish once the setup is done. Once VirtualBox is installed and the Kali Linux file has been fully extracted, open the extracted folder. Double-click on the blue icon file inside the folder. Then, in VirtualBox, click on Tools at the top of the left sidebar and select Add. Browse to the desktop, select the Kali Linux file, and click Open. After the file loads, double-click on the blue icon file again to launch the virtual machine. It will automatically configure and open within VirtualBox. Click on Start arrow button located at the top to boot Kali Linux. We can see that the Kali Linux is starting. When prompted for login credentials, enter username, Kali as the username, and for password, enter Kali. Click Login. For a better viewing experience, switch to full screen mode. Next, click on the terminal emulator located at the top left corner to open the terminal. In the terminal, type sudo su and press enter. When prompted, enter the password, Kali. You are now logged in as root, which gives you administrative privileges. Now type sudo apt update and press enter. Again, enable full screen mode so you can view the interface comfortably. With that, the setup of Kali Linux is complete. Burp Suite is a well-known tool that is good for hackers to look for security loopholes in web apps. It lets users see and change the data that is sent between a web browser and the internet. They can use this to find problems like broken logins or weaknesses in security that are hidden. The company who made Burp Suite is Portswigger. This is a well-known company that makes great security tools. Ethical hackers love it because it has everything they need in one place, from checking web apps for bugs to testing. Professionals in computer security choose it because it's powerful and easy to use. This tool has so many extensions, like Repeater, Intruder, Comparer, Sequencer, and lots more which you can use in the extension part of Burp Suite. In this demo, we will demonstrate the steps for installing Burp Suite and its components. Burp Suite is developed by a company called Portswigger, and this is a powerful tool widely used by ethical hackers and penetration testers. Burp Suite is also frequently used by real-world attackers. Let's begin by setting up Burp Suite in our Kali Linux environment, which we installed in the previous demo. Before we begin, please make sure your Kali Linux is set up and ready to go. Burp Suite comes pre-installed in Kali Linux. To open it, click on the Application menu in the top left corner. Next, Type burp into the search bar. Select it from the list and launch application. Now click Next, then choose Start Burp. Burp Suite will begin launching. If this is your first time using it, it may take a few moments to initialize. Once it loads, you'll see the Burp Suite interface. We're using the Community Edition, as indicated in the title bar of the window. There are two versions available, the free Community Edition and the paid Professional Edition. For this demo, we'll continue with the Community Edition, which is available to everyone at no cost. Our next step is to access the Proxy tab from the top menu bar and open the browser. To do this, click Open Browser. This launches a Chromium-based browser provided by Portswigger. With the browser now open, let's intercept some web traffic by visiting google.com. First, return to the Burp Suite interface and go to the Proxy tab, then select the Intercept subtab. Make sure Intercept is enabled so we can capture requests between the client and the server. Now go back to the browser and enter google.com in the search bar. At this point, you should see a captured request between the client and the server in Burp Suite. Right-click on the request. You will see major extensions such as Send to Intruder, Send to Repeater, Send to Sequencer, Send to Comparer, Send to Decoder, and Send to Organizer. You can also view request details and session information. To pass the request to the server, click the Forward button at the top of the Intercept subtab. To stop intercepting further traffic, click the Intercept is on button in the Intercept tab. Forwarding is particularly useful when navigating websites that require multiple page interactions. That wraps up our demo on setting up and using Burp Suite in Kali Linux. In this demonstration, we will install Shell GPT, introduced by ChatGPT. Before beginning the installation, ensure that Python 3 is installed on your Kali Linux system. Python 3 is the latest major version of the Python programming language. Additionally, confirm that pip 3 is installed. Pip 3 is the official package manager for Python 3. Open your terminal. Now, type the following command: sudo apt-get install Python 3. Then, press Enter. The system will prompt you for your password. Type the default password, Kali. Python 3 will now begin installing. If you haven't installed Python 3 yet, it will automatically download and install. Since I already have Python 3 installed, I'll move on to the next step, installing pip for Python 3. To do that, simply press the up arrow on your keyboard to bring up your previous command. Now, include -pip at the end of the command. It should look like this: sudo apt-get install Python 3-pip. Press Enter. This command will install pip. As I've already installed both Python 3 and pip, I'll proceed to the next step. If you haven't done so, please install them now. Next, enter the following command: pip install shell-gpt. If you encounter an error at this point, it's likely because an additional command is required. To fix this, simply copy the command from the notes section at the bottom of your terminal screen and paste it into the previous command. It should look something like this: pip install shell-gpt-break-system-packages. Now, press Enter. Shell GPT will begin installing. Once completed, you'll see a confirmation of successful installation. Now type sgpt and press Enter. The system will now prompt you for your OpenAI API key. To obtain your OpenAI API key, open your browser and search platform.openai.com/docs/overview. Click on Dashboard button located at the top right corner of the screen, then click on API Keys on the left-hand side menu. If you already have an API key, delete it for security purposes. Click on Create New Secret Key button at the top right of the API Keys page. Give your key a name, for example, CEH v13. Then click Create Secret Key to finish. Once the key is generated, copy it. Return to your terminal, right-click, and paste it when prompted. Note that the API key won't be visible when pasted. This is a security feature to protect sensitive information. After successfully entering your API key, type sgpt-help. Then press Enter. This command will verify that Shell GPT has been properly installed and provide you with usage instructions. Note that the OpenAI API key is not free. You will need to purchase it for $5 to use Shell GPT. Let's now open the terminal. After the successful installation of Shell GPT in your Kali Linux system, we will now explore how to use Shell GPT for information gathering, also known as footprinting. For this task, we have two available methods. The first method is to use the prompt. Type the command sgpt-shell in double quotes type. Make footprinting on testphp.vulnweb.com using dig. This is our target domain. In this case, the prompt shows a reference to a specific tool within the command. If you do not mention a tool explicitly, Shell GPT will automatically select one. However, the tool it chooses might either not be installed or not compatible with your system. Now go ahead and execute the command by pressing enter. Shell GPT will generate a script for initiating the command. Remember the shortcut keys for Shell GPT. Press capital E to execute. Press capital D to describe. Press capital A to abort. To execute the command, press capital E and press enter. Once executed, you'll notice that the dig command runs automatically. This command retrieves information about the target domain. The output will show details such as CNAME of the target, which is RFC, 8482, and TTL values, such as 3600. This demonstrates one method for using Shell GPT to perform footprinting. Now type clear to clear your terminal screen. But let's look into the second method. To reuse the previous command, press the up arrow key on your keyboard till the command appears. Pressing up arrow key brings back the last used commands. Now modify the command. It should read as follows. sgpt inside double quotes type. Make footprinting on testphp.vulnweb.com using dig. Now, press enter to run the command. Shell GPT will process the prompt and return one or more suggested shell commands. These commands can either be executed manually by you or handled automatically by Shell GPT, depending on your workflow preference. The response may include various DNS record types, such as A, MX, NS, TXT, and that's how you perform footprinting using Shell GPT. In this demo, we will demonstrate the Haggard's approach to web application footprinting. To begin, open your browser, go to the search bar, and type google.com. Google.com will be our target domain. As an ethical hacker, one of your primary tasks is to check the subdomains of the target. To do that, click on the plus button to open a new browser tab and search for subdomainfinder.c99.nl. Once the site loads on the main page, you'll find a text box labeled Domain. Input the domain name you want to investigate, in this case, google.com. Click on the Start Scan button to initiate the process. The tool will then list a large number of subdomains, such as ads.google.com, accounts.google.com, and many others. Along with each subdomain, you can find the IP addresses associated with them. 142.250.102.129 is the most commonly used IP address by major subdomains. The tool has identified a total of 12,164 subdomains for the specified domain. To view the search progress, press the Check Status button located at the top of the subdomain list, then press the check button beside each subdomain to start the subdomain scan. In many cases, you may need to do some manual research on the target. This is where we can utilize automation. If you see a status code 200, it means the subdomain is live and functioning properly. I will right-click on accounts.google.com and select Open Link in New tab. I will repeat the same process for acrolinks-prod.corp.google.com to explore them further. The pages are loading without errors, indicating they are active and reachable. In addition to this, you can also check Whois data for the domain. Simply click on Whois check, located at the top of the subdomain list. Here, you'll get access to detailed information such as domain name, which is google.com, registration domain ID, which is 213-8514_domain_com-VRSN. Registrar who is server, whois.markmonitor.com. abusecomplaints@markmonitor.com, the email address used by the domain. Phone number, server name, Google LLC, the organization name, US, the admin country, and more. Everything you need for footprinting is available right here in the Whois data. Now, moving forward, attackers also uses the OSINT framework. So, go to the browser and open a new tab. Search for OSINT framework. From the search results, click on the first link, osintframework.com. There are a wide variety of tools for username searches. Click on username search engines, and you'll see a lot like, what's my name? Name check. Name checker. What's my name? What's my name? That's them. Check usernames. Let's click on check usernames. Some tools within the framework may not work at all times. However, many others will work perfectly. Next, click on People Search Engines in the main list, and then click on Registries. Here, you'll find numerous tools like the Knot, Registry Finder, and more. We will explore and use many of these tools in our upcoming demonstrations. This concludes our current demo, and that's how attackers and ethical hackers use Haggard's approach to gather information on any web application target. In this demonstration, we will learn about the Harvester tool, which is used to gather information. To get started, open up your Kali Linux environment and launch the terminal. Type the Harvester and press Enter. You will now see the interface for the Harvester tool. It supports multiple flags for customization, such as -H, -D, -S, -P, -V, and -T, and a few more. Now let's run a basic command using the Harvester tool. Type theharvester-d microsoft.com-l200-b bing. -D specifies the target domain. Here, it's microsoft.com. -L sets the limit for the number of results. In this case, 200. -B sets the data source, which is Bing. Press Enter. Now you'll see the Harvester tool running. Once it's completed, the output will display emails and hosts discovered for the target domain. For example, accountprotection.microsoft.com. Noraply at accountprotection.microsoft.com is the mail identified by this tool. Also, we can find fish at office365.microsoft.com. These are real-world examples of emails found by the Harvester tool. Now, let's see how to use the Harvester tool inside Shell GPT. Let's start our Shell GPT. Type sgpt-chat fp-shell. Now, input the following prompt in double quotes. Use the Harvester to gather email accounts associated with Microsoft.com, limiting results to 200 and leveraging Bing as a data source. This prompt mirrors the flags we used earlier in Harvester. -D for domain, -L for limit, -B for data source. So here, Microsoft.com for the target domain. 200 is the result limit. -B Bing as the data source. Now, press Enter. Then, type capital E and press Enter to execute the shell command. You'll notice that Shell GPT runs the Harvester tool with the same flags and parameters and returns the same output. This demonstrates how Shell GPT can be used for automation using simple prompts, saving time and making operations more efficient. And that concludes our demonstration of the Harvester tool. Welcome to this demonstration on utilizing the Wayback Machine, a digital archive that allows users to view historical versions of websites that have been saved at different points in time across the internet. There are two ways to use the Wayback Machine: through the web application or directly through a URL. Let's start with the web application. First, open your browser, go to the search bar, and type Wayback Machine. Then press Enter. Click on the first link, which is web.archive.org. You will see the official interface of the Wayback Machine web application. Once the page opens, locate the search box at the top middle of the screen. Now, type in your target domain, that is google.com, and press Enter. After entering the domain, you'll see a timeline with various updates for google.com. Let's focus on the year 2011. On February 1st, there were a total of 67 snapshots recorded. This means the Wayback Machine captured 67 versions or updates on that day. To view one of these snapshot data, right-click on the first data, which is 1 minute and 43 seconds, and select Open link in New tab. A new tab opens. Click on the New tab. You'll now see how Google.com looked on February 1st, 2011. There's also an option for Advanced Search on the right of the search bar. Click on Advanced Search to explore further. You can gather additional historical data from the Advanced Search option based on specific URLs or time frames. This helps gather detailed information from the past versions of a website. As you'll notice, the current version of Google.com looks very different from the older versions. Now, let's move on to the second method, which is using the Wayback Machine via URL. To use the Wayback Machine via URL method, open a new tab in your browser. In the address bar, type the constructed URL to use the API or CDX of the Web Archive tool. And www.hostinger.com is the domain name example we have used. Let's say your domain is taxdo.com. You would type taxdo.com and press enter. If your target domain is large or has a long history, this process might take a couple of minutes to load the results. Once it loads, you'll see a wide range of archived URLs. You'll find JS files, CSS files, TXT files, and many other options. All of this information is useful. You only need to copy the archive URL https://www.taxado.com/de/c/thank-u/ by right-clicking and selecting Copy option. Open a new browser tab, paste the URL, and press Enter to explore further. You can even view versions of the site in different languages, like English or German, depending on how the content was archived. These URLs can then be used to gather deeper information about your target. And with that, we're done with the setup and usage of Web Archive or the Wayback Machine for web application footprinting. In this demonstration, we'll explore Google dorking, a powerful technique used to find hidden or sensitive information on websites using advanced search operators in Google. This method is commonly used for security testing and information gathering. To begin using Google dorking, open your browser and search for Google dorking cheat sheet and press enter. From the results, you'll see a GitHub link, which is gist.github.com. Click on the link. You'll find a collection of Google dorks available for various use cases here. Let's start with the all-in-text operator, which is used to search for the occurrence of all keywords given. For example, you can type all-in-text, keyword to use the all-in-text operator. Now, we are going to use the in URL operator. We also have in text and in URL. Copy the example of in URL dork from the third column of the sheet. Open a new browser tab and paste the code into the search bar. Now, replace the keyword with PDF. Press enter. From the results, you'll see that all the data is in PDF format. For example, nhc.noaa.gov PDF, bitsavers.org PDF. You will find all the results in PDF format. This is the power of Google dorking, as it provides specific results about your target. Let's try another example of site. Copy the site dork example, site:/www.google.com. From the third column of the sheet, open a new browser tab and paste the code into the search bar. Make sure to remove the www. And then press enter. You'll now see a list of subdomains of google.com, many of which are not normally visible when you perform a basic search for google.com. This is another reason why Google dorking is such an effective technique for advanced information gathering. By using it, you can uncover a wide range of data about your target. For instance, you'll discover subdomains like images.google.com, one.google.com, scholar.google.com, accounts.google.com, workspace.google.com. Google regularly uses these subdomains, but they are typically not easily found without advanced search techniques. This is why Google dorking is critical in cybersecurity and useful in everyday search tasks. That concludes our demonstration on Google dorking. In this demonstration, we will explore DNS footprinting, a technique used to gather information about a domain's DNS records and its target systems. This includes details such as domain names, IP addresses, and network configurations. This method helps attackers or ethical hackers map the network topology, uncover security vulnerabilities, and gain insight into potential weaknesses in a network. Let's begin the demonstration of DNS footprinting. To perform DNS footprinting, open your browser and search for MX Toolbox. From the search results, click on the first link, mxtoolbox.com, that appears. Once the tool opens, you will see a search bar in the top left. In the search bar, simply enter the domain name google.com and then click on MX Lookup button beside the search bar. You will immediately receive details about the domain, such as the host name, smtp.google.com, its associated IP addresses, and the DMARC public policy. Now, let's explore more DNS-related information. Scroll down slightly on the page and click on DNS Lookup. Now, you can see comprehensive DNS details, including DNS records published, DNS records found, the domain name, which is google.com, the IP address 172.253.63.100, and the TTL, time to live, which is 5 minutes. Next, if you want to verify the DNS check, click on DNS check. Under the results section, you'll find a detailed analysis, including the SOA serial number format is invalid. The SOA refresh value is outside of the recommended range. The SOA expire value is also outside the recommended range. These are important indicators of DNS misconfigurations that may be exploited or need to be corrected. You'll also notice information like DNS record found, no bad glue detected. And that's how you conduct DNS footprinting using MX Toolbox. In this demo, we will set up the Shodan tool. Shodan is a search engine specifically designed for internet-connected devices, such as webcams, servers, routers, and more. It helps security professionals identify exposed systems and check for vulnerabilities across the internet. Shodan allows users to filter results or use dorks to gather information such as IP addresses, ports, locations, and device types related to a target. So let's get started. Open your web browser and search for Shodan. Press Enter. From the search results, click on the first link, shodan.io. You'll now see the main interface of the Shodan tool. In the search bar of the interface, type google.com and press Enter. You'll see search results like www.mykitchen3338.com. Multiple IP addresses such as 34.196.115.145, 34.226, 77.200. Using Shodan, you can obtain information about servers and devices that are available in regular search engines. You'll also notice details such as operating systems, top organizations, and top products directly from the search results. If you observe carefully, the number of proper google.com subdomains is quite limited in the results. To get more precise and targeted subdomain results, we can use dork. Dorking refines your search to return specific results. And this technique also works in Shodan. In the Shodan search bar, type ssl.cert.subject.cn:, put domain google.com in double quotes, 200. This query finds servers whose SSL certificate's common name is google.com, and that return an HTTP 200 OK response. And press on search icon. However, you might encounter an error message stating, please log in to use search filters. If you haven't logged in, to resolve this, go to the top right corner and click the Login button. Enter your username and password. Once you're logged in, repeat the search. Wait a few seconds for the results to load. You'll now see much more specific results, such as domains associated with Google and Amazon AWS. These are the proper searches given by the Shodan tool. Now, let's try a similar search for Facebook. In the search bar, type ssl.cert.subject.san, open double quotes, facebook.com, close double quotes, 200, and press Enter. You'll now see results related to facebook.com, particularly subdomains like extem.facebook.com. Keep in mind that Shodan is a paid tool. As a free user, your access is limited to only 2 pages of results. To access additional pages and unlock full capabilities, you'll need to purchase a premium plan. And that completes the setup and demonstration of the Shodan tool. In this demonstration, we'll explore who is a web application tool used to retrieve domain registration information. This information typically includes the domain owner's details, registration date, expiration date, and the DNS server. While some attackers use this tool to verify domain ownership, security researchers use it to detect potential fraud. Let's begin. First, open your browser and search for WhoIsLookup. You'll see two popular tools for WhoIs. The first is WhoIsLookup. The second is who.is. We will explore both of them. Let's start with who.is. Open the who.is website. Here, you'll see a search bar in the center of the page. To get domain information, simply type your domain name in the search bar. For example, google.com, and press enter. From the results, you'll receive key information such as the registrar's name, in this case, MarkMonitor Incorporated, the WhoIs server, which appears as whois.markmonitor.com, and dates like the expiration date and the registration date, and also the last updated date. Now, let's go back to the previous window and check another tool by clicking on the first link, whois.com. Once you open it, you'll notice two search boxes on the screen. In the first search box located at the top, type google.com and click on WhoIs button. Again, you'll see detailed domain information, including the domain name, which is google.com, registration date, expiration date, last updated date, and also the domain status. Client delete prohibited, client transfer prohibited. This indicates the server is very good. You'll also find the name servers listed. In this case, named servers are ns1.google.com, ns2.google.com, ns3.google.com, etc. If you look under registrar information once again, you'll see that the registrar is again MarkMonitor Incorporated. As you can see in the first tool, the registrar's name was MarkMonitor Incorporated. And in the second tool window, the domain name is google.com. So, who.is and whois.com are the two different tools you can use to gather information. Both of them are used to determine WhoIs. You're free to use either one or both if you want a more comprehensive view. By using WhoIs, you can access information such as registrant contact details, administrative contacts, technical contacts, registrar information, and other information about your target. That concludes this demonstration on the WhoIs tool. In this demonstration, we will showcase how to perform operating system discovery using Nmap. Nmap offers two primary methods for operating system discovery. First is by using Nmap scripting engine, or NSE, and the second is by using simple Nmap-O flag. Let's begin with the Nmap scripting engine. To do this, open your terminal and enter the following command: nmap-script smb-os-discovery.nse. This is a pre-written NSE script. 192.168.56.1 is the target IP address. Then press enter. In a couple of seconds, you will receive the output. Now, observe the results. You'll notice that no specific OS information is returned in this case. That's because Nmap has many scripts, and the results depend on choosing the right script for your target. For example, sometimes your target machine might be running inside VirtualBox, or it could be a Windows-based host. This is why it's essential to select the appropriate script according to your target environment. Now let's switch to a simpler method. Using Nmap-O flag, type the following command in the terminal: Nmap-O 192.168.56.1 is your target IP address. Then press enter. After a few seconds, you will see the output. Now compare this output to the one from the Nmap scripting engine. You might notice a message stating, OS scan results may be unreliable because we could not find at least one open and one closed port. Bridge, VoIP adapter, general purpose indicates target device type identified by Nmap. The output shows that the system might be running Oracle VirtualBox with a 98% accuracy rating. This entry suggests that Nmap has identified the operating system as Oracle VirtualBox and has detected an application developed by Danny Gasparovsky. It also provides aggressive OS guesses, such as Oracle VirtualBox, AT&T, BGW 210 Voice Gateway, QEMU User Mode Network Gateway, These entries reflect Nmap's best guesses based on the available data. Since 192.168.56.1 is a public IP address, the OS could be anything, and Nmap cannot guarantee accuracy in this case. If you're scanning a specific target IP where you know the environment, for example, a system running Windows or Linux, Nmap is more likely to identify the OS accurately. And that's how you can perform OS discovery using Nmap and the Nmap scripting engine. In this demonstration, we will use Shell GPT to perform operating system discovery. To begin, open your terminal in Kali Linux. First, we need to create a file. Type the following command, nanoscan1.txt. Press enter. We will name the file scan1.txt. Inside this file, enter 3 target IP addresses. I am using 10.0.2.2, 10.0.2.3, 10.0.2.15. After entering the IP addresses, press the following key combination on your keyboard to save the file. Ctrl+X, then press Y, and finally enter. Your file is now saved. To verify, use the following command, catscan1.txt. You will now see the 3 IP addresses listed in the terminal. Next, we're going to use Shell GPT. Start by entering the following command, sgpt-chat scan-shell. Then, type the following prompt in double quotes. Use Nmap script engine to perform OS discovery on the target IP addresses in scan1.txt. Then press enter. Type capital E when prompted and press enter. You may encounter an error message initially. If that happens, just try again. Press enter. Type capital E when prompted and press enter. You will notice that Shell GPT begins the process. The output is as follows. It shows port 135 for 45, 1042, 1043, and 7778 of TCP are open. Detected virtualization components are Oracle VirtualBox, Slurp by Danny Gasparovsky, and QEMU networking. For the second IP address, 10.0.2.3, we can see AT&T embedded with a 96% accuracy, followed by QEMU and Oracle VirtualBox at 95%. For the third IP address, 10.0.2.15, host is reachable, but all 1,000 scan TCP ports are either closed or filtered, providing no response to the scan. And that's how you can perform OS discovery using the Nmap scripting engine through Shell GPT. In this demonstration, we will demonstrate different methods used for host discovery. Let's begin by opening our Kali Linux and launching the terminal. First, let's start with the ARP scan. To perform an ARP scan, use the following command, nmap-sn-P-R, then type 10.0.2.15, which is the target IP address. Press enter. In the output, we can see the message host is up. It indicates that the target IP address responded to probe packets, confirming its presence on the network. This is how you conduct an ARP scan. Next, we'll move on to the UDP ping scan. For this, type the following command, nmap-sn-P-U, then type 10.0.2.15, which is the target IP address. Press enter, and you'll observe the message host is up. Now let's go for the ICMP echo ping scan. To do this, use the following command, nmap-sn-P-E, then type 10.0.2.15, which is the target IP address. The result displays message the host is up. To perform an ICMP timestamp scan, type nmap-sn-P, then type 10.0.2.15, which is the target IP address. Press enter. You'll once again see that the host is up. In Nmap, host discovery methods like ARP, UDP ping, ICMP echo, and ICMP timestamp are distinguished by specific flags, -PR, -PU, -PE, and -PP. Now let's try the TCP synchronization ping scan. Type the following command, nmap-sn-P, then type 10.0.2.15, which is the target IP address. Hit enter. You'll see the host is up. Next is the TCP acknowledgement ping scan. For this, use the following command: nmap-sn capital P capital A. Then type 10.0.2.15, which is the target IP address. Press enter, and you'll see that the host is up and it confirms its presence in network. Finally, let's look at the IP protocol ping scan. Use the command nmap-sn capital P capital S. Then type 10.0.2.15, which is the target IP address. Press enter. You'll see the output message indicating the host is up. These are the most commonly used techniques for host discovery. In each case, we simply change the flag based on the scanning method. In this demonstration, we will demonstrate how to use Shell GPT for host discovery. We will walk you through two examples. Let's begin with the first example, which is scanning the target network for active hosts. Start by opening the terminal in your Kali Linux environment. Now, type the following command: sgpt-chat scan-shell. After that, enter the prompt in double quotes. Scan the target network 10.0.2.15/255 for active hosts and place only the IP addresses into a file scan1.txt. Press enter, type capital E when prompted, and then press enter. You'll see that the output has been saved in the file scan1.txt. To view the contents of this file, type catscan1.txt, then press enter. Here, 10.0.2.2, 10.0.2.3, 10.0.2.15 are three IP addresses identified during the scan of the 10.0.2.15/255 network. Now, moving on to the second example, we will perform a comprehensive nmap scan against the IPs discovered in scan1.txt. To do this, again, use the command sgpt-chat scan-shell and enter the prompt in double quotes. Run a fast, comprehensive nmap scan against scan1.txt and write the results to scan2.txt. Hit enter. Type capital E when prompted and press enter. The scan results will be displayed on the screen and saved to scan2.txt. To verify, use clear command to clear the terminal screen, and then check the contents of the output file using catscan2.txt. Press enter. Now, let's analyze the results. For the host 10.0.2.2, the scan shows that port 135 is open and running the MSRPC service. Port 445 is also open and used by Microsoft ES. For the host 10.0.2.3, port 53 is open and is used for the domain name system service. For the host 10.0.2.15, all 100 scan ports are ignored, meaning no open ports were found. This is how Shell GPT can be used effectively for host discovery using nmap. In this demo, we'll show how to perform host port discovery using nmap. We will begin by identifying open ports using a UDP scan. To do this, open your terminal and enter the following command: nmap-small s capital U. This initiates a UDP scan, -v, for Verbo's output to check for open UDP ports and give detailed information during the scan. Then type 10.0.2.15, the target IP address. Press enter. We can see that the UDP scan is completed. You can see the output of given command here. Next, let's perform an XMOS scan. Simply bring back the previous command by pressing up arrow key and replace SU with SX. So the command becomes nmap-small s capital X-v10.0.2.15, the target IP address. Press enter. Here, the XMOS scan has completed. The output displays the static report of the given command. Now, let's see how to perform port discovery using Shell GPT. To do this, enter the following command in your terminal: sgpt-chat scan-shell. Type the following prompt in double quotes. Use nmap script to find open ports in IP address 192.168.56.1, the target IP address. Press enter, then type capital E when prompted and press enter again. Shell GPT will now run the command and provide the output. In the results, you can see that port 135 is open and used for Microsoft RPC. Port 139 is open and associated with NetBIOS Session Service. Port 445 is open and used for Microsoft Directory Services, Microsoft ES. Now, to clear the screen, type clear and press enter. Let's move on to retrieving service versions of the open ports. To do this, use the previous shell GPT command simply by pressing up arrow key. sgpt-chat scan-shell and modify the prompt slightly. Type the prompt. Use Nmap script engine to find open port and their versions in IP address 192.168.56.1, the target IP address. Then press enter, type E when prompted, and press enter again. In a few seconds, you will receive detailed output. You will see that port 135 is open. It runs the MS RPC service, and the version is Microsoft Windows RPC. Port 139 is open. It runs NetBIOS SSN with the version Microsoft Windows NetBIOS SSN. Service information. The detected operating system is Microsoft Windows. Capital CPE small CPE /O Microsoft Windows, which is a Common Platform Enumeration CPE identifier for vulnerability tracking. This is how you can perform port scanning using both Nmap and Shell GPT. Let's explore the key enumeration tools and the commands used to extract crucial system and network information. These tools enhance the effectiveness of testing and analysis, providing valuable insights that streamline security assessments and vulnerability identification. The first tool is Nmap. Nmap is a network scanner tool. It can be used to detect the target machine's operating system, open ports, and the services running on them. The tool also has NSE, Map Scripting Engine, which lets you do in-depth analysis with built-in scripts. Let's look at some commands that can be used with Nmap. Nmap-ss-sv-o target_IP. This command performs a stealth SYN scan to discover open ports, identify the versions of services running on those ports, and attempt to find the target machine's operating system. Nmap-pn target_IP. This command turns off host discovery, ping, allowing Nmap to scan targets that may not answer to ICMP requests, which is important when dealing with firewalled or filtered hosts. Nmap-script vuln target_IP. This command uses Map's scripting engine to run vulnerability detection scripts on the target, helping the identification of known security flaws in services or settings. Netcat is our second tool. Netcat, sometimes known as the Swiss Army knife of networking, is a simple yet powerful networking tool that is commonly used for banner capturing to help identify the service running on a specific port. Banner capturing is the process of connecting to a service and getting its initial response, or banner, which usually reveals the service's name and version. Let's look at some commands that can be used with Netcat. Command: nc destination_IP 80. This command connects to the target machine's port 80, HTTP, to communicate with the service and possibly grab its banner. nc-zv destination_IP 1-1000. This command performs a simple port scan of ports 1-1000, displaying which ones are open, -z for scan, -v for verbose. nc-lvp 4444. This command sets Netcat to listen on port 4444 for incoming connections, which is handy for reverse shells and file transfers. enum4Linux is our third tool. enum4Linux is a powerful tool that extracts data from Windows systems, both 32-bit and 64-bit, using the SMB protocol. It can list users, groups, shared files, and policies, and is based on the Samba framework, which allows Linux computers to interact with Windows shares. Let's look at some commonly used enum4Linux commands. enum for Linux dash a target underscore IP. This command completes a thorough scan and provides users, shared files, network policies, and configuration details. Enum for Linux dash u target underscore IP. This command lists all user accounts on the target Windows system. Enum for Linux dash s target underscore IP. This command enumerates the system's shared resources and folders. Next is snmp walk. snmp walk is a command line tool that uses the Simple Network Management Protocol, SNMP, for retrieving information from network devices such as routers, switches, and printers. If SNMP is misconfigured or left with default settings, it might reveal sensitive information such as system details, network setups, and user data. Here are some popular SNMP walk commands. snmp walk -v1-c public target underscore IP is used to query the device. Use SNMP version 1 with the default community string public. If successful, it may provide a variety of system information. snmp walk -v2c-c public target underscore IP. This command performs the same job using SNMP version 2c, which is more frequent in contemporary devices. snmp walk -v2c-c public target underscore IP :1.3.6.1.2.1.1. This command queries a specific OID, object identifier, to retrieve generic system information such as the device. Next, LDAP search tool. LDAP, Lightweight Directory Access Protocol, is widely used by organizations to manage user data and centralized directory services such as Active Directory. LDAP servers may frequently be queried without authentication, allowing the enumeration of usernames, email addresses, roles, and organizational structure. Here are some useful LDAP search commands. LDAP search -x-h target underscore IP -dc equals example, dc equals com. This command does an anonymous search on the target LDAP server using the provided base domain, example.com. It obtains all accessible directory entries. LDAP search -x-h target underscore IP -b-dc equals example, dc equals com, object class equals person. This command filters the search results to show only entries classified as people, useful for showing user accounts. LDAP search -x-h target underscore IP -b-dc equals example, dc equals com, cn equals asterisk, via email. This command searches for common names, CN, and obtains their email addresses. Next, SMTP enumeration tools. SMTP, Simple Mail Transfer Protocol, is used for sending emails across networks. While not a standalone tool, SMTP services on mail servers can be accessed using tools such as Telnet, Netcat, Nmap, or SNMP user enum to enumerate users or obtain sensitive information. Some SMTP servers reply to instructions like VRFY and EXBN, allowing an attacker to see if specified email addresses or users exist on the system. This information can later be utilized to conduct phishing or brute force attacks. Here are a few commands that help with SMTP enumeration. Telnet connects to port 25 of the destination SMTP server. Telnet target underscore IP 25. Once connected, type VRFY username. If the server returns a valid response, it confirms the existence of the user. Netcat acts like Telnet and allows interaction with SMTP manually. NC target underscore IP 25. After connection, type hellotest.com, VRFY admin. This helps to determine whether an email account exists. Nmap with SMTP scripts. SMTP enumeration may be automated with Nmap scripts. Nmap-p25-script SMTP-enum- users target IP. This use is built in Nmap scripts to discover valid usernames on the SMTP server. SMTP-user-enum. a dedicated tool for enumerating SMTP users using a word list. Finally, we have RPC Client. RPC Client is a command line tool that interacts with Windows systems over the Remote Procedure Call (RPC) protocol. It is part of the Samba package and is often used to list users, groups, shared resources, and other domain information on Windows systems. This tool is beneficial in situations when anonymous login is allowed, giving access to valuable information without credentials. Let's look at some popular commands. RPC client-u target_IP. This command connects anonymously to the target system. Once connected, you may use the following commands in the RP client shell. Enum users. This command returns a list of all domain user accounts on the target system. Netcharinum. This command lists all the shared folders on the target system. Before diving into the hands-on experience, let's take a moment to understand the NetBIOS tool in more detail. We know that NetBIOS enables applications on different systems to communicate over a LAN and is used in the Windows environment to discover connected devices, shared files, and printers. For enabling communication, NetBIOS identifies devices by assigning them 16-character NetBIOS names. The last character in each name serves as a service identifier. This mapping is part of the NetBIOS name table, which shows the accessible services on a device. For example, 00 represents the workstation service, identifies the computer name. Less than 20 represents the file server service, used for file sharing. 03 is the messenger service, receives messages sent via the netsend command. 1B represents the domain master browser. 1C represents domain controllers, and 1D is the master browser. Administrators and security experts can analyze network roles and services by querying distant systems' NetBIOS name tables with tools such as NetStat and NetView. Now, let's move on to the demo. In this demonstration, we'll walk you through how to use Shell GPT to perform NetBIOS enumeration in Kali Linux. NetBIOS enumeration is the process of identifying and collecting information about computers running NetBIOS services, which are used for communication within a LAN. To begin, open your Kali Linux and launch the terminal. Now type the following command, sgpt, then enter the prompt within double quotes. Perform NetBIOS enumeration on target IP. In this demo, the target IP address is 10.0.2.4. Press enter. Shell GPT will now return a NetBIOS scan result and suggest a command, nbt scan 10.0.2.4. Copy this suggested command, paste it into your terminal, and press enter. The output provides information about the target system. For instance, you'll see the NetBIOS name listed as Metasploitable. This refers to a second virtual machine set up for this demonstration. The server name is not displayed. The user appears as Metasploitable. The MAC address is not shown in this result. Now, clear the terminal screen using the clear command and pressing enter. Next, type the following command, sgpt-shell. Then enter the prompt within double quotes. Get NetBIOS info for IP 10.0.2.4 and display the associated names. Press enter. This gives us a script, nmb lookup -capital A 10.0.2.4. Press enter. Now, type capital E when prompted and press enter to execute the command. The results include the NetBIOS name, Metasploitable. You'll also see server response codes such as 00, 03, 20, and 1E. Additionally, group names and their active status will be displayed. However, the MAC address still does not appear in this output. To retrieve the MAC address, we'll run one more command. First, clear your screen again. Now, type sgpt-shell. Then enter the prompt within double quotes. Enumerate NetBIOS on target IP 10.0.2.4 within map. Press enter. Shell GPT will now generate the script. In map -p 137 -script nbstat.nse 10.0.2.4. This uses the nb stat NSE script, which is designed for NetBIOS enumeration. After running this command, you may see that port 137 over TCP appears closed, but the MAC address is successfully retrieved. It also confirms the system identity as PCS System Technic / Oracle VirtualBox Virtual NIC. And that wraps up our demonstration on using Shell GPT for effective NetBIOS enumeration in Kali Linux. In this demonstration, we'll explore how to use the Shell GPT to perform SNMP enumeration in Kali Linux. To begin, open your Kali Linux and launch the terminal. Now type the following command: sgpt --shell. Inside double quotes, enter the following prompt. Perform SNMP enumeration on target IP 10.0.2.4 using nmap and display the result. Press enter. Shell GPT will respond with a script, which is nmap -small s capital U -small p 161 script equals SNMP info 10.0.2.4. This command uses UDP port 161, which is the default port for SNMP services. Now type capital E and press enter to execute the command. After a few seconds, the scan result displays nmap scan report for 10.0.2.4. The output shows UDP port 161 may appear closed, but SNMP service data and the MAC address are still returned. In this case, the MAC address corresponds to a PCS System Technic or Oracle VirtualBox Network Interface Card, or NIC. Next, clear the terminal screen by typing clear and pressing enter. Now type the command sgpt. Inside double quotes type how to scan SNMP on a subnet using nmap and SNMP walk 10.0.2.4/24. /24 indicates the size of the IP range being scanned. This helps identify active systems within the network. Press enter. Shell GPT will return two scripts. The first is nmap -small s capital U -small p 161 -open 10.0.2.4/24. This version uses the -open flag to only show hosts with open SNMP ports. The second script is SNMP walk -small v2 small c -c public IP address. Replace IP address with your target system's address. SNMP walk is effective when SNMP services are active and accessible on the network. Once you run the command, the SNMP port may appear open, even if it's filtered, indicating that the service is active on the target device. Copy the first command and paste it in the terminal and press enter. The output shows that port 161 over UDP is marked as open or filtered, indicating that the SNMP service may be active but not fully responding to probes. We can also see a QEMU virtual NIC, which is different from the previous Oracle NIC. This difference is due to using different scanning flags and scripts, which can produce varying levels of detail, even when scanning the same machine. Previously, we used the SNMP info script. This time, we added the open flag to focus only on active ports. Different scan parameters, it can affect both the visibility and depth of the information you receive. And that concludes our demonstration on how to use Shell GPT to perform SNMP enumeration and analyze the results effectively. NTP, or Network Time Protocol, ensures that all computer clocks are synchronized. Accurate timekeeping is essential for many reasons. For instance, if computers are set to different times, they might record logs in the wrong order, which could mess up login systems or stop jobs from running as planned. NTP ensures that all devices on a network are maintained at the same exact time. It connects to time servers, which are frequently synced with atomic clocks. These servers form a chain that communicates over UDP port 123, with each server giving exact time information to the next. NTP constantly tries to keep all systems in sync. However, if the service is misconfigured or left open, it might be a useful source of information throughout the enumeration phase. Now that you understand NTP, let's explore NTP enumeration. NTP enumeration gathers information from a system's NTP service. This data can include current time on the server, server uptime, which is how long the server has been running, NTP version being used, time server hierarchy, which reveals the chain of NTP servers used for synchronization, IP addresses or domain names of connected peers, and server response settings. While this information may appear harmless, attackers may use it to find vulnerabilities, discover how the system works, and plan future attacks. For instance, if the server is running for a long time, it indicates that the system hasn't been restarted or upgraded recently. This can help attackers to identify outdated software and exploit it. It also helps attackers understand the internal server structure and detect out-of-date configurations. Let's look at the most used commands in NTP enumeration. NTP trace / target host /. This command follows the chain of NTP servers connecting to the target system. Once executed, it displays the time servers in the hierarchy, beginning with the target system and progressing to the Stratum-1 server, which is an accurate time source directly connected to an atomic clock or GPS. It provides information such as time offset and delay for each server, number of NTP layers in use, and possible internal IP addresses or misconfigurations. Here's an example to illustrate how the NTP trace command works. When you execute NTP trace example.com, it might respond with something like example.com, stratum3, offset 0.003, delay 0.020, ntp.provider.com, stratum2, offset 0.002, delay 0.010, main.ntp.org, stratum1, offset 0.000, delay 0.000. Let's understand this output. A Stratum-1 server communicates directly with a GPS or atomic clock. A Stratum-2 gets its time from Stratum-1, Stratum-3 from Stratum-2, and so on. Offset is the time difference between servers and the time source. Delay displays how long the request took to reach the server and return. This output shows how far the system is from the main time source and which servers it communicates with. It helps you verify whether your system is syncing time correctly and where its time source originates. NTPQ-P. This command lists the peers, other time servers, the system uses for time sync. It shows server names, delays, reachability, and status. It's used when you're directly connected to a system and want to check which NTP servers it's using. nmap-su-p123-script equalto ntp-info target. This command checks UDP port 123, used by NTP, and gives basic server info like version or possible misconfigurations. TCP/IP communication is not required in NTP enumeration. Let's see why. Unlike web browsing or file transfers, NTP does not use TCP to communicate. NTP uses UDP, which is a simpler protocol. UDP doesn't need a connection to be set up. You just send a request, and if the server is active, it replies. Due to this, you don't need a TCP session or handshake to get information from an NTP server. This means it is fast and lightweight. Also, it is easier to send requests without detection, and attackers can send one small packet and still get useful data. This also makes NTP easier to probe and sometimes easier to abuse if the server is not configured securely. In this demonstration, we'll explore how to use AI tools, specifically Shell GPT, to perform SMTP enumeration. We'll be working within the Kali Linux operating system for this demo. To begin, open your terminal in Kali Linux. Now in the terminal, type the following command: sgpt, then inside double quotes type, perform SMTP enumeration on target IP 10.10.0.15, and then press enter. Shell GPT will now generate several suggestions. You'll see command options including nmap commands and other alternatives. SMTP-user-enum-capital M vrfy-U/path/to/user list. .txt-t 10.10.0.15. For this demonstration, we'll use the nmap command, since it's already installed and working properly on our system. Go ahead and copy the nmap command. nmap-p 25-script smtp-enum-users 10.10.0.15. Paste it into the terminal window and press Enter to execute. You should see output confirming that the host is up and that the SMTP port, typically port 25, has been identified. This demonstrates how to perform SMTP enumeration on a target IP address. If you're using your own IP address, ensure that it's properly connected to your Kali Linux environment and that it is within the same network range. Next, clear the screen by typing clear and pressing enter. Now we'll try another prompt using shell GPT. In the terminal, type sgpt inside double quotes type perform SMTP enumeration on target IP 10.10.0.15 with Metasploit, and then press enter. Previously, we used the nmap command. Now we'll test using Metasploit. Shell GPT will once again suggest multiple command options for this prompt. Before moving forward, clear the screen again. This time, we'll include --shell into the command. Type sgpt-shell inside double quotes type. Perform SMTP enumeration on target IP 10.10.0.15 with Metasploit. Then press enter. Now type capital E to execute. Press enter. Instead of running each command manually, we can copy the suggested prompt, add --shell to run shell GPT in shell mode, and then execute the entire sequence. We also have a script here. MSF console -q-x in double quotes we have. Use auxiliary /scanner /smtp/smtp_enum semicolon. Set our host 10.10.0.15 semicolon run semicolon exit. You will notice that the target host is identified and the scan completes in just a few seconds. In this instance, no SMTP server information was returned. That likely means the SMTP service on the target machine hasn't been configured properly. If your target IP is configured correctly, this prompt will return valuable SMTP server details. You can use Shell GPT for SMTP enumeration by crafting specific prompts and combining it with tools like nmap and Metasploit to enhance your results. And that concludes our demonstration. In this demonstration, we'll explore how to perform DNS enumeration using the amass tool in Kali Linux. Amass is an open-source tool designed for DNS enumeration and network mapping. It helps security professionals identify subdomain IP addresses and related network assets. Amass is primarily used during the reconnaissance phase of ethical hacking and vulnerability assessments. First, open Kali Linux terminal. Next, go to the top left corner and click on the Applications menu. Locate the Information Gathering section. The first tool listed should be Amass. Click on it to open. You should now see the Amass command line interface. You can now see several flag options available. -h shows the program usage message. -help. This will show a list of available commands and usage instructions. -version checks and prints the version of Amass installed. Some important subcommands include Amass Intel, used to discover targets for enumeration. Amass Enum, used to perform DNS enumeration and network mapping. Now, let's perform a basic enumeration using Amass. First, clear the terminal. Then type the following command. Amass enum -d google.com. Press enter. Please note that this scan may take some time. Since google.com is a large domain with many subdomains, the scan duration can vary. As the scan begins, Amass will start retrieving domain information. This includes DNS records, IP addresses, and other useful data related to the target domain. Let's allow the scan to progress. In the output, we can observe it has identified google.com, name server, or NS records for google.com, ns3.google.com, ns4.google.com, smtp.google.com, i.google.com. It has also discovered a CNAME record for api.google.com. These DNS records are key components of DNS enumeration and play an important role in network mapping. It may take a few more minutes to list more records. We can now see the message. The enumeration has finished. In the output, we can see analytics.google.com has a CNAME record pointing to analytics-alv.google.com. dir.google.com is a CNAME record that points to directory.google.com. earth.google.com has a CNAME record pointing to www.3.i.google.com. This output shows how a mask can be used to discover DNS-related assets effectively. And with that, we conclude the demonstration on DNS enumeration using the amass tool in Kali Linux. In this demonstration, we will perform DNS enumeration using AI. As we've seen in our previous demos, Shell GPT is a powerful AI tool available in Kali Linux, often used in cybersecurity tasks. So, we'll use Shell GPT to carry out DNS enumeration. To begin, open your Kali Linux and launch the terminal. Now type the following command: sgpt-chat scan-shell. Next, enter the following prompt within double quotes. Use nmap to perform DNS enumeration where domain is google.com. Press enter. Shell GPT will respond with a suggested script. nmap-script dns-brute-small p 53 google.com. Now type a capital E and press enter to execute the command and begin DNS enumeration using Shell GPT. As you can see, the output is displayed in approximately 14.79 seconds. In the results, you'll notice that port 53 is being used. That's because our script specified -p53, which is the default port for DNS. The scan targeted the domain google.com, and the output includes filtered DNS record for that domain. For example, one MAC address listed is 2404/6800/4002/81F:/2000. We also see DNS records associated with the IP address 142.250.194.46. For the subdomain admin.google.com, the IP address is 142.250.206.110, and the MAC address appears as 2404/6800/4002/813::200, and so on. This is how you can retrieve DNS records and perform DNS enumeration using Shell GPT. In this demonstration, we'll explore how to use the SubFinder tool for gathering information on hidden subdomains. SubFinder is a command line tool, and we'll be using it in Kali Linux. To begin, open your browser by clicking the icon in the top left corner of your screen. In the search bar, type SubFinder and press enter. You should see the first link pointing to the GitHub repository with a URL like https://github.com/project-discovery/subfinder. Click on that link to open the GitHub page. Here, you'll find all the details required to install SubFinder in your Kali Linux system. Scroll down the page, and you'll come across the usage instructions. For example, to get help on commands, you can use SubFinder-h. There are many useful flags available for using the SubFinder tool. For example, -d or -domain string is used to specify a single domain. -d or -list string lets you provide a file containing multiple domains to scan. -s or -sources string is used to specify which data sources the tool should use for subdomain enumeration. To install SubFinder, you first need to make sure that the Go programming language is available on your Kali Linux system. This is typically pre-installed when you update Kali Linux. Let's begin by opening the terminal. Click on the terminal icon located in the top left corner of your screen. Now, type the following command: git clone. Next, go to the GitHub tab in the browser. Scroll up and locate the code button. Click on it, and then click on the copy URL to clipboard icon. Go back to your terminal and paste the URL after the git clone command using Ctrl+Shift+V. Now press Enter. If Subfinder is already installed on your system, you'll see a message saying that the Subfinder already exists and is not an empty directory. If not, the repository will start downloading and installing. Once the download is complete, type the following command in your terminal: cd subfinder/v2/cmd/subfinder. Press Enter to navigate to the Subfinder directory. Now compile the tool by typing the following command: go build. Press Enter. If the Go programming language is not installed on your system, the go build command will not work. In that case, you'll need to install Go first to proceed with using Subfinder. Now type the following command in your terminal: mv subfinder/usr/local/bin. Press Enter. You may receive a permission denied error because this action requires administrative privileges. To fix this, press up arrow key to bring up the previous command, and at the start, type sudo. The final command should look like sudo mv subfinder/usr/local/bin. Press Enter again. To verify the installation, type subfinder-h. Press Enter. Subfinder is now ready to use on your Kali Linux system. Finally, type the clear command to clean up the terminal screen, and press Enter. Since Subfinder is a Go-based tool, it's portable. You can run it from any directory on your system. Let's try running it from the home directory. First, type the following command: cd. Press Enter. Now you're back in the root of your user folder. To begin discovering subdomains, type subfinder-d google.com. Press Enter. Once Subfinder runs, it quickly starts identifying hidden subdomains for the target domain. In this case, it discovered 808 subdomains for google.com in just 3 seconds, 974 milliseconds, which is incredibly fast and efficient. Here you can see several hidden subdomains such as Firebase messaging campaigns.client6.google.com, qa.adz.google.com, and many more. These subdomains are typically hidden and not accessible through regular web browsers. However, they can reveal valuable information during reconnaissance. This is how you can use the Subfinder tool to discover and enumerate hidden subdomains effectively. In this demonstration, we'll explore the use of the dig command and slookup for DNS analysis. Let's start with the dig command. Dig, which stands for Domain Information Grouper, is a powerful and flexible tool used to query DNS name servers. It performs DNS lookups and displays the answers returned from the queried name servers in a clear, detailed format. Now let's see how to use the dig command for DNS server interrogation in Kali Linux. First, open your terminal. Then, type the following command: dig-ns google.com. Here, google.com is the domain we are querying. Press Enter. After running the command, you'll see the output from dig. At the top, you will notice the version. Dig 9.20.44 Debian. ns-google.com is the CNAME. In the answer section, you'll find the name servers listed for google.com. ns4.google.com, ns2.google.com, ns1.google.com, ns3.google.com. In the additional section, you'll also see IP addresses for these name servers. For example, ns2.google.com resolves to 216.239.34.10. This is how you can use the dig command to query and gather DNS server information for a domain. Now let's see how to use the ns lookup command. To begin, go to the search bar on your taskbar. Type CMD. Right-click on Command Prompt and select Run as Administrator. This will open the command line interface with the necessary admin permissions. Once you are in the terminal, you are ready to use the ns lookup tool to gather DNS information. Now, let's begin by typing the following command: ns lookup. Press Enter. This will show you your default DNS server and its IP address. In our case, the default server is geofiber.local.html. an IP address. Next, let's change the type of DNS query to retrieve SOA, start of authority, records. Set query type equals to SOA and press enter. Now, let's query a domain. Type google.com. Press enter again. Here we receive a non-authoritative answer, which means the data is retrieved from a cache, not directly from the primary DNS server. In the output, we can see primary name server is ns1.google.com. Responsible mail address is dns-admin.google.com. Refresh time is 900 seconds. Retry time is 900 seconds. Expire time is 1800 seconds. Default TTL is 60 seconds. Now you can also use another command, ls-d google.com. This command attempts to list all DNS records for the domain google.com through a process called a zone transfer. However, as you can see in the output, we get the message, cannot list domain google.com, query refused. This happens because the DNS server has refused to transfer the zone to your system. This is completely normal as most public DNS servers, especially for large domains like Google, disable zone transfers as a security measure. And with that, we conclude the demonstration on DNS information gathering. In this demonstration, I will guide you through using Burp Suite and Nikto to perform a web application vulnerability assessment. We have already set up Burp Suite in the previous demos. To open it, click the application menu on the top left, type Burp, and select Burp Suite. Burp Suite will launch. In the dialog box, click OK, then Next, and finally Start Burp. You will now see the Burp Suite dashboard. This demo will also cover the forward function. To forward requests, open Firefox and open a new tab. In Burp Suite, go to the Proxy tab on the left, then click on Proxy Settings. You'll see Burp Suite is set to use IP address 127.0.0.1 and port 8080. Now, configure Firefox to use the same proxy settings. Click the menu button at the top right in Firefox, go to Settings, and search for Proxy. Open Proxy Settings. Under Manual Proxy Configuration, set the HTTP proxy to 127.0.0.1 and the port to 8080. Click OK. Next, open a new browser tab and type https://burp, then press Enter. You'll see an error due to HTTPS. Change HTTPS to HTTP and press Enter again. On the Burp Suite Community Edition page, click the CA certificate button at the top right. This will download the CA certificate. Now, go back to Firefox Settings, remove the proxy, and search for certificates. Under Certificates, click View Certificates. In the Certificate Manager dialog, click Import at the bottom. Navigate to your Downloads folder, select the certificate file, and click Open. In the pop-up, check both. Trust this CA to identify websites. Trust this CA to identify email users. Then click OK twice. The certificate is now trusted. Return to Proxy Settings. Under Connection Settings, ensure the box "Also use this proxy for HTTPS" is checked. If not, check it and click OK. Open a new tab and return to Burp Suite. Turn Intercept on. In Firefox, search for google.com and press Enter. Burp Suite will now capture requests from your browser. To forward these requests, click the Forward button at the top left in Burp Suite. You'll see the google.com loading. Keep clicking Forward to pass requests through. Once done, google.com will fully load. If you turn Intercept off, browsing will resume normally. If you encounter issues, open a new tab in Firefox and type about:config, then press Enter. Click Accept the risk and continue. In the next screen, search for network.proxy. From the list of results, click on the second one, network.proxy.allow_hijacking_localhost. If set to false, click the toggle to change it to true, then close the tab. This completes using Burp Suite to intercept and analyze HTTP requests and responses for vulnerability assessment. Now, open a new Firefox tab, type google.com, but don't press Enter yet. First, go to Burp Suite and enable Intercept. Return to the browser and press Enter. In Burp Suite's HTTP history, you can view all requests to google.com. These are the requests between the client and server. To manipulate a request, right-click it and select Send to Repeater. Click on the Repeater tab located in the top tab bar. You can edit the request here. For example, change the host. Click on Send. You will get a 200 OK response. Change the host from www.google.com to www.google1.com. Click Send again. You will see a 404 not found response. This demonstrates how to modify requests using Burp Suite's repeater. Now, right-click the request and select Send to Intruder. In the Intruder tab, you have several options. First, let's change Google One to Google. To perform a denial of service test, set it up here. DOS involves sending multiple requests from the same source quickly. In the first line, change get/http/2 with get/1/http/2. Select 1 and click Add Section to mark payload positions. You can change the attack type from sniper to any other type as needed. I am keeping it as sniper attack. Click Start Attack. If prompted with payload is empty, click Auto section to detect payload spots automatically. In the payload section on the right, select numbers. Set from to 1 to as 100. Then set step to 1. Then click Start Attack again. Click OK in the pop-up. You will see an automated sequence sending requests with numbers 1 to 100 inserted. Now, close Burp Suite by clicking Discard. Make sure Intercept is off before exiting. Now, you'll see that google.com will continue working normally. For the second tool, open Kali Linux. In the terminal, type the command nicto-h https://google.com and press Enter. Nicto will scan the website and display results such as root pages redirects to google.com. The line subject :/cn is equal to *.google.com indicates that the website uses a wildcard SSL certificate. This is how you gather key information about a target website. Press Ctrl+C to exit Nicto. This concludes the use of Burp Suite and Nicto for vulnerability assessment. In this demonstration, we'll show you how to use Shell GPT and Smart Scanner for vulnerability assessment. Smart Scanner is an automated tool that identifies vulnerabilities without needing manual input. To get started, open your browser and type Smart Scanner in the search bar. Press Enter. From the search results, click the first link, which is thesmartscanner.com. Once the page loads, click the Download for Free button to download the tool. Save the file to your system. The download file size is approximately 113 megabytes, so it may take about a minute to complete. Please wait patiently for the download to finish. Both Smart Scanner and Shell GPT are automation tools. Shell GPT is AI-powered and interactive, whereas Smart Scanner uses limited AI features and runs on predefined logic. After the download completes, navigate to your Downloads folder and double-click the downloaded file. If a pop-up appears saying, Windows protected your PC, click More Info, then select Run Anyway to proceed. Accept the license agreement, click Next, then click Install. Once the installation is done, click Finish. Once Smart Scanner is launched, you'll see its interface. At the center of the screen, you'll find a text box where you can enter the URL of the website you want to scan. You'll also see an option to upload HTTP request files directly. For this demonstration, enter the URL, google.com, then click the Scan button. The scan will start immediately. Within seconds, issues will appear in the list on the left side of the screen. The first finding is Content Security Policy header is missing, a common issue, as this header helps block unauthorized external requests. Another issue is Sub-resource integrity is missing, which affects protection against compromised third-party resources. You'll also notice findings related to missing HTTP-only flags, which are important for securing session cookies. Additionally, the Content Type Options header is categorized as an informational vulnerability. At this stage, no high or medium severity issues have been detected. Give it a moment. The scan will complete in a few minutes and generate a full report. An important finding is that TLS 1.0 is enabled, which can expose the application to potential downgrade. The scan also identifies broken links. For example, https://www.google.com/calendar/about/sitemap.xml. Now, copy this link, open your browser, and paste it into the address bar. When you press enter, you'll see it returns a 404 error, meaning the link no longer exists, even though it still appears on the Google website. Since Smart Scanner is an automated tool, it may sometimes produce false positives. That's why it's essential to manually review the entire report during a professional vulnerability assessment. Now, let's look at some other findings. You'll notice the URL for the robots.txt file at https://www.google.com robots.txt. Click on this entry to view both the request and response. The request method is GET, which means your browser is requesting data from the server. The response shows a 200 OK status, confirming the request was successful. Copy the link for the robots.txt file. Next, open your browser, create a new tab, paste the link into the address bar, and press enter. You will see the contents of the robots.txt file. Sometimes, this file may list sensitive paths or directories. Other times, it contains only a few entries. In this example, a significant amount of information is available. Let's close the Smart Scanner and return to the main Kali Linux interface. Now that you've learned how to use Smart Scanner for vulnerability assessment, it's time to use Shell GPT. To begin, open your Kali Linux terminal by clicking on the terminal icon located at the top left of the screen. Next, type the command sgpt. Then, enter the following prompt in double quotes: vulnerability assessment steps, tools, commands for target system. Press enter. In the output, you'll notice that Shell GPT suggests some useful nmap scripts. Nmap-small s capital S, -small s capital V, -capital O, target IP. Along with commands, Shell GPT also outlines a proper vulnerability assessment process. The steps typically include planning, discovery, vulnerability scanning, analysis, reporting, remediation, reassessment. Now copy the suggested command from the Shell GPT output. Paste the copied nmap command into the terminal. Replace target IP with 10.0.2.15. Then press enter. As you can see, because we haven't opened any services or ports on the target system, there's little or no data being returned. This demonstrates how the script works when there are no open ports or active services to detect. Now type clear again and press enter to clear the screen. Next, type the following command: sgpt. Then, enter the following prompt in double quotes: give me some commands for vulnerability assessment. Press enter. In the output, Shell GPT suggests a few more useful commands for scanning and enumeration. One of them is an nmap command. Nmap-small s capital V, -small s capital C, target. You'll also see a nicto command. Nicto-small h, target. Additionally, there's a command to start OpenVAS. OpenVAS-start. And there are a few more. Now, let's copy the nicto command. Nicto-h, target. Clear the screen by typing clear and press enter. Next, paste the copied nicto command in the terminal. Replace target with https://google.com. Then press enter. In the output, you'll notice that multiple IP addresses have been identified. The primary target IP is 142.250.70.110. The target hostname is google.com. The target port is 443. You'll also notice SSL-related information included in the results. And that concludes our demonstration on the use of Shell GPT and Smart Scanner together to perform vulnerability assessments. In this demonstration, we'll use Shell GPT to create a Python script for vulnerability scanning in a Kali Linux environment. To begin, click on the terminal icon and launch the terminal. Once the terminal opens, type the following command: sgpt-chat scan-shell, and input the following prompt in double quotes. Create a Python script to run a fast nmap scan on google.com, and then execute vulnerability scanning using Nikto on google.com. This is the prompt we're providing to Shell GPT to generate and execute our vulnerability scanning script. This prompt instructs Shell GPT to generate a Python script that performs two actions. First, it runs a fast nmap scan on google.com, and second, it uses Nikto to perform a vulnerability scan on the same domain. Now, press enter. As you can see, Shell GPT will now generate a complete Python script to perform these tasks. After the script is generated, type a capital E and press enter to execute it. You will see that the nmap scan begins. After a short while, it will display the results. The output shows port 80 for TCP is open, which is commonly used for HTTP. Port 443 for TCP is open, typically used for HTTPS. Once the nmap scan is complete, Nikto will begin its vulnerability scan. You'll notice the output will show that the target IP address for google.com is 142.250.182.206, and the scan is running on port 80. The scan duration may be displayed as 3 hours, 2 minutes, and 46 seconds. As part of the scan, Nikto may reveal the following message: the X content type options header is not set. This could allow the user agent to render the content of the site in a different fashion from the declare MIME type. This indicates a potential security concern. As Nikto continues to scan, more data is being retrieved from the target. Please be patient. This may take some time. Now, we can see that Nikto may continue to identify additional findings. /news/news.mdb, uncommon header, except-ch found with contents, sec-ch-ua-arch, sec-ch-ua-bitness. This suggests that the site is disclosing user agent client hints, which may lead to privacy or fingerprinting vulnerabilities. Once you have reviewed the findings, press Ctrl+C on your keyboard to stop the execution and exit the scan. And that concludes our demonstration. This is how you can use Shell GPT to generate and execute a Python script for running both nmap and Nikto scans as part of a web vulnerability assessment. In this demonstration, we will use Nmap Script Engine, or NSE, for vulnerability assessment. To begin, open your Kali Linux system and launch the terminal. To view the available NSE scripts, type the following command in the terminal: cd/usr/share/nmap/scripts/, then press enter. Next, type ls and press enter again. You'll now see a list of available nmap scripts. These are categorized by function and protocol. Some examples include afp-ls.nse. This is for Apple Filing Protocol shares. ip-geolocation-maxmind.nse. This is for IP-based geolocation using Maxmind databases. These scripts allow Nmap to extend its functionality for a wide variety of scanning tasks. Once you've viewed the available scripts, type clear to clear the screen and press enter. If you need to return to your home directory, simply type cd and press enter again. Now, let's perform a basic nmap scan using the NSE default scripts. Type the following command: nmap-s C testphp.vulnweb.com. In this command, testphp.vulnweb.com is the target for the scan. Then press enter. Nmap will initiate a scan. Depending on your internet speed, results may appear in a few seconds or minutes. Once complete, you'll see information like: the HTTP title of the website is Home of Akunatics Art. A notice that 999 TCP ports are filtered, meaning they're blocked or non-responsive. Port 80 for TCP is open, which is standard for HTTP web traffic. Now, let's run a specific NSE script. In the terminal, type nmap --script http-title scamme.nmap.org. Then press enter. This command targets scamme.nmap.org, a public test server provided by nmap. Let's break this down. Nmap is the base command. --script HTTP title specifies the script to run. Scamme.nmap.org is the target. After executing the scan, nmap returns the following results. Port 22 for TCP is open, which is used for SSH. Port 80 for TCP is open, used for HTTP. The HTTP title reads, "Go ahead and scan me." Port 9929 for TCP is open, used by nping echo. Port 31337 for TCP is also open, labeled as elite. This demonstrates how the nmap scripting engine can provide deeper insight during a vulnerability scan. That concludes our demonstration on using NSE with nmap for vulnerability scanning and assessment. In this demonstration, we'll walk through how to set up Nessus on your Kali Linux system. To begin, open your browser in Kali Linux by clicking on Firefox ESR from the application menu. Once Firefox opens, close the default Kali Linux homepage and open a new tab. In the search bar, type the following URL: https://tenable.com/downloads/nessus !login attempted is equal to true. Then press enter. This will take you to the Tenable Nessus download page. Under the platform section, the default option is Linux, Ubuntu-based. Since Kali Linux is Debian-based, click the drop-down arrow and select Linux, Debian-based. Click on the download button. Next, agree to the license terms by clicking I agree. The Nessus download will begin and complete in a few moments. While the file is downloading, locate the checksum option next to the download button. Click it, copy the SHA-256 value, and paste it into a text editor or notepad for verification later. Once the download finishes, open the terminal. Navigate to the Downloads folder by typing cd downloads. Then press enter. To verify the file is present, type ls. Then press enter again. You should now see the downloaded Nessus Debian package listed. To verify the file's integrity, type the following command: echo, inside double quotes, enter your checksum value that was copied earlier. Copy the Debian-based Nessus file using Ctrl+Shift+C. Paste it after the checksum using Ctrl+Shift+V. Angular bracket, SHA-256 some underscore Nessus. Then press enter. Then verify the file by running SHA-256 some-C SHA-256 some underscore Nessus and press enter. If the checksum matches, you'll see OK in the terminal. Now, proceed to install Nessus with this command: sudo small apt install /. Paste your Debian-based Nessus file. Enter your password when prompted and press enter again. If Nessus is already installed, the terminal will indicate that. Otherwise, it will proceed with the installation. To clean up the screen, type clear and press enter. Now, open a new browser tab and navigate to https://tenable.com/tenable-for-education/nessus-essentials and press enter. This page allows you to register for free activation code. Fill out the form by entering first name, last name, email address, organization name. Check the box to receive product updates, then click Get Started. You'll receive a confirmation and an activation code via email. While you wait, return to your terminal and start the Nessus service by typing sudo systemctl start nessusd.service. Then press enter. Once the service starts, open a new tab in your browser and go to https://127.0.0.1:8834. This is the default local web interface for Nessus. When the browser warns you with potential security risk ahead, click Advanced then accept the risk and continue. You'll be taken to the Nessus sign-in page. If you already have an account, enter your credentials and sign in. If not, create a new one. After logging in, you'll see the My Scans dashboard. To create a new scan, click the New Scan button on the top right of the dashboard. And that completes the Nessus setup on Kali Linux. This demonstration will show how response manipulation can be used in the context of password cracking. To begin, we'll be working within the Firefox browser. Please note, this demonstration is for white hat ethical hacking only. We do not allow or support black hat or unauthorized activities. This method is intended to be used only in safe, controlled environments such as penetration testing labs or authorized test platforms. It will not work on major websites, and attempting this on real-world targets without permission is illegal and unethical. Now, let's begin the demonstration. In Firefox, go to the search bar and type testphp.vulnweb.com. Press Enter. If you encounter an error message that says, "Proxy server is refusing connections," follow these steps. Open Firefox settings by clicking the menu button in the top right corner of the browser window. From the drop-down, click on Settings. Go to the search bar at the top and type Proxy. Then, click on the Settings button that appears under Network Settings. In the Connection Settings window, select the option that says Auto-Detect Proxy Settings for this network. Click OK to apply the changes. Then, return to the test website in Firefox and click Try Again. The page should now load correctly. Now, we'll use Burp Suite. Open the application menu in the top left corner of your Kali Linux desktop. In the search bar, type Burp Suite and click to open it. Once the Burp Suite launcher appears, click Next and then select Start Burp. Burp Suite will now start loading. When it has launched, switch back to Firefox. In the search bar, type Proxy and click on Settings. Under Configure Proxy Access, select Manual Proxy Configuration and click OK. Now return to Burp Suite. At the top, click on the Proxy tab. Under the Proxy tab, click on Proxy Settings. Here, you'll see that a proxy listener is already configured on 127.0.0.1, port 8080, the default loopback address in Kali Linux. Next, go to the test website on Firefox. Click on Sign Up from the left-hand side menu bar. Here, enter test as the username and test as the password. Then return to Burp Suite. In the top left corner, locate the Intercept is on button. Make sure Intercept is enabled by clicking the button if it's not already active. Now go back to Firefox and click Login. You will now see the HTTP request intercepted under the Proxy tab. Right-click on the capture request and select Send to Repeater. Right-click on the request again, hover over Do Intercept, then select Response to this request. Now, click on the Intercept is on button to turn it off. You will now see the HTTP response displayed at the bottom in Burp Suite. Copy the full response into Notepad for future reference. Now, return to the Proxy tab and click the Forward button at the top. Next, click on the Repeater tab again and press the Send button. Here, you can view both the original request and the server's response. Switch back to Firefox. You'll notice that you are now successfully logged in. Click Log Out to sign out the test user. Now, go back to the sign up page and repeat the process. This time, use test1 as the username and test as the password. Open Burp Suite, go to the Proxy tab, and ensure that Intercept is on. Now switch to Firefox and click Login. Once again, you'll see the HTTP request intercepted in Burp Suite. Right-click on the request and select Send to Repeater. Go to the Repeater tab and click Send. Here, you'll see a 302 found response. This indicates a redirection, meaning the login attempt was unsuccessful. Now return to the Proxy tab in Burp Suite. Right-click on the request again, choose Do Intercept, and then select Response to this request. Click the Intercept is on button to turn Intercept off. You'll now see the 302 response content. Here's the key step. Let's replace the 302 found response with the 200 OK response that you copied earlier into Notepad. This simulates a successful login. Paste the saved 200 OK response in place of the current response. Then, click the forward button at the top. In Firefox, you'll now see that you're logged in, even though the credentials were incorrect. This shows the system relies only on the response code, not actual validation. A critical vulnerability. That's how Burp Suite can be used for response manipulation in password cracking, strictly in ethical test environments. In this demonstration, we will use Shell GPT for password cracking. To begin, open Shell GPT and type small sgpt --chat scan --shell, then type the following prompt in double quotes. Use random credentials on http://testphp.vulnweb.com/login.php and crack the password. This command instructs Shell GPT to generate a command that attempts to crack passwords on the specified login page using random credentials. Then click Enter. Shell GPT will generate a command utilizing Hydra, a powerful password cracking tool, to perform the task. When prompted, type capital E to execute the command, then press Enter. This action confirms the execution of the generated command in your terminal. You will notice a warning message stating, "Please do not use it in military or secret service organizations or for illegal purposes." This is an important reminder. Shell GPT must never be used to attempt unauthorized access or test credentials on random websites. Doing so is unethical, potentially illegal, and can cause serious harm to systems and organizations. So, now let's test known credentials in a controlled environment. We'll start with the command small sgpt --chat scan --shell, then enter following prompt in double quotes. Use credentials on http://testphp.vulnweb.com/login.php, where username equals test, password equals test, and insert a period. Then type the prompt within double quotes until did we get the user info.php page. In this simulation, we're testing credentials in a safe, controlled environment, a test server where both the username and password are set to test. Press Enter again. As you can see, the response confirms that test is a valid credential. This is achieved using a curl command to send an API request. Shell GPT automatically generates this curl command for you. When prompted, type capital E to execute the command, then press Enter. You'll be redirected to the user info page, which confirms that the login credentials test were accepted successfully. This shows that the username and password combination test is confirmed to be valid for the test website, testphp.vulnweb.com. While Shell GPT is a powerful automation tool, it's important to remember, when performing password cracking, always manually verify the results. Automation can occasionally lead to false positives, so it's crucial to double-check the output to ensure accuracy and avoid any misinterpretation. And that concludes how you can use Shell GPT for password testing within a controlled and ethical environment. Steganography hides secret information within an ordinary file or message to avoid detection. Just like encryption, which makes data unreadable format, steganography helps that very easily on the data. So, as an example, an attacker can hide malicious code or sensitive information inside an image, audio, or video file. These hidden messages pass undetected during transmission because the carrier file appears normal. Cybersecurity specialists use steganography to secure sensitive data, and cybercriminals hide malware or stolen data in normal-looking files. Therefore, understanding steganography is crucial in digital forensics and information security. Let's see a demo. In this demonstration, we will take a closer look at steganography. Steganography is the art of hiding data within seemingly harmless files such as images, audio, or video. This technique can be used for various purposes, including secret communication, data masking, and protecting sensitive information. Today, we'll be using Shell GPT to implement steganography and demonstrate how to embed and retrieve hidden data within an image file. To begin, we first need to download the image file required for this demonstration. Open Firefox on your computer, then click on a new tab. In the search bar, type CEH.png and press Enter. A number of image results will appear on the screen. Right-click on the chosen image and select Save Image As. Rename the file to CEH.png and save it to your Downloads folder. Once the file is saved, open the terminal on your system. Type the command ls to display all files and directories in your current location. Once the list appears, locate the Downloads folder. Now type cd downloads to navigate to the Downloads directory. Then type the command ls. You should now see a file named ceh.png. Now, to clear the terminal screen, type clear and press Enter again. Let us go back to our terminal. Now, invoke shell GPT in shell mode with the following command. sgpt-shell, then inside double quotes type, use exif tool to hide data, then inside single quotes type, my account number is 123 123 123 123 in image ceh.png. Press Enter. Then, type E when prompted, and then press Enter to execute the operation. The image file will be updated with hidden data. To confirm the file has been modified, type the command ls to list out the files. You will now see a new file named ceh.png_original, which is the backup of the original image. To view the hidden data, type sgpt-shell, inside double quotes type, use exif tool to get hidden data of ceh.png. Then, press Enter. Type capital E when prompted, and press Enter to proceed. The output will display details, such as the exif tool version number is 13.10. The file name is ceh.png. And under the comments section, you'll see my account number is 123 123 123 123. This is how you can hide data within files using a technique known as steganography. In this demonstration, we use Shell GPT to successfully embed and retrieve hidden information from an image file. Logs are communication records between the client and the server. Logs are created by computer systems, programs, or devices, keeping track of events, actions, and system behavior. They help administrators to know system activity, including network activity, file access, program installations, and login attempts. Therefore, logs help to track criminal activity and troubleshoot problems. Usually, after compromising a system, attackers erase logs to hide their footprints. Erased logs make it impossible for security teams to determine how the system was compromised, what actions the attacker took, or even when the incident occurred. Clearing logs helps attackers to escape discovery and postpone response actions, like wiping fingerprints from a crime scene, which makes the investigation more difficult and keeps them hidden for longer. Hence, log monitoring and preservation are essential to preserve cybersecurity in any company. Let's see how with a demo. In this demonstration, we'll discuss logs and the process of clearing them. However, we won't focus solely on clearing logs, because doing so can be harmful to your system. Some logs are critical for networking, and others are essential for the configuration of various subsystems you're using. So first, we'll see how to use and view logs effectively. To begin, open Command Prompt with administrator privileges. Next, type the following command: webtool. This is a command line interface tool that comes pre-installed in the command prompt. The commands used with webtool include small e. Small l stands for enumerate logs. It lists all available event logs on the system. Small g. Small l stand for get log. It retrieves the configuration details of a specified event log. Small s. Small l stands for set log. It modifies the configuration settings of a specified event log. Small c. Small l stands for clear log. It clears all entries from a specified event log. Let us demonstrate this commands. Type webtool small e small l. As you can see, this generates a list of logs. You can examine logs related to different actions and Microsoft components. This tool is useful for both enumeration and investigative purposes, especially for analyzing attacker activity. So the attacker uses this tool to clear, update, and manage log files. To view logs from the Windows subsystem, you need to go to the search bar and search for Control Panel. Open the Control Panel. Then navigate to System and Security. Click on Windows Tools. Note that this demonstration is on Windows 11. If your view is different, please navigate to the option as needed. From there, open the Event Viewer. You can view your logs list in the left pane. Click on the Windows Logs. From the drop-down, select Application. This section displays various logs including their level, date and time, and source. If you want to delete a log, then select Clear Log option to the right side of your screen. This is how you clear and manage logs in Windows 11. In the left side list, we can also see logs for security, system, setup, forwarded events. The same process applies to Windows 10. The methodology remains consistent. You can also access custom views under administrative events. Now, to view logs in Kali Linux, open your VirtualBox, start Kali Linux, and open a terminal. In the terminal, navigate to the directory by entering the command cd/var/log. Press Enter. Next, type the command ls to list the contents. This is the main log directory where all the logs are generated and separated by the system. For example, to view boot.log, run the command cat boot.log. If you encounter a permission denied error, use sudo in the command. Now the command will be sudo cat boot.log. Press Enter. Sudo command grants administrative permissions. Then enter your password. Now, you should be able to see the log contents. To delete a log, you can use the following command rm boot.txt, where boot.txt is the file name. However, as I mentioned earlier, this can be harmful to your system. So please do not perform to clear logs. This is just a demonstration to show how attackers perform log enumeration and clearing of tracks in Windows and Linux. But this is how log enumeration, manipulation, and track clearing can be performed, both in Windows and Linux environments. In this demonstration, we will explore static methods for malware analysis using two tools, VirusTotal and PE Studio. Static malware analysis involves examining a file's structure and attributes without executing it. This approach helps identify potential threats safely. VirusTotal is an online service that scans files using multiple antivirus engines to detect potential malware. To get started, open your browser and search for VirusTotal. Click on the first link from the search results, virustotal.com. Now, you'll see the VirusTotal homepage. Imagine you receive an email with an attachment and you're unsure if it's safe. In such cases, save the attachment to your computer. Then, switch on the VirusTotal homepage, click on Choose File, and upload the suspicious file. VirusTotal will scan the file and display the results, highlighting any detected malicious activities. If you'd like to analyze a URL instead of a file, open a new tab and search testphp.vulweb.com. We use this website as a test environment for such analyses. Once the website opens, copy the URL. Now, return to VirusTotal. Navigate to the URL section and paste the URL. In the URL, change HTTP to HTTPS as it provides a more secure connection. So the URL will be https://testphp.vulnweb.com. Click on Search. You will now see a scan report. For example, if 1% of the scanned URL is flagged as malicious, such as by CRDF, you can search for more details about CRDF to understand the nature of the detection. These findings indicate the types of malicious activities that could occur during malware testing. While VirusTotal is simple and effective, if you're looking for more advanced analysis, you can use PE Studio. Let's move on to PE Studio. To begin, open a new browser tab and search for PE Studio Download. Press Enter. Click on the first link for PE Studio 9.61 Basic from the search results. On the next screen, click on Download PE Studio Basic and save the file to your system. It's a small file, so the download should complete quickly. Once downloaded, navigate to the folder where the PE Studio zip file is saved. Unzip the file by right-clicking on it and choosing Extract All. Click the Extract button from the pop-up. Inside the extracted folder, you'll see several items, including an XML folder, changes.log file, a PE parser DLL file for testing, and the executable PEstudio.exe. Double-click on PEstudio.exe. If a warning appears, click on More Info, then click Run Anyway to proceed. The PE Studio interface will now open. It's user-friendly and simple to navigate. From the menu bar, click on File, then click on Open File. In the dialog box, locate and select the testing DLL file provided in the downloaded folder. Once opened, PE Studio begins analyzing the file. On the left side, you can see various analysis options. It even integrates VirusTotal for external validation. As I mentioned earlier, VirusTotal is a basic tool. PE Studio, however, goes deeper. Click on the DOS header option on the left side. Every file has a header, which is critical for understanding the file structure during malware assessments and network evaluations. You'll see details such as file ratio is 0%. Entropy is 2.133. Also, we can see the header location information and header associated with it. On the left side, click on DOS stub. You can see that the file size is under 200 bytes, and PE Studio will display the headers associated with that file. On the left, go back to the directory by clicking on d:/PEstudio/PEstudio/PEparser.dll. Under the Properties section, you'll observe several indicators, such as the first 32 bytes of the file, a text file that might not be human-readable, the dynamic link library, DLL, file, 64-bit GUI file, and a Microsoft linker. This is how you effectively use VirusTotal and PE Studio for static malware analysis. In this demonstration, we will perform dynamic malware analysis techniques. We'll be looking at 3 techniques: process monitoring, scheduled tasks, and port monitoring. Let's begin with process monitoring. For this, we'll use a tool called Process Explorer. Open your browser, go to a new tab, and search for Process Explorer, and press Enter. This broader search may return a mix of results. So, in the search bar, type Process Explorer Download, and press Enter. This specific query likely prioritizes direct download links for faster access to the official page. From the search results, click on the first link titled Process Explorer Sysinternals. Once the page opens, you'll notice that it's hosted on Microsoft.com. So this is a legitimate and highly reliable tool used for process monitoring. To download, click on the Download Process Explorer link present in the middle of the screen. Select a location on your system and save the file. Now, navigate to your Downloads folder. Right-click on the downloaded file and select Extract All to unzip it. Then click on Extract in the pop-up. After the extraction is complete, open the second file, which is the procexp.exe file. Once Process Explorer launches, you'll see how the tool functions in real time. You can monitor CPU usage, private bytes, the working set, process IDs, PIDs, and descriptions of the processes running. For example, hover over the svchost.exe file on the left side of the screen, and you can check that a process belongs to Windows, view its logs, and see where it's located and what it's doing on the system. In the dashboard, under the last column, Company Name, you can also view the company name associated with each process. In my case, it shows ASUS and AMD because I'm running this on an ASUS laptop with AMD hardware. You might see Microsoft.com or other vendor names depending on your setup. This is how process monitoring is performed using Process Explorer. There are also various options available in the interface. For advanced control, you can run Process Explorer as administrator by clicking on File in the menu bar and selecting Run as administrator option. You can also launch VirusTotal.com integration by clicking on Options. This concludes the process monitoring section. Now, let's move on to port monitoring. To begin, open the command prompt, CMD. Search for CMD in the Start menu. Then right-click and select Run as administrator. Grant administrative permissions when prompted. In the command prompt window, type the following command: netstat-an. Press Enter. You'll now see a list of ports that your system is actively using. This list includes the local address, foreign address, and connection state. For example, if you see 127.0.0.1:1042, this indicates 127.0.0.1 is the local address and port number 1042 is in use. And if it's in an established state, it means there's an active connection. This is how port monitoring is performed during dynamic malware analysis. Sometimes, malware operates by exploiting open ports. So, it's important to regularly review your open ports and investigate any suspicious or unfamiliar activity. To check this, we can always use the command netstat-an to keep track of these changes. Now let's move on to the third method, scheduled tasks. In the same command prompt, type the following command: CEH tasks. Press Enter. This command lists all scheduled tasks configured on your device. Malware can leverage scheduled tasks to execute payloads at specific times or under certain conditions. Reviewing this list allows you to identify unauthorized or suspicious tasks that could potentially be associated with malware. You'll see entries like ASUS optimization, a task with status ready; AC power notification, a task that is currently running with no next runtime; Armory crate service, task countdown, a task with status ready and a next runtime of December 31st, 2025. These are normal tasks set by system software or hardware tools. However, if you come across folders like Google System, we can see the message indicating that there are no scheduled tasks presently available at your access level. This is how you gather information about scheduled tasks and monitor your system for unusual or unauthorized behavior. This is how you perform dynamic malware analysis. In this demonstration, we'll look at ARP spoofing. To perform ARP spoofing, we'll use a tool that is pre-installed in Kali Linux, named ARP Spoof. This is a network tool used to perform ARP poisoning, tricking devices into sending their traffic through the attacker's machine. This enables a man-in-the-middle MITM attack for sniffing or manipulation. To begin, open your Kali Linux terminal. First, check your IP configuration by typing the following command: ifconfig. Then press Enter. You'll see that your IP address is 10.0.2.15 and your broadcast address, where you could say default gateway, 10.0.2.255. To demonstrate ARP spoofing effectively, you'll need another machine on the same network. In this case, we're using a Windows 10 machine. Check the configuration on this machine by typing the command ipconfig, then press Enter. Here, you can see that the IP address is 10.0.2.16, which is within the same subnet as the attacker's machine. The default gateway is also 10.0.2.255, matching the attacker's machine. Now, clear the screen by typing the clear command and press Enter. Next, run the following command on your Kali Linux machine: ARP-a. Press Enter. This will list the current ARP entries. You'll notice 10.0.2.16 is incomplete on F0. This indicates no MAC address received from 10.0.2.16 yet. Now, switch to the second Windows 10 machine. Here we can see the same IPv4 address, which is 10.0.2.16. Next, run the same command, ARP-a. Press Enter. Here, you'll see several internet IP addresses and their corresponding physical MAC addresses are available. Now, go back to your Kali Linux target machine and run the command sudo ARP spoof. Press Enter. You'll see that the ARP spoof version is 2.4. The usage format for this tool is ARP spoof, -i for interface, -c for host IP, -t for the target IP, -r host for the secondary host on which you are working. Now, run the actual command to initiate spoofing. Sudo yarp spoof -i f0-t 10.0.2.3-r 10.0.2.16. Here, F0 is your Ethernet interface. 10.0.2.3 is the target machine. 10.0.2.16 is your host machine. Now press Enter and execute the command. You'll observe that ARP spoof begins retrieving IP addresses across the network to perform ARP poisoning. If your target is metasploitable and both machines are configured on the same gateway, you'll see that its MAC address gets changed as ARP poisoning takes place. However, please note that we are not demonstrating this part in the demo because such an act is not fully ethical. Since this is an educational video, the goal is to demonstrate how the ARP spoof tool works and how to use it responsibly. So, this is how you use the ARP spoof tool. If you want to test it, you'll need to set up a metasploitable target machine. Before running the ARP spoof command, make sure to identify the target machine, specify the host machine. Observe that the other machine's MAC address changes once ARP spoof is activated. The most important point to remember is that both machines must share the same default gateway. Once that's in place, you can establish your ARP connection and then proceed to perform ARP spoofing effectively. To defend against ARP spoofing, several strategies can be applied. Start by using static ARP entries on critical systems to prevent unauthorized MAC IP changes. Enable dynamic ARP inspection, or DAI, on managed switches to validate ARP traffic. Use monitoring tools like ARPWatch or XARP to detect spoofing attempts. Encrypt network traffic with VPNs and HTTPS to protect data, even if intercepted. Segment your network using VLANs to limit the spread of spoofing within isolated zones. And finally, deploy IDS or IPS systems like Snort to detect and alert on suspicious ARP activity. These combined defenses offer layered protection against ARP spoofing. And finally, as demonstrated in this session, deploying intrusion detection or prevention systems like Snort can help detect and alert on suspicious ARP behavior in real time. In this demonstration, we'll explore the tool Wireshark. Wireshark is used for packet capturing and packet sniffing. This tool is widely used by ethical hackers and security researchers. It's a very simple tool to operate. For this demonstration, we'll use Wireshark on Kali Linux running inside VirtualBox. Start by opening your terminal. To launch Wireshark in Kali Linux, type the following command: sudo wireshark. Then, press Enter. You'll be prompted to enter your Kali Linux password. Type it in and press Enter. Wireshark will now open in the graphical interface. Since it's pre-installed in Kali Linux, there's no need to install it manually. This demo uses Kali Linux 2025.1a. Let's briefly look at the main menu options in Wireshark. Under the File menu, you'll find options to upload a new file or open a recent capture file that you worked on previously. We also have View menu. It lets you customize the interface by showing or hiding toolbars like the main toolbar, filter toolbar, wireless toolbar, and status toolbar. You can also switch to full screen mode and zoom in if needed. There's another menu called Go, useful for navigating through packet captures quickly. Next is the Analyze menu, where you can display filters, apply filters, and use Decode as to interpret packet content based on custom protocols. Let's now see how to use Wireshark in practice. Since I'm using Ethernet, you'll see on the top right corner, wired connection listed. On the dashboard, under Capture, click on F0. This will start capturing packets. At first, you might see no packets captured. That's because there's no active traffic on the network yet. To generate traffic, open a new terminal window. Clear the screen and type ping 8.8.8.8. Then press Enter. Switch back to Wireshark, and you'll now observe that packets are being captured in real time. In this case, your source is 8.8.8.8, which is the ping address, and your destination is 10.0.2.15, which is your local machine. The protocol being used is ICMP, and the packet length is 98 bytes. We can also see information which shows you exactly what packets are being sent during the capture. You'll also see different entries like frame 13, which might show 42 bytes on wire, 42 bytes captured. If you expand a captured frame, you'll find Ethernet source, destination addresses, and protocol type, such as ARP. This is how you capture, transfer requests, and analyze network traffic using Kali Linux. Wireshark also allows you to filter packets for easier analysis. In the filter bar, type small t, and you'll get suggestions like TCP. Select TCP.port equals 80 or UDP.port equals 80. Press Enter to apply the filter. If there are no TCP packets on port 80 at the moment, no results will appear. To clear the filter and view all packets again, simply delete the filter and press Enter. Thus, Wireshark is a widely used and highly effective tool for network analysts, not just for packet capturing, but for comprehensive traffic analysis as well. Every network-connected device has a MAC, Media Access Control, address. Think of it like a unique fingerprint for your network interface. It helps identify your device on a local network. Usually, this MAC address is fixed. MAC spoofing refers to changing the MAC address to impersonate another device. Why do attackers spoof MAC addresses? There are several reasons. Sometimes they want to evade network filters or restrictions. Also, bypass MAC address-based access control lists, ACLs, or stay hidden from network monitoring tools. Sometimes, it's to impersonate trusted devices in man-in-the-middle, MITM, or session hijacking attacks. Let's see how MAC spoofing works. The attacker changes their MAC address to match with another's. Most of the operating systems let users modify their MAC address with only a few commands. Linux has a well-known tool called MAC Changer. Let's look at an example command. ifconfig eth0 down. MAC Changer -m 00:11:22:33:44:55 eth0 ifconfig eth0 up. Using this command, the attacker first brings the network interface down, then spoofs a new MAC address, and then brings the interface back up. That's it. The system now thinks the network card has a new identity. On Windows, attackers can change the MAC address through Device Manager, Registry Edits, or tools like Technicia MAC Address Changer. They can also use PowerShell and Nets Network Shell. Let's look at an example using PowerShell. Set -item property -path. Open double quotes, capital HKLM : /system, /current control set, /control, /class, open curly braces, actual class GUID, close curly braces, /0001, close double quotes, -name, network address, in double quotes, -value 123456789, capital ABC, in double quotes. This command sets a custom MAC address for the selected network adapter in the Windows registry. Net's interface, set interface name equals, in double quotes, type, Ethernet, admin equals disable. Net's interface, set interface name equals, in double quotes, type, Ethernet, admin equals enable. These commands disable and re-enable the network adapter to apply the new MAC address. Here are 4 types of MAC spoofing attacks. Static spoofing. It is the simplest method to bypass access controls. The attacker often sets the MAC address manually before connecting to a network. Next is dynamic spoofing. This method uses a script or tool that helps attackers stay hidden or confuse tracking systems by constantly changing the MAC address at certain intervals. Followed by targeted spoofing. Here, the attacker spoofs the MAC address of a specific victim, like a trusted user or device on the network. This is often used to bypass MAC-based access control lists, ACLs. Lastly, we have a CAM table overflow attack. Attackers flood a network switch with random MAC addresses to overflow its CAM table, forcing it to broadcast traffic and enabling packet sniffing. DNS poisoning, often referred to as DNS spoofing, deceives a device into resolving a domain name to a harmful IP address rather than a valid one. DNS converts domain names like google.com into their matching IP addresses. Forged DNS responses can be sent by an attacker on the same network, usually using MAC spoofing. As a result, the victim's device links to a fake site, allowing the attacker to steal information, distribute malware, or conduct phishing attacks without the user's knowledge. Let's say you try to visit your bank's website. Usually, your system asks the DNS server for the bank's IP. But if an attacker responds faster with a fake IP, your device accepts it. The fake website might look similar to the real one, and when you enter your login details, the attacker grabs them. Attackers use tools like DNS spoof, EtherCap, or Responder to launch DNS poisoning attacks. These tools are often part of penetration testing suites, but in the wrong hands, they become dangerous weapons. Here are a few tools used in MAC spoofing and DNS poisoning. MAC Changer, Linux. It quickly changes the MAC address of your network adapter. Technician MAC Address Changer, Windows, a GUI tool that can change MAC addresses easily. Responder. This tool is often used to spoof DNS and other services for credential harvesting on internal networks. ERP Spoof. It helps redirect traffic on a local network and is often used before DNS poisoning. DNS Spoof. It is built explicitly for DNS poisoning on local networks. It sends fake DNS responses. And lastly, EtherCap. It is used for MITM attacks, including DNS spoofing. Here's a real-world scenario for better understanding. In a university network, a student wanted free access to the premium Wi-Fi only for faculty. The student spoofed the MAC address of a known faculty device. He got access, but later, IT noticed strange DNS traffic. It turned out he was also playing around with DNS spoofing tools and had accidentally redirected some users to fake sites. This incident shows how easily such techniques can be misused, even in simple settings. Understanding MAC spoofing and DNS poisoning is essential for cybersecurity. These powerful techniques, if misused, can cause serious harm. Ethical responsibility must always guide their use. In this demonstration, we'll explore the TCP dump tool and learn how to use it effectively within your Kali Linux environment. TCP dump is a network analysis tool. It's a command line-based packet analyzer that captures and displays network traffic. It works seamlessly across most Unix-based systems, including Kali Linux. Security professionals frequently use TCP dump in investigations or for diagnosing network issues. Since the tool is pre-installed in Kali Linux, there's no need for additional installation. Just open the terminal and you're ready to go. First, let's clear the terminal screen using the command clear. To check the version of TCP dump installed, type TCP dump -- version and press enter. In my case, TCP dump is already installed in Kali Linux environment. If it's not installed on your system, then type the command sudo apt install TCP dump and then press enter. Now enter your password when prompted. This is how you can install TCP dump. However, in most Kali Linux setups, TCP dump should already be available. Now let's clear the screen again using the clear command. Now, to run TCP dump, type the command TCP dump and press enter. If you receive a permission denied error, you'll need to run the command with root privileges. For that, you need to type sudo TCP dump and press enter. You will now begin seeing the output in the terminal. TCP dump also supports a variety of flags, such as -v, that extend its functionality. We'll now explore how these flags help with network traffic analysis. To stop the live capture, press Ctrl+C. Since no meaningful traffic was generated during this demo yet, no packets were captured. Let's clear the screen again. Next, let's try a more specific TCP dump command. So type TCP dump -i, then enter specific network interface like eth0 for Ethernet and VLAN 0 for wireless connection. -c100 specifies number of packets to be captured. Then press enter. If permission error appears again, then add sudo before the same command. The command will be sudo tcp dump -i f0 -c 100. You'll now begin seeing captured packets in the terminal. To generate traffic, open your web browser. Now, as you come back to the terminal again, you will see a lot of packets are being captured. Since we set the limit to 100, the capture stops automatically after that number is reached. If you want to capture more packets, you need to rerun the command, this time changing the count to 200. Then press enter. Go to the browser and switch back to terminal. You can see that TCP dump already started to capture packets. Now switch back to your browser and open a new tab, then visit the site, google.com. If you navigate back to the terminal again, you will notice that as you interact with websites, TCP dump actively captures 200 packets in real time and 237 packets received by filter. Now use clear command to clear the screen. This covers the basic and essential usage of TCP dump. This tool allows you to monitor your network in real time, offering insights into both performance and potential problems. For instance, if your system feels slow, TCP dump can help you pinpoint traffic-related issues. It's a powerful tool for both network analysis and security diagnostics. And that's how you can effectively use TCP dump in Kali Linux. In this demonstration, we'll explore the Shellfish tool and understand how it is used in cybersecurity awareness and education. As you know, phishing is a highly dangerous and common cyber threat in today's digital landscape. That's why understanding and educating others about phishing is crucial. To support cybersecurity awareness, we'll be using Shellfish, a tool designed for educational purposes and phishing simulation. Please note that Shellfish is not pre-installed in Kali Linux, so we need to install it manually. Open Firefox or your default browser in Kali Linux. In the search bar, type github.com. Once the GitHub homepage loads, use the search bar in the top right corner and type Shellfish. Press enter. Look for the repository named Abir Hassan 2005/Shellfish and click on it. Scroll down the page to find the installation instructions. If you're unsure about the installation, open a new tab and search online for https://www.cybrary.it/blog phishing-using-shellfish. This will take you to a detailed step-by-step article. Open Firefox in Kali Linux. Then type github.com. In the search box, type Shellfish. Select the first repository. Click on the clone or download button and copy the URL. Now let's switch back to GitHub. In the GitHub repository, click on the green code button located near the top right of the repository's main page. Then, in the drop-down, just hover your mouse over the HTTPS URL, and you'll see a clipboard icon at the right end of the input box. Click the clipboard icon to copy the URL to your clipboard. Now go back to your terminal in Kali Linux and type the command git clone followed by the copied URL. Press enter to begin cloning. Since Shellfish is already installed on my system, it displays Shellfish already exists. In the terminal, then type ls. This lists all files and folders. You should see a folder named Shellfish. Now type cd shellfish to enter the directory. To confirm, type ls again. You should see the Shellfish files listed. To run Shellfish, we need to give it root permissions. Go back to the phishing using Shellfish page. We can see that we have to use the command chmod +x shellfish.sh. Right-click on the command and copy it. Switch to terminal and paste it. Press enter. The +x flag is used to mark the script as executable in CH mode, commonly used to change the file permissions of a file or directory. Next, we have to execute the command /shellfish.sh. Copy it and paste it in the terminal, and press enter. Shellfish will now start loading. On screen, you'll see the interface of Shellfish. It is a phishing tool created and maintained by Abir Hassan 2005. You will now see a list of social sites to choose from to simulate phishing. These include Facebook, Instagram, Google, Microsoft, Netflix, PayPal, Steam. These are the common social media sites used. Let's select Google as an example. Type 3 for Google and press Enter. Next, to use the old Gmail login page, type 1 and press Enter. To use localhost, type 1 again. When prompted to use default port number, type 5555 and press Enter. The tool will begin setting up a fake Gmail login page on your local host. This may take a few moments. Once setup is complete, copy the local host link. http://localhost:5555. Now go to Firefox, open a new browser, and paste it. Once the fake Gmail login page loads, enter a test email, such as example55565695@gmail.com. Type a dummy password like "attacker is here" and click on Sign In. A pop-up will appear to save Gmail password for localhost. Then, click on Not Now. You'll be redirected to a fake account recovery page. Return to your terminal in Kali Linux. You'll see Victim Details. The victim's IP address is 127.0.0.1. The local file path is sites/google/victimip.txt. The captured email and password of victim are as follows. The account is example55565695@gmail.com. And the password is "attacker is here," all in small letters. This is how you can simulate phishing attacks using the Shellfish tool in Kali Linux. Remember, Shellfish is for educational and awareness purposes only. It is designed to demonstrate how phishing works so organizations and individuals can better protect themselves. In this demonstration, we will explore the Netcraft tool. Netcraft is a phishing defense tool designed to detect malicious websites and links. It helps users protect themselves from phishing attacks by offering detailed insights into site credibility. To begin using Netcraft, we will start by opening the Firefox browser on Kali Linux. Open a new tab in the address bar and type Netcraft and press Enter. From the search results, click on the first link, https://www.netcraft.com. You'll see that Netcraft is part of a broader suite of security demonstrations. In our case, we will focus on using the Netcraft browser extension. To install the extension, do the following. First, click on the extension button, which is on the right of the address bar. You'll often see a puzzle piece icon for it. Then navigate to the search bar in the top middle of the dashboard and type Netcraft. Press Enter. Click on the first search result, Netcraft extension. Now locate and click on the Add to Firefox button to add it to Firefox extension. When prompted, confirm by selecting Add and make sure to check the option that allows the extension to run in private window. Once installed, the Netcraft extension is ready to use. Let's test it out. Open a new browser tab and type google.com and press Enter. The website will now load normally and securely. Now, click on Extensions button at the top right corner and select Netcraft extension. You'll see that Netcraft recognizes google.com. Now select Site Report to access more details. A new window will open, showing the site title as Google with a site rank of 1. So what is site rank? Click the rank number to learn more. This ranking reflects how trusted and secure the site is, based on Netcraft's global data. In this case, Google.com is considered highly secure, earning the top rank of 1. Just below Google in the rankings, you'll find other well-known platforms. YouTube. Third is mail.google.com, followed by outlook.office.com, Facebook, and so on. Let's try another site. Type testphp.vulnweb.com into the address bar and press Enter. Now click the extension button and choose Netcraft extension again at top right and choose Site Report. You'll see that this domain has a site rank of 1,242. Its primary language is listed as English. It was first seen in April 2017. The NetBlock owner is Amazon.com, and the site is hosted by Amazon in the US West region. The hosting country is US. IP address is 44. 228.249.3, which is confirmed by VirusTotal. You can also obtain DNS admin information, which is hostmaster@eurodns.com. Using this tool, we can get further insight into the site's infrastructure. So overall, Netcraft proves to be a very effective security tool. It identifies web trackers, associated companies, website categories, and even wizard-generated websites. This is how you can extract detailed information and detect malicious websites using the Netcraft extension. If you suspect a malicious site, simply click on the search icon and enter the URL. It will instantly display a detailed site report. From that report, you'll be able to determine whether the site is malicious or safe. Or you can search the website and choose Netcraft extension and discover if the website is malicious or not. Let's analyze a familiar domain like youtube.com. Then click on Look Up. When you check Netcraft's data for YouTube, you'll find entries for both HTTP and HTTPS versions. The secure HTTPS version, https://youtube.com, has a rank of 2, while the unsecured HTTP version, http://youtube.com, has a rank of 1982. This difference clearly highlights the importance of secure protocols, like HTTPS. If Netcraft detects a malicious site, it will display a warning window, highlighted in red like this, indicating that the website is suspected of phishing. And that's how you can use Netcraft for phishing detection. To analyze websites, identify threats, and protect yourself from phishing attacks. In this demonstration, we will explore how to perform denial of service, also known as DOS attack, using Burp Suite. To begin, click on the application menu on the top left, and then type Burp into the search bar. From the search results, locate Burp Suite and click to launch the application. A quick reminder, a DOS attack involves a single client sending a large number of requests to a target server in an attempt to overload it and disrupt its normal operation. Once Burp Suite opens, click Next. Then click Start Burp to initialize the tool. It may take a few moments to load, depending on your system's performance. Once it loads, you will see the main Burp Suite interface. Now let's go to the Firefox browser, open a new tab, and close all other tabs. Before capturing a request, we need to configure the proxy settings in Firefox. To do this, click on the menu icon in the top right corner and select Settings from the drop-down menu. Navigate to the search bar and type Proxy. Then click on Settings. Choose Manual Proxy Configuration. Then click OK to apply the settings. Now open a new tab. Type www.google.com into the address bar, but do not press Enter yet. Switch back to Burp Suite. In the top menu, click on the Proxy tab. Then, within the Intercept subtab, ensure that Intercept is on. Now return to Firefox and press Enter to load google.com. Burp Suite will now intercept and display the captured HTTP request under the Intercept tab. In the HTTP request, you will notice get/HTTP/1.1. Modify this to get/1 HTTP/1.1. Now right-click on the intercepted request and select Send to Intruder. Next, turn off the intercept and click on the Intruder tab at the top of the interface beside the Proxy tab. You'll see the captured HTTP request details here. Select one, then click Add Section to mark it as a payload position. This will open payload options on the right. Now we need to define payload values. So, navigate to Payload Options and choose Payload Type to Numbers. Under Payload Configuration, set from as 1, to as 100, and step as 1. Once your configuration is complete, click on Start Attack. In the Burp Suite Intruder pop-up, select OK to proceed. Please note, since this is the Community Edition of Burp Suite, the attack will run slower. The Professional Edition executes these attacks much faster. Now, observe the results. You will see a list of requests being sent, such as get/1, get/2, get/3, get/4, and so on. You're currently viewing the request headers. The highlighted section is the parameter being changed in each request. What's happening here is Burp Suite is modifying just one parameter and sending multiple requests within the same browser session. As you can see, the HTTP status code remains unchanged because Google.com uses a highly resilient and powerful infrastructure. However, if you were targeting a less robust domain, it might crash or become unresponsive under this flood of repeated requests from a single client. Other tools that can be used for DOS attacks include Hydra, John the Ripper, and several others. And that concludes the demonstration on how to perform a DOS attack using the intruder module in Burp Suite. In this demonstration, we will explore the GoldenEye tool. GoldenEye is a denial of service (DOS) attack tool specifically designed to target websites and other web-based services. It is a widely known and commonly used tool. GoldenEye works by sending multiple HTTP requests to a targeted domain, overwhelming the server by simulating traffic from multiple sources. This tool is often referred to as a boss-level attack utility due to its efficiency and simplicity. That's why we'll be using it for this demonstration. GoldenEye is not pre-installed in Kali Linux, so let's begin by setting it up. Please open your Kali Linux terminal. Now let's navigate to Firefox browser. Now, open a new tab. In the address bar, type GitHub and press Enter. Once GitHub loads, use the search bar at the top right of the GitHub page and type GoldenEye. Then press Enter. From the search results, select the first link /GoldenEye. Click on the code button in green color and copy the repository URL. Now, return to your Kali Linux terminal. In the terminal, type the following command: git clone and paste the copied link. Then press Enter. If GoldenEye is already installed on your system, you can skip this step. If not, please install it at the beginning. Next, we'll prepare the environment to run GoldenEye. First, let's clear the terminal by typing clear and pressing Enter. Then type ls and press Enter to list the directories. You should see the GoldenEye directory. Now, to navigate to the GoldenEye directory, type the command cd GoldenEye and press Enter. Let's list out the files in GoldenEye. Then type ls and press Enter. We will be using goldeneye.py file. To use GoldenEye, we will use the command /goldeneye.smallpy, which is the Python file. As you can see, GoldenEye requires a URL to target. We can also see that we are running version 2.1 of GoldenEye, created by Jan Seidel. The usage format of the command /goldeneye.py URL options. There are different options or flags available in GoldenEye. -u, which is user agents. -w, which represents workers. -s, which represents sockets. -m for method. -n for no SSL check. Then, -h, which represents help. Here our target is HTTPS. Type /goldeneye.smallpy HTTPS. So, open a new Firefox tab. Type testphp.vulnweb.com. Once it loads, copy the URL. Switch back to your terminal and delete HTTPS and paste the copied URL. Now your command should read like /goldeneye.smallpy http://testphp.vulnweb.com -w for workers. Default is 10, but we will use 1. -s, 1 for one socket. -m, get the default method. Your command is now ready, so press Enter to execute it. GoldenEye will now begin the DOS attack simulation. You will see output indicating the number of hits, strikes, and server responses. Successful attacks will be marked, and you may also see status codes and confirmation messages like true or success or failed. And that's how you use the GoldenEye tool in Kali Linux to simulate a DOS attack. In this demonstration, we'll explore session hijacking using the cookie editor extension in Firefox. To get started, open the Firefox browser on your Kali Linux. Now, navigate to the extension option at the top right. This will open the Extensions Manager. Once the page loads, go to the search bar and type cookie editor. Press enter. You should now see a list of available extensions. Click on the second link in the search results titled Cookie-Editor. This tool is created by C. Gagnier. Click on Add to Firefox. Then, click on Add in the pop-up box on the right. When prompted, check the box to allow the extension to run in private windows and click OK in the pop-up. You'll see that the extension has been added successfully. Now close all the tabs in the current browser window. In a new tab, type the following URL in the address bar: testphp.vulnweb.com, and press enter. Once the site opens, navigate to the Sign Up option on the left. You'll find username and password fields. Next, click on the menu option on the top right corner of Firefox and select New Private Window and press enter. In the newly opened private window, again type testphp.vulnweb.com into the address bar and press enter. Now click on Firefox and choose Login Page. Here's the scenario. You're going to log in from one browser window, then capture the session cookie, and select Home of a Kinetics Art option and reuse it in another browser window. I will switch back to the login page, hence bypassing the login process entirely. This will demonstrate a session hijacking attack. So let's begin. In the first browser window of login page, enter the following credentials: username as test, and enter the password as test. Then click on Login. When a pop-up appears to save passwords, choose the option Not Now. Once you're logged in, you'll land on your profile page. You should see the following details. Username is test. Name is please work. We also have credit card number 1002111122AA, email address, phone number, and address. Now choose the cookie editor extension in the top right corner of your browser. Click on it. Choose the Export tab, and then select Header String. Now switch to User Info page in the browser. Then click on Sign Up option on the left. At this point, you are not logged into this profile. I will refresh the page. The site asks for login credentials again. Now, instead of logging in, we'll inject the session cookie data using the cookie editor. To perform that, click the cookie editor icon in the toolbar. Select the Import tab. In the Import box, paste the copied header string. Then click Import. Paste the earlier copied content of header string from Export tab, and click on Import. Now, refresh the page again. You should now see Logout Test, which indicates that the user test is logged in, without entering a username or password. Navigate to the User Profile section. You'll now see updated user details, where name is John Smith. Then there is credit card number, which is 123456782300900. Then email address, which would be email@email.com. Phone number is 232-3345, and address, which is 21 Street. This confirms that session hijacking was successful. Now switch back to the original browser window. You'll see the same session active there as well. Here the username is John Smith, and in other tab a username is Please Work. This occurred because the website is vulnerable. It lacks proper session management and security controls. That's why session hijacking is possible here, due to weak session handling and existing security flaws in the application. Here we have brute force the password. You can also modify user data like email, name, phone number, and other fields by editing cookie values directly. This demonstrates how session hijacking works using the cookie editor extension. It allows unauthorized access by manipulating session cookies. No need for credentials, no username, and no password, just the use of session data. This attack technique is called session hijacking. Welcome to this demonstration. We will explore the use of cross-site scripting vulnerability to perform session hijacking. Let's begin by opening Kali Linux system. Open the Firefox browser. Once the browser is open a new tab. Now, in the address bar, type testphp.vulnweb.com. Press Enter. This is a free test website we use for practicing vulnerability exploitation in a safe environment. Once the site loads, Navigate to the Sign Up option on left. Enter the username and password, then click on Login. When a pop-up appears to save passwords, choose the option Not Now. At this point, you should see the details like name, credit card number, email, phone number, and address once you're logged in. In this case, we can see that we have implemented another kind of payload, but we will insert a JavaScript payload. This payload will execute within the browser and allow us to extract session-related data. So open a script tag, alert, within parentheses type document.cookie, close the script tag. You can type this manually or copy and paste it into the input field on the target site. The document.cookie function is crucial. It's often used to access cookie data, which can be hijacked during an attack. Now click on the Update button on the website. You should see a field displaying something like login equals test %2ftest. In one of our previous videos, we have demonstrated how to hijack a session using a cookie editor browser extension, where we used it to extract and modify session cookies. If you haven't had the chance to view that video, please rest assured, we'll revisit that method here. Open your Firefox browser once more, click on the extensions, and in the search bar type Cookie Editor. Press Enter. Now, navigate to the second link, Cookie-Editor, in the search results, which should lead to the Cookie Editor extension page. Then, click on Add to Firefox. Then, click on Add in the pop-up box on the right. When prompted, check the box to allow the extension to run in private windows and click OK in the pop-up. Once added, click the Cookie Editor icon in your browser extensions. Then click on Login. You will see a drop-down displaying your current cookies. Here, the cookie named Login has a value of test %2ftest. Now click on Update option. In the pop-up, you can see the value. Login is equal to test %2ftest. You can now edit this cookie's value. By changing it to match a valid session, you can effectively access an authenticated session, demonstrating a session hijack. Remember, there are multiple techniques for session hijacking. This demo highlights how cross-site scripting can be used to achieve that. The essential part is identifying a vulnerable input field or parameter, one where your script can be successfully executed. To test that, we need to use the payload discussed earlier. Open a script tag, alert, within parentheses type document.cookie, close the script tag. As discussed earlier, the document.cookie function is key. It retrieves session cookie information directly from the browser. And that's how you can demonstrate session hijacking using an XSS vulnerability. In this demonstration, we'll explore the use of Snort in IDS and IPS systems. Snort is a widely used open-source intrusion detection and prevention tool. It works based on a set of rules that help identify suspicious network activity. Snort rules are typically grouped into 4 main types. First, we have the community rules. These are free and publicly available. They're created and maintained by the Snort community and don't require any kind of user account. Second, there are the registered rules. They are free and available to anyone who registers. They are released after a delay, but remain accessible indefinitely. Third, we have the subscription rules. These require a paid subscription, but they provide the most up-to-date protection with the latest rule updates. Lastly, you can also create your own custom rules. In this demonstration, we'll focus on using Snort on an Ubuntu machine and setting it up with a basic configuration. To get started, open your Ubuntu terminal. To install Snort, type the following command: sudo apt-get install snort-y. Press Enter. This command will begin the installation process. During the setup, Snort will ask for your network IP address and configuration details. Just follow the prompts to complete this part. To find your IP address, open a new terminal tab in Ubuntu. You can do this by clicking the drop-down menu at the top of the terminal window and selecting Ubuntu. Next, type the following command, IP-addr. Then press Enter. This will display your network configuration. In the output, look for your IP address. Also, take note of your network adapter name, which here is F0. Now we will copy the first 3 octet of the IP address. Then, switch back to the previous terminal tab, where Snort is prompting you to enter the IP address. Paste the copied portion into the configuration prompt. After pasting the IP address, type 0/. Now switch back to the new terminal tab and confirm your IP range. In our case, it's 20. Then, return to the previous tab where Snort is running and type 20 to set the network range. After entering the details, use the down arrow key to navigate to OK, then press Enter to confirm. You'll see a confirmation that the setup is complete and the download was successful. Type the command clear to clear the terminal screen. Now that your IP is set up, we can move on to the next step. Type the following command: sudo IP link set eth0 promisc on. Here, eth0 is the name of network adapter. Then press Enter. After running the command, you might not see any visible change, but it's working in the background on your network adapter. Now, switch to the next terminal tab and type the command IP addr. Press Enter. Here, you'll notice that promisc mode is now enabled on your adapter. This confirms that the command worked successfully. Now, type the next command to open the Snort configuration file. Sudo nano/etc/snort/snort.conf and press Enter. This will open the Snort configuration file in the Nano text editor. Nano is a simple command line editor, but you can use any text editor you prefer. Now, scroll down through the file. We won't be making major changes here, but you'll notice a line. IP var capital home _ capital net. Any. Now, we need to update this with our actual IP address. Switch to the other tab and locate your IP. Copy this address, return to the configuration file, and replace the word any in the line. IP var capital home _ capital net. Any with your copied IP address. Instead of using the full IP address, replace the last part with 0 to define the network range. This represents the entire subnet. Once done, press Ctrl+X to exit, then press Y to save the changes and press Enter. You've now successfully updated the Snort configuration file. Before we move on to the next command, let's quickly understand the types of Snort rules. Snort supports several types of rules. Alert, to generate alerts when a condition is met. Block, to block traffic, typically used with inline mode. Drop, to silently drop packets. Log, to log traffic without raising an alert. Pass, to ignore certain traffic. In this demonstration, we'll use an alert rule. To do that, type the following command in the terminal: sudo nano/etc/snort/rules/local.rules. Now we're navigating to the directory where Snort's local rules are stored. Once you press Enter, you'll see that we're inside the local.rules file. This is where we'll define our custom rule. Now, we need to add a custom Snort rule using the alert action. Type the following command: alert ICMP any arrow for this type $sign $capital home _ capital net. Any inside parenthesis type MSG : inside double quotes type ping detected exclamation sign close double quotes semicolon SID :10001 semicolon rev:1 semicolon. Let's break it down. Alert is the action. ICMP is the protocol we're monitoring. Any means the source IP and port can be anything. Arrow defines network traffic direction. $home _ net means traffic directed to our home network on any port. Inside the parentheses, message : ping detected is the message that will be shown in the alert. SID : 1000001 is the Snort rule ID. Rev:1 is the revision number. Once you've typed the rule, press Ctrl+X, then Y to save, and hit Enter to exit the editor. Now your alert rule is set up. Now type the following command: sudo snort-small-q-var/log/snort-small-if0-A console-c/etc/snort/snort.conf. Press Enter. Snort will start running smoothly. If you see any errors, it means Snort is not working properly, and you'll need to check your configuration and rules. If no alerts appear immediately, that's a good sign. Snort is running correctly. Now when your network receives any traffic, Snort will detect it and alert you. For example, when a ping is detected. To stop Snort, simply quit the process by pressing Ctrl-Z. Afterwards, you can check the logs by running the command sudo ls/var/log/snort. Here, you'll find alert logs, such as the file named as snort.log.174.932.0804 and snort.log.174.932.0984. Let's close the terminal and go back to the Kali Linux home screen. Now that you've seen how to use Snort, let's move on to another powerful IDS and IPS tool, Suricata. To begin, open your Kali Linux terminal by clicking on the terminal icon at the top left of the screen. Now type the following command to download and install Suricata. Sudo apt install suricata-y. Then press enter. In this case, you can see that Suricata is already installed on the system. If you haven't installed it yet, this command will handle the installation for you. Once that's done, clear the terminal again by typing clear and press enter. Now type the following command in the terminal. Suricata-help. Then press enter. In the output, you'll see that the installed version of Suricata is 7.0.10. You'll also find several useful command line flags. -c is used to specify the path to the configuration file. -T tests the configuration file for any errors. -D runs Suricata as a background daemon. -l sets the default log directory. And many other flags are available. Type clear again to clean up the terminal screen and press enter. Now type the following command in the terminal to test Suricata's configuration file. Sudo suricata-t-c/etc/suricata/suricata.yml. Then press enter. In the output, you should see a confirmation message like, "This is Suricata version 7.0.10 release, running in system mode." If you see this message, your configuration is valid and you're good to go. Now, type clear to clean up the terminal screen and press enter. Now type the following command. Sudo suricata-c/etc/suricata/suricata.yml-i eth0. Then press enter. In the output, you'll notice several key messages. Suricata. This tells us that Suricata version 7.0.10 release is running in system mode. Detect. A warning here says that no rule files match the expected pattern at /var/lib/suricata/rules/suricata.rules. Detect. Another note mentions that even though one rule file was specified, no actual rules were loaded. AF-packet. This means interface eth0 is using AF-packet, but recommends version 3 for better performance in non-inline setups. Threads. It confirms that threads were successfully created, logging details like w:2fm:1fr:1, and that the Suricata engine has started. Now press Ctrl+C to stop Suricata. You'll see a message saying, "Signal received," confirming the process was successfully interrupted. Next, clear the screen by typing clear, then press enter. To check Suricata's logs, type the following command. Sudo les/var/log/suricata/eve.json. Then press enter. In the output, you'll notice log entries dated June 12, 2025. These entries represent alerts and detection events recorded by Suricata stored in the eve.json log file. To exit the log view, press Ctrl+Z. That's how you can use Suricata as another effective tool for intrusion detection and prevention. Next, we will explore firewall solutions and how they respond to scanning attempts. To do this, we will use nmap along with some specialized commands to analyze firewall behavior. Let's begin. Type the following command in the terminal. nmap -D 10.0.0.2, comma capital ME, 10.0.2.5. 10.0.2.5 is the target IP address. Then press Enter. In the output, you'll see port 21 over TCP is open for FTP. Port 22 over TCP is open for SSH. Port 23 over TCP is open for Telnet. This method injects fake IPs to disguise the real attacker. If you capture this scan using Wireshark, you'll notice requests coming from the fake IPs, making it harder to identify the true source of the scan. Now, type the clear command to clean up your terminal screen. Next, type the following command: sudo tcp dump -i f0 host 10.0.2.5. Press Enter. When prompted, enter your Kali Linux password. In the output, you'll see system is waiting for network traffic on F0. You'll also notice the capture is running on the Ethernet interface, and the snapshot length is set to 262,144 bytes. Run this TCP dump command in one terminal while scanning from another, using tools like Nmap. This allows you to observe which packets are reaching the target and which ones are being filtered by the firewall. Leave this terminal running and now open a new terminal window. Now, type the following command: sudo nping -icmp 10.0.2.5. Press Enter. When prompted, enter your Kali Linux password. In the output, you'll see that ICMP packets are being sent and received. We can see raw packets sent are 5, and raw packets received are 5. This indicates that ICMP traffic is allowed, and the firewall is not blocking these requests. This is a simple but effective way to test ICMP firewall behavior on a network. Now, clear the screen by typing clear command. Next, click on the terminal icon at the top of the screen, and then select the first instance of the terminal to return to the first terminal window where TCP dump is running. You will now see the captured traffic. As packets travel between your system and the target, you can observe how they appear in the output. This gives you visibility into what gets through the firewall and what doesn't. Once done, press Ctrl+C to stop the process and then type clear to clean up the terminal screen. Now, type the following command: sudo nping -tcp -p 443 10.0.2.5. Press Enter. You will now see that the TCP packet synchronization process has started. In the output, you can see 5 packets are sent and 5 packets are received. This indicates that the firewall is allowing TCP traffic on port 443. So this is how you can analyze firewall behavior using a combination of tools like Nmap, nping, and TCP dump. And that concludes our demonstration. In this demonstration, we'll explore how to use Nmap to detect low-interaction honeypots and the techniques to effectively bypass them. We'll cover several techniques, which we will demonstrate step by step. To begin, open your Kali Linux terminal. Our first technique involves operating system detection and service version scanning to identify potential anomalies. Honeypots often attempt to imitate real operating systems, but they frequently contain subtle inconsistencies in their OS fingerprints. If Nmap is unable to confidently determine the operating system, it could suggest the presence of a honeypot. To test this, enter the following command in your terminal: nmap -O -v, then enter target IP address 192.168.56.1. Press Enter. Here, -O enables OS detection and -v triggers service version detection. Once you run the command, Nmap will start analyzing the target to determine its operating system and running services. If the output includes something like no exact OS matches for host, test conditions non-ideal, service info :OS :Windows, CPE /o Microsoft Windows. It indicates that the system might be running Windows, even though Nmap isn't entirely certain about the operating system. This method helps detect irregularities that could point to a honeypot. Since this is a Microsoft Windows version, it is unlikely to be a honeypot. This is how we can gather clues to detect honeypots. Now, clear the terminal by typing clear and pressing enter. In the next method, we'll decoy packets to confuse the target's logging systems. In your terminal, type nmap-D, capital R&D, :10, then type the target IP address, 192.168.56.1. Press enter. This sends 10 random decoy packets to the target IP address. These decoy packets simulate different sources, helping to mask your actual IP address. Some honeypots may raise alerts or respond oddly when decoys are used. So if you notice strange output or warning messages, it could suggest the presence of a honeypot. And you can bypass this using several techniques. As the scan runs, we can see that the synchronization stealth scan timing indicates approximately 37% completion. This is a large scan because we are sending 10 random decoy packets. If your target IP range is large, the scan will take more time to complete. Here, the stats shows elapsed time is 10 seconds, but scanning may still be in progress with no results yet. 0 hosts completed. Now observe the updates showing progress, such as 52.3%, followed by 52.38%, and then 52.4% completed. You can scroll up in the terminal to review earlier output, especially if it scrolls by too quickly. We can see 49 seconds have elapsed since the process began. Eventually, the results will appear. For example, 49.72% completed. You may also encounter a warning message, such as retransmission cap hit 10. This warning means that either a honeypot has detected your scan or the system has reached a limit during decoy packet transmission. Using the -D flag in nmap helps detect honeypots by analyzing how the system responds to decoy traffic. To end the task, press Ctrl+C in the terminal to stop the scan. Now let's clear the screen using the clear command and pressing enter. Now, let's look at our next technique. Using a randomized source port, enter the following command: nmap-source -port 53, then type your target IP address, 192.168.56.1. Then press enter. After entering the command, wait for nmap to generate output. Some honeypots only accept traffic that appears normal. Port 53, associated with DNS, is often considered trustworthy. Here we can see port 53 isn't active. Instead, the scan reveals TCP port 135 is open and used for Microsoft RPC, MSRPC. TCP port 139 is used for NetBIOS SSN, and TCP port 445 is used for Microsoft ES. This output suggests the system is likely legitimate, as simplistic honeypots often do not emulate these services accurately. To practice safely, use the IP address of another virtual machine within your own lab environment. Now, let's try our final method, which is packet fragmentation to evade basic detection systems. First, type clear to clear the terminal screen. Then, enter this command, nmap-f, then enter target IP address, 192.168.56.1. Press enter. This option breaks the scan data into fragmented packets. Some honeypots may not be able to properly reassemble or analyze these fragments. You'll likely see similar responses as in earlier scans, providing another clue about how the system reacts. So packet fragmentation can be an effective technique to bypass simpler honeypot detection mechanisms. That concludes our demonstration on using nmap to detect and bypass low-interaction honeypots. In this demonstration, we will perform a directory traversal attack in a web application. A directory traversal attack allows an attacker to access restricted directories and obtain sensitive information by using specially crafted input, known as directory traversal payloads. To begin, open the Firefox browser on your Kali Linux system. Once the browser opens, close any unnecessary tabs and open a new one. In the address bar, type the following URL: testphp.vulnweb.com. Press Enter to load the site. This is a publicly available demo site designed specifically for practicing web application security testing. To proceed, you'll need to sign up on the website. Click the Sign Up button located in the left sidebar of the homepage. In the sign-up form, enter test as your username. Then, click on the password field and type test as your password as shown below. Click the Login button to continue. A pop-up appears asking to save the password. You can choose Not Now. A pop-up window will appear displaying the number 0. This is a default cross-site scripting alert set by the website. Click OK to close the pop-up and continue. When the pop-up appears again, click Not Now. Next, we need an image to target for the directory traversal attack. Click on Browse Artists, located in the left sidebar of the homepage. A list of artist names will appear, including Blad3, Lizy, R4W8173. Click on the artist named R4W8173. On the artist page, scroll down and click on View Pictures of the artist, located near the bottom of the page. This will open a gallery showing images associated with the selected artist. Next, open a new tab in your Firefox browser. In the address bar, type Directory Traversal Attack Payloads. Press Enter. From the search results, locate the first link provided by OWASP, which is https://owasp.org, and click on it. This page lists commonly used payloads for directory traversal attacks. One of the most used payloads in a directory traversal attack is /etc/p8sswd. This file contains information about user accounts on a Linux-based system. To test this, modify the file parameter in the image URL. Replace the existing image path with /etc/p8sswd. Return to the test website by clicking on the Pictures tab. Once you're on the page displaying the artist's images, go to the first image in the gallery. Right-click on the image and select Open Link in New tab. A new browser tab will open, displaying the image directly. Now, switch back to the OWASP page and copy the payload /etc/p8sswd. Next, return to the browser tab that shows the image file. In the address bar, replace the existing image path /pictures/1.jpg with the payload you copied. /etc/p8sswd. After making the change, press Enter. If you see an error message, it indicates that the server has blocked the request. To bypass this restriction, you'll use Burp Suite. Open Burp Suite by clicking its icon on the top left of your screen. Once it opens, click on the Proxy tab in the top menu bar. Within the Proxy tab, look for the Intercept section and turn it on by clicking the button labeled Intercept Off. The label should change to Intercept On. Now, return to your browser. Refresh the image page by clicking the Refresh button on the left side of the address bar. Then, switch to Burp Suite to check if the request is being intercepted. If the request is still not intercepted, open the browser menu by clicking the icon on the right side of the address bar. From the drop-down menu, select Settings. In the Settings page, use the search bar to type Proxy. Click Settings under the Proxy section. A pop-up window will appear. In this window, choose to set up a manual proxy configuration. Set the IP address to 127.0.0.1 and set the port to 8080. Click OK to save these settings. Return to the Image tab in your browser and refresh the page again. You can now see your request is intercepted by Burp Suite. In Burp Suite, look at the bottom half of the window where the intercepted request is displayed. Right-click on the request and select Send to Repeater. Next, click the Intercept On button at the top of the Proxy tab to turn Intercept off. Now, switch to the Repeater tab in top menu. You will see the request you just sent. Click the Send button in the top left corner of the Repeater tab. You may receive a 200 OK response, indicating the request was successful, but the page might still display an error. To improve your payload, type ... before /etc/PASSWD in the first line. This sequence moves up one directory level. Click Send to resend the request. If the error still appears, continue adding more ... sequences to your payload and retry the request each time. Eventually, you will reach the root directory, and the server will respond with directory listing data. You might see output that includes entries such as root:x:0:root:/bin/bin/bash, daemon:*1:1:demon:/usr/sbin:/bin/sh, bin:*x:2:bin:/bin:/bin/sh, and more. These entries confirm that you've successfully performed a directory traversal attack. If you want to try another method, open Firefox again and go to the tab where the test site link is open. In the address bar, remove any URL parameters after the main domain and press Enter to return to the homepage. Now, in the URL bar, next to testphp.vulnweb.com/type phpinfo.php. If you receive a file not found error, try alternative file names, such as secured/phpinfo.php. If one of these file names works, you will see a detailed PHP information page. This page displays critical information, such as PHP version, configuration file paths, user files information, additional file details, and server-specific settings. This is another example of a vulnerability that can be exploited through directory traversal techniques. And that concludes our demonstration on how to perform a directory traversal attack in a web application. In this demonstration, we will perform FTP brute forcing. FTP brute forcing is a systematic method of trying multiple username and password combinations to gain unauthorized access to an FTP server. Attackers commonly use tools like Hydra, along with custom scripts, to automate this process. To defend against such attacks, it is important to implement strong passwords and utilize intrusion prevention systems like fail2ban. For the demonstration, we will use the Kali Linux terminal. First, open the terminal by clicking the terminal icon located at the top left corner of your screen. Once the terminal opens, type the command sgpt. Now enter the prompt in double quotes as follows. Attempt to try FTP login in 10.0.2.15 with Hydra using users.txt and password.txt from word list. 10.0.2.15 is the target IP address. Press Enter. You will receive a message like, ensure you have permission to perform this action on the target system, as unauthorized access attempts are illegal and unethical. This is an important reminder to always obtain proper authorization before conducting any security testing. Since this demonstration is purely for educational purposes, we will only use test environments where permission has been granted. Now, in our test setup, you'll notice two word lists, users.txt and password.txt. Type the following command, cat username.txt. Press Enter. You will receive a response saying, no such file or directory. This indicates that the file username.txt does not exist in the current directory. Next, type the command cat users.txt. This time, you'll find that the file exists. It will display three usernames, admin, guest, and user. Then, in your terminal, type clear. Before clearing the screen, let us copy the Hydra command, which is Hydra -L users.txt -P password.txt ftp ://10.0.2.15. Now go back to the clear command and press Enter. This will clear the terminal screen for better visibility. Next, paste the copied Hydra command into the terminal. Once you start Hydra, it will begin running a brute force attack simulation. The tool runs without restrictions and does not enforce legal or ethical guidelines. Hydra is executing several tasks in parallel. The output displays the following information. Max 9 tasks per one server. This means maximum of 9 tasks are assigned to a single server. Overall 9 tasks. It means all 9 tasks are currently active. 9 login attempts, 1 try per task. Attacking FTP, ://10.0.2.15:21/. An error message is also displayed. All children were disabled due to too many connection errors. At this stage, no login has been successful. Again, let me emphasize, this demonstration is conducted in a controlled environment and is intended strictly for educational purposes only. Never use these techniques on unauthorized systems. And this is how you can use Shell GPT to automate the command and perform an FTP brute force attack within a safe, legal, and ethical test environment. In this demonstration, we will show how to use Shell GPT for web server and web footprinting. To get started, open the Kali Linux terminal by clicking the terminal icon located at the top left corner of your screen. Once the terminal opens, type the command sgpt-shell and enter the following prompt in double quotes. Give IP address of testphp.vulnweb.com using NSLOOKUP. NSLOOKUP is our tool here. Press enter. It will return a command like this. NSLOOKUP testphp.vulnweb.com. Pipe grep address colon in single quotes. Pipe tail dash small and 1 pipe awk single quote open curly brace print $2 close curly brace single quote. Next, type the letter E when prompted and press enter. You will receive the output 44.228.249.3, which is the IP address for testphp.vulnweb.com. This is how we can perform basic web footprinting using Shell GPT. Now, let's modify the previous command. Use up arrow key to bring back the command and remove --shell. Now the command is sgpt. Inside double quotes we have give IP address of testphp.vulnweb.com using NSLOOKUP. Press enter. You will see a response like this. To find the IP address of testphp.vulnweb.com using NSLOOKUP, you can run the following command in your terminal. The system will then provide the command NSLOOKUP testphp.vulnweb.com along with the corresponding output. This is how you can quickly obtain useful network information using simple commands. Now type clear and press enter to clear the terminal screen. Now type the next command, sgpt, and enter the following query in double quotes. Find web server version using nmap in testphp.vulnweb.com. Press enter. The system will return a typical command like this. nmap-v testphp.vulnweb.com. Simply copy this command and paste it into your terminal to run it. Then press enter. After running the command, the output will have information like nmap scan report for testphp.vulnweb.com. The IP address as 44.228.249.3. The DNS record for the mentioned IP address is EC2-44-228-249-3.us-west-2.compute Amazon AWS.com. This indicates that TCP port 80 is in an open state. The service running on this port is HTTP, served by Nginx version 1.19.0. Let's clear the screen again by typing clear and pressing enter. Now type the next command, sgpt. Then enter the following query in double quotes. Check if Apache 2.4.29 version has some vulnerabilities. Press enter. This is how you can get detailed information about vulnerabilities related to the Apache server version 2.4.29. The system will return a list of common vulnerabilities and exposures, such as CVE 2017-15710, CVE 2018-1301, and CVE 2018-1312. This information is crucial for gathering intelligence during target reconnaissance and penetration testing. Additionally, it will provide links to further resources and detailed reports for deeper analysis. Clear the screen again by typing the command clear and pressing enter. Now type the following command sgpt and enter the following query in double quotes. Perform web technologies detection on testphp.vulnweb.com. Press enter. You will receive a response indicating that. To perform web technology detection on testphp.vulnweb.com, you can use tools like Wapalizer or WhatWeb. If you plan to use WhatWeb, first ensure your system is up to date and verify whether WhatWeb is installed. To install WhatWeb, we can use the commands sudo apt update, sudo apt install WhatWeb. To check if WhatWeb is installed, type whatweb-help. This command will provide you with details on how to use WhatWeb. To run WhatWeb on the target website, you can use the command whatwebtestphp.vulnweb.com. This command provides technology-related details about the target website. It's an effective way to use Shell GPT for website footprinting. In this demonstration, we will explore how to use the Shodan tool to gather information on an IIS, Internet Information Services, server. Shodan is a search engine widely used by ethical hackers and penetration testers. It helps collect detailed information about Internet-connected systems, offering a structured and professional approach to reconnaissance. To begin using the Shodan tool, you need to open the Firefox browser. Open a new tab and type Shodan. Now, press enter. When the search results appear, click on the first link, https://www.shodan.io. Press enter to open the link. You're now on the Shodan homepage. The URL is https://www.shodan.io. On this page, you'll find several options. At the top left corner, you'll find the Explore and Pricing options. The Sign Up button is located toward the center left of the page. At the top right corner, you'll see the Login option. Please note, Shodan offers both free and paid access tiers. If the information you need appears on the first page of results, logging in is not required. However, to access more than one page of results, you must log in. This account is free to create. To view more detailed or extensive data beyond the second page of results, a paid Shodan subscription is required. Now, let's start using Shodan. In the search bar at the top of the homepage, type IIS, as we're specifically looking for IIS server information. Press enter. Shodan will now search for information related to IIS. The search results display information such as 77-89-170-137.fluidata.co.uk. Shodan detected a public IIS server hosted by Fluidata in the UK. Onlineportal.us.com. A publicly accessible IIS-based web portal hosted under the us.com domain, indexed by Shodan. You'll begin to see several results appear on the screen. You can also see information such as media.finleypublishing.com, a public IIS server associated with Finley Publishing, identified by Shodan. EC2-44-233-189-39.us-west-2.com. An IIS server hosted on an Amazon EC2 instance in the US West 2 region, detected by Shodan. Note, while these results appear in a search for IIS servers, we cannot guarantee that all of them are actually running IIS. Some may be using other web server technologies. To inspect a result, click on the small arrow icon next to the first entry. Select Open Link in New tab. Switch to the New tab to view the full details for that entry. You may encounter a login page or system interface from the target system. If this page appears suspicious, untrustworthy, or unexpected, close the tab immediately and return to the previous Shodan results page. To narrow your results, we'll use Shodan's filter functionality. In the search bar, type the following filter command: ssl.ceert.subject search.cn : within inverted commas type IIS, then type 200. Now, press enter. If you're not logged in, you'll receive an error message that says, "Please log in to use search filters." This is because advanced filters require a logged-in account. To log in, click the Login button at the top right corner of the page. Enter your username and password, then click Login again. Once you've successfully logged in, return to the main search bar. Re-enter the same filtered query, ssl.cert.subject.cn : within inverted commas type IIS, then type 200. Then click the search icon or press enter. This filter specifically pulls results related to IIS, Internet Information Services, from SSL certificate data. You'll now see results that may include entries such as IIS Windows Server, Elite, Wrexham Signs Limited Home, IIS Windows Server. This filtering method is similar to Google dorking. Just as Google dorking helps refine your searches for more precise information, Shodan filters allow you to search for specific systems and technologies with high precision. Now, locate the result labeled IIS Windows Server. Click on the small arrow next to it. From the menu, select Open Link in New tab. Switch to the New tab. Here, you'll find detailed and useful information about the IIS Windows Server. This demonstrates how you can effectively use the Shodan tool to gather valuable information on IIS target systems. In this demonstration, we'll be performing directory brute forcing using Shell GPT. In our previous videos, we followed standard manual methods to conduct directory brute forcing. Now, let's explore how to automate this process using Shell GPT. Let's get started. First, open your terminal window. Then, type the following command: sgpt --shell, then within double quotes type the prompt. Perform directory brute forcing on testphp.vulnweb.com using dirbuster. We're using the dirbuster tool to perform directory brute forcing. Press enter. Shell GPT will now generate the dirbuster command, which is dirbuster -u http://testphp.vulnweb.com -usr/share/wordlists/directory-list-2.3-medium.txt. Now, to start the scan, enter capital E when prompted and press enter. Dirbuster will now begin scanning the target URL, http://testphp.vulnweb.com. By default, it uses 10 threads for the scan. If you want to speed up the scan, you can increase the number of threads. But for this demonstration, we'll stick to the default value. Now, locate the Start button near the middle right corner of the dirbuster and click Start to begin the scan. Once the scan begins, you'll notice live status updates in the log window. Dirbuster starts testing for various files and directories based on the selected word list. For example, you might see messages like, "Testing for files with the .php extension 0% complete," or "Scanning for directories inside the images folder 0% complete." These messages indicate that the tool is actively attempting to discover hidden resources on the target web server. As the scan progresses, these percentages will increase, showing the real-time progress of each brute force path. Now, switch back to the terminal window. You'll see that several directories have already been discovered. Some examples include index.php, which returns a 200 OK response, then search.php with a 200 OK, and login.php, which also has 200 OK response. These responses indicate that the tool is identifying valid paths on the target website using brute force methods. Now, go back to the dirbuster interface. At the bottom of the dirbuster interface, you'll see the current number of threads running. By default, this is set to 10. To increase the scan speed, use the text box below the thread count display to change this value. Type 200, then click on Change button. You should see this number begin to rise as the tool processes more requests simultaneously. Note that even if the live display shows 0 requests per second, the average speed typically reaches around 13 requests per second. Now, let's reset the thread count back to 10 and then click on Change. Let's switch back to Terminal. So that's how we perform directory brute forcing using Shell GPT. In this demonstration, we will perform web application attacks like cross-site scripting or XSS and HTML injection. As you may know, cross-site scripting is a vulnerability where a user inputs JavaScript code into a web application's input parameter. The script is executed in the browser and typically triggers alerts or retrieves informational data from a source. Similarly, in HTML injection, a user places malicious HTML payloads into input parameters to extract or inject other types of data. The output of the HTML injection depends on the tag used in the HTML injection payload. To begin, open the Firefox browser. Once Firefox is open, navigate to a new tab and close any previous ones. Now type testphp.vulnweb.com. On this page, locate the first input parameter, labeled as searchart. In the search field, enter a basic XSS payload, which is open a script tag, then type alert within parentheses, open double quotes, type capital A, close double quotes, close the script tag. Then press enter. As you can see, the script executes and an alert box appears with the message capital A. You can click on OK. This demonstrates a successful cross-site scripting attack. This is just one example of an input parameter. You can also find input fields on the sign up or profile pages. Enter your credentials, username, and password in the login fields. Click on the login button. A pop-up may appear prompting you to save your password. You can choose Not Now. If you do not have an XSS payload, follow the next step. Open a new browser tab and search for XSS payloads. Press enter. From the search results, click on the first GitHub link that contains a list of XSS payloads. In the repository, scroll down the page. You will see a comprehensive list of XSS payloads. There are many payloads available. You can copy one and try it in various input parameters on the test site. In this example, we will copy one payload, which is angular bracket image slash src slash on error equals prompt. Inside parentheses type 8, close angular bracket. Paste the copied payload into the name field, then click Update. A pop-up appears with a number 8, which indicates our script executed successfully. You'll also notice that an input box appears. This happens because the payload includes an image tag. Since we're using the prompt function in our payload, the browser displays a pop-up like this. When you use prompt, the browser generates an input box. If you use alert or confirm, the result will differ. Click OK to dismiss the box. Now, for HTML injection, you could try a simple anchor tag like open anchor tag, href equals https://google.com, close angular bracket, then type test, close anchor tag. Click on Update. When you update the page using this payload, you may not see immediate output. So what's happening here? If you look closely, a clickable link labeled Test is now visible. When you click on Test, you are redirected to https://google.com. This works because the anchor tag with the href attribute was used to inject a hyperlink. This is a basic example of how HTML injection works. You can also use other payloads like open button tag, on click equals, inside double quotes, alert, open parenthesis, open single quote, XSS, close single quote, close parenthesis, close angular bracket. Then type submit, close the button tag. Copy this payload. Place this payload in all the input fields and click Update. You may see an error like unable to update user information. You have an error in your SQL query syntax. Check the manual that corresponds to your MySQL server version for the right syntax to use near XSS submit, cc equals submit. Still, when you click the submit button, the XSS alert will appear. This demonstrates that different payloads can be injected into input fields and reflected back in the web application. You can use HTML injection, cross-site scripting, or a combination of both to test input reflection. Now, let's test one more payload. Copy the last payload. Open angular bracket, exclamation mark, dash dash, exclamation mark, close angular bracket. Open angular bracket, h1, value, equals, open double quotes, arrow sign. Open anchor tag, href, equals, open double quotes, JavaScript, alert, open parenthesis, document.domain, close parenthesis, close double quotes, close angular bracket, link, close anchor tag. Paste in the name field and click Update. If you see an error, clear the entries in the other input fields, then click on Update again. Now you should see a clickable link on the page. When we click on the link, the domain reflects the payload due to a reflected XSS vulnerability. This is known as reflected cross-site scripting, where the payload is reflected in the URL and executed. If the payload is stored in the application source or DOM without needing user interaction, it's referred to as stored XSS or DOM-based XSS. In this case, because user interaction is required to trigger the payload, it falls under reflected XSS. And that is how you can perform both HTML injection and cross-site scripting in a web application. In this demonstration, we will explore how to use Shell GPT for detecting a web application firewall or WAF. To perform this detection, we'll be using Shell GPT. Within Shell GPT, we will run a curl command to help determine whether a WAF is in place. Now, type the command sgpt. Then, enter the following prompt within double quotes. Check if https://google.com have WAF in capital using curl. As you can see, it's a simple and direct query. Now press Enter. The output provides information such as to check if a website like https://google.com has a web application firewall, WAF. Using curl, you can look for specific HTTP headers or responses that indicate the presence of a WAF. Here is a basic command to get the headers. Curl -I https://google.com. Copy the command by selecting it. Then press Ctrl-Shift-C to copy. The output also shows. Look for headers like server, xsecurity ID, xcdn, xcache, or any other unusual headers that might indicate a WAF. Additionally, you could try sending requests with unusual patterns or payloads and observe if the response changes, which might suggest WAF activity. However, note that detecting a WAF can be complex and may require more advanced techniques or tools. As we can see, advanced detection may require more sophisticated tools and techniques. What we are showing here is for educational purposes only, not a comprehensive method. Now, paste the curl command you copied earlier. Use Ctrl-Shift-C to paste. The command should look like this. Curl -I https://google.com. Press Enter to run the command. In the output, we can see http://2/301. The HTTP status code is 301, indicating a redirection. The location header will show https://www.google.com. The content type will specify the format of the return data, which is usually HTML. You may also find headers like Content Security Policy Report Only, which tell the browser how to handle the content securely. The date header reflects the current date. The expires header might show a future date, for example, June 15th, 2025. The cache control header explains how and for how long the response should be cached. These headers give us useful clues and context when trying to identify a WAF. That said, this is a basic curl-based technique that does not involve advanced detection methods. We are simply using standard curl commands. So, please remember, this is a high-level overview, not a deep dive. It's meant to provide you with a basic understanding of WAF detection, strictly for learning and exploration. There are also many other tools and resources available on platforms like GitHub, cybersecurity forums, and ethical hacking communities. So this concludes our demonstration on using Shell GPT for detecting a web application firewall. In this demonstration, we'll explore how to use ZenMap for port scanning and service discovery. To get started, open your Kali Linux environment. Next, go to the application menu located in the top left corner of the screen. In the search bar, type ZenMap and press enter. When ZenMap root appears in the search results, go ahead and select it to open the application. A pop-up window will appear asking for authentication. Simply enter your password in the field provided, then click Authenticate to continue. Once it's successful, ZenMap will launch automatically. Now, you'll see the ZenMap interface displayed on your screen. ZenMap is the graphical user interface, or GUI version of Nmap. You might have used Nmap before. It's a popular command line tool used for network scanning. ZenMap works similarly, but with a graphical interface that makes it more accessible and easier to use. With a GUI, you interact using menus, buttons, and windows instead of typing commands. It is perfect for those who prefer a more visual approach. Within ZenMap, you'll notice several menu options located in the top left corner of the interface. Let's explore a few of them. Scan option on the top left. Under the Tools menu, you'll find helpful features like compare results, search scan results, and filter hosts. In the Profile menu, you'll see options such as New Profile or Command and Edit Selected Profile, great for customizing your scans. The Help menu includes options like Report a Bug, in case you run into any issues. And under the Scan menu, you'll find actions like New Window, Open Scan, Save Scan, and many other useful commands. These menus make it easier to navigate ZenMap's features without needing to remember command line syntax. To start scanning, go to the Target field in the top left corner of the ZenMap window. Type the target IP address. In our case, it is 10.0.2.15. You can also enter a range of IP addresses if you're scanning multiple hosts within a network. Next, move to the Profile drop-down menu at the top right of the screen. Here, you'll find a list of predefined scan types, such as Intense Scan plus UDP, Ping Scan, Quick Scan, and many more. For this demonstration, we're using the default selection, Intense Scan. Now, go to the Command field just below the Target field. Here, you'll need to make a small change. Replace -T4 with -V. The -SV option stands for Service Version Detection. So the final command will be nmap -s V -A -v 10.0.2.15. This not only identifies open ports, but also detects the version of services running on them. Once you've made the change, click the Scan button located at the top right of the screen to begin the scan. In just a few seconds, you'll see the scan results begin to populate on the screen. If you encounter a scanning error, it's often caused by an extra -s being added to the command automatically. Simply remove that part from the command field, then click Scan again to restart the process. The scan has restarted and is now running smoothly and much faster compared to using Nmap directly. ZenMap provides a quicker and more user-friendly experience. In the output, you can see completed ACK acknowledgement, scan at 256, 0.03 seconds elapsed, 1,000 total ports. It also clearly shows which services are open. For example, services like DSF and SCO sys mgr are actively running on the specified IP address. And that's how you use ZenMap in Kali Linux for port scanning and service discovery. In this demonstration, we'll explore how to use the dig and lbd commands for web footprinting and identifying load balancers. These tools are commonly used during the reconnaissance phase to detect load balancers, giving us insight into the target's infrastructure before we dive into deeper scanning. To get started, open up your Kali Linux and launch the terminal by clicking on the terminal icon in the top left corner. Now, type the following command: dig google.com. The dig tool comes pre-installed in Kali Linux, so there's no need for any additional setup. In this demonstration, our target is google.com. Once you've typed the command, press enter to run it. As you can see in the output, we've retrieved information about the target. The domain resolves to debiangoogle.com, and the IP address is 142.251.43.110. That's how you use the dig command to gather basic DNS information about a target. Now, type the clear command and press enter to clear the terminal screen. Now, type the following command: dig ns google.com. Then press enter. This command gives you more detailed information about google.com, specifically the name servers associated with the domain. Unlike the previous dig google.com command, which only gave us a single IP address and basic DNS info, dig ns google.com command helps us identify the authoritative name servers and any name records or additional IPs linked to the domain. For example, ns1.google.com. The dig command is used to perform DNS lookups. It helps identify multiple IP addresses linked to a single domain, which can reveal DNS-based load balancing. This makes it a helpful tool for footprinting during reconnaissance, as it shows how traffic is distributed across different servers. Now, let's move on to our second tool, LBD. First, type the clear command to clean up the terminal. LBD stands for Load Balancer Detector. It's a simple tool that checks whether a website is using load balancers. Now type the following command: LBD google.com. Press enter to run the tool. In the output, you'll see that we're using Load Balancing Detector version 0.4. It says, checks if a given domain uses load balancing. Written by Stefan Beat. Proof of concept might give false positives. Always verify results manually. LBD works by analyzing DNS records, HTTP headers, and cookies. If it finds variations in responses across multiple requests, that often indicates load balancing. This makes LBD a useful tool during footprinting and reconnaissance. In the output, you will also see that GWS is detected, but nothing is found. Next, the tool begins checking for HTTP load balancing. You'll notice dates around the series of timestamps in the output, such as 6 hours, 40 minutes, and 21 seconds, 6 hours, 40 minutes, and 21 seconds, 6 hours, 40 minutes, and 22 seconds, 6 hours, 40 minutes, and 22 seconds, 6 hours, 40 minutes, and 23 seconds, and so on. These show the sequence of HTTP requests being made for analysis. And that's how you can use the LBD and dig command for load balancing detection and web footprinting. In this demonstration, we'll use Shell GPT for website mirroring. Let's begin with a quick understanding of website mirroring. In website mirroring, attackers replicate a website's server data, including web applications, assets, and other resources, onto a separate device. This replicated data can then be used for malicious activities, such as social engineering attacks like phishing, or to study the site structure, behavior, and potential vulnerabilities in an offline environment. To perform website mirroring using Shell GPT, follow these steps. First, open your terminal window. Next, type the command sgpt. Then, type the following prompt within double quotes. Perform website mirroring on testphp.vulnweb.com. Then, press enter. Shell GPT will now generate a complete and structured command for you, using the wget tool to perform website mirroring. wget --mirror --convert -links -adjust -extension -page -requisites -node -parent http://testphp.vulnweb.com/. Before proceeding, you'll see a message reminding you to ensure you have permission to mirror the website, as this can be considered intrusive or against terms of service for some sites. In this example, we're using a test website for educational purposes. So, we do have permission to proceed. Copy the command by pressing Ctrl-Shift-C. Now, paste the copied command into your terminal. Do this by pressing Ctrl-Shift-V. Then press Enter to execute the command. The website mirroring process has now begun. On your screen, you'll see terminal output indicating that data is actively being downloaded from the target website. For demonstration purposes, we are now stopping the process by pressing Ctrl+C. This interrupts the command and halts the download. Let's take a moment to review the top portion of the output. First, you'll see the start time and date of the operation. Next is the target website, http://testphp.vulnweb.com. You'll also see the resolved IP address, 44.228.249.3, confirming that the domain name has been translated successfully. The terminal then shows an HTTP request being sent, followed by a response code, such as 200OK, which indicates that the resource was successfully retrieved. The mirrored content is being saved to a file labeled testphp.vulnweb.com/index.html. This file is stored on your local system, allowing offline access to the mirrored version of the site. The last modified header is missing from the response, so timestamping is turned off. We also observe that the system saves the scanning results into a local file for future review and offline accessibility. You may see a message about loading robots.txt. Please ignore any related error messages. They do not affect the mirroring process. You may also see messages like error 404, not found. These are common and usually happen due to authentication requirements or site restrictions that block certain content from being copied. We can also find the file, http://testphp.vulnweb.com/style.css. The file, testphp.vulnweb.com/style.css, has not been modified on the server, so it won't be downloaded again. And that's how you can perform website mirroring using Shell GPT. All you need to do is provide a clear and appropriate prompt, and Shell GPT will generate the exact command required to mirror a website efficiently. In this demonstration, we will explore how to identify server-side technologies using the Shell GPT tool. To begin, open Kali Linux terminal by clicking on the icon located at the top left corner of the screen. To use Shell GPT for basic web fingerprinting, follow these steps. First, open your terminal and type the command sgpt-shell. Then, enter the following prompt in double quotes. Run curl to fingerprint https://google.com. Here, google.com is the target website. Press enter. In just a few seconds, Shell GPT will return a command like curl -I https://google.com. Now type E and press enter. You'll receive a response showing server-side information about your target. In this response, you can see the location, also known as the host, which is our target, https://www.google.com. The content type is listed as text/HTML. You'll also find the Content Security Policy Report only header. This includes rules like object-src none and base-URI self, which help control what resources can be loaded and from where. So this is how you can gather server-side technology details using the curl command. Type the following command to clear the terminal screen. Clear, then press enter. Next, type the following command, sgpt-shell. Then, enter the following prompt in double quotes. Run nmap to fingerprint https://google.com. Press enter. Shell GPT will respond with a command like nmap-p 443-script ssl-enum-ciphers -P google.com. This command means -p 443 specifies the port number, -script ssl-enum-ciphers runs an SSL cipher enumeration, and -pn tells nmap to skip the ping check. Now type E and press enter. Nmap will begin scanning, and you'll start seeing server-side technology details from the target. So, as you can see, Both Nmap and curl can be used to gather server-side information, but they serve different purposes and give different types of output. With Nmap, you can target a specific port, in this case, port 443, and get detailed results based on that. It also shows supported TLS versions, such as TLS 1.0, TLS 1.1, and TLS 1.2. This is how you can extract deeper server-side details using the nmap command. Now, let's clear the terminal again by typing clear. Now type the following command, sgpt. Then, enter the following prompt in double quotes. Search crt.sh for subdomains for certificate data of testphp.vulnweb.com. Here, testphp.vulnweb.com is the target. Press enter. At this point, you might notice an issue, so it's important to include proper syntax. To fix that, just bring up your previous command by pressing up arrow and close double quotes at the end. Since we didn't use -- shell this time, the prompt doesn't execute as a command. Always make sure to use double quotes around your prompt and include -- shell when needed. Again, bring up your previous command by pressing up arrow and add -- shell after sgpt. Press enter again, and now you'll see a suggested query or script generated by shell GPT. Let's stop here for a moment by entering A when prompted to abort the execution. Let us now copy the command. https://crt.sh/?q is equal to &25.testphp.vulnweb.com. Now, clear the screen again and type curl-s and enclose the copied URL in double quotes. So the final command should be curl-s inside double quotes type https://crt.sh/?q is equal to &25.testphp.vulnweb.com. Once executed, you'll receive detailed metadata or certificate data from crt.sh for the target domain. This is how you can explore server-side certificate information using shell GPT and the curl command in combination with crt.sh. In this demonstration, we'll explore username enumeration in WordPress. Username enumeration is the process of discovering valid usernames by exploring databases or specific entry points to gather sensitive information about the target system. To enumerate usernames, you typically need access to data points that are closely tied to the database, making it easier to extract usernames. In WordPress, many data points are interconnected. One key entry point is the admin panel, commonly known as WP-admin. To begin, open Kali Linux and launch Firefox by clicking the Firefox icon located in the top left corner of the screen. Open a new tab and in the search bar, type https://indini.com/wp-admin. Then press enter. You'll see the WordPress login page. Now try logging in using a common username and password, for example, root as both username and password. You'll get an error message saying, incorrect username or password. Next, click on Lost Your Password. Here, we can test different usernames to see how the system responds. Try entering root. You'll get a message saying the username doesn't exist. Try Indini. Same result, it's not valid. Now enter Josh. This time, the message changes. Check your email for the confirmation link. This tells us Josh is a valid username. And that's how you can perform username enumeration in WordPress by observing how the system reacts to different inputs. As you can see, there's a clear difference in the output when trying incorrect versus correct usernames. When you enter an invalid username, the system simply responds with incorrect username or password. But when you enter a valid username, the message changes to check your email for the confirmation link. This confirms that the username exists in the system. For example, if we try Josh as the username and guess the password, Josh@123, we still get an error, but we now know that Josh is a valid username, thanks to the response we saw earlier on the password reset page. This is how username enumeration works on the WordPress admin page. To try this yourself, you only need to know that the target website is built with WordPress. Then, just add wp-admin at the end of the URL to access the login page. From there, you can begin testing usernames and analyzing the system's responses. And that's how you identify valid usernames in WordPress using simple enumeration techniques. In this demonstration, we will explore how to use Burp Suite to identify and test data entry points in a web application. Data entry points are locations in a web application where data can be retrieved or modified. These typically include URL paths or parameters that interact directly with a backend database. Let's get started. First, open Kali Linux. Now, launch the Firefox browser by clicking on the icon on the top left corner of the screen. Once it opens, open a new tab and close the previous one. Next, open Burp Suite. To do this, go to the top left of your screen, open the Applications menu. In the search bar, type Burp Suite. When the search results appear, click on Burp Suite to launch it. Once the Burp Suite window appears, a pop-up will show up. Click Next, and then select Start Burp. Give it a moment. It may take a few seconds to fully load. Once Burp Suite is open, the first step is to check the proxy settings. To do this, click on the Proxy tab in the top menu bar. Now, confirm that the IP address is set to 127.0.0.1 and the port number is 8080. Once everything looks correct, go ahead and close the window. Now, switch back to Firefox. Click the three horizontal lines in the top right corner to open the menu. From the drop-down, select Settings. In the Settings search bar, type Proxy. Scroll down to find Manual Proxy Configuration. Here, make sure the IP address is set to 127.0.0.1 and the port is 8080, matching the settings in Burp Suite. Once that's done, close the window and open a new tab in Firefox. Type the following in the address bar: testphp.vulnweb.com. Then press Enter. As we discussed, data entry points are input fields or URL parameters that interact with the database. Now, go to Burp Suite and make sure Burp Suite's intercept is turned on. Return to Firefox and refresh the page by clicking the refresh icon on the left of the address bar. You will see that Burp Suite has captured the request under the Proxy tab. Then, right-click anywhere on the capture request and choose Send to Repeater. In Burp Suite, click the forward button beside the intercept to send the request through. Go back to the test website and locate Search Art option on left sidebar. In the search bar, type Test, then click Go. Burp Suite will capture this new request. Right-click on the capture request and choose Send to Repeater. Click Forward again, then turn off the intercept. Finally, navigate to the Repeater tab, which you'll find just to the right of the Proxy tab. You will now see two requests listed. The first one is a general request. The second one includes URL parameters, which are potential data entry points. Click on the first request. You'll notice it doesn't contain any parameters. Since admin is a commonly used parameter on many websites, type admin on the first line, right after the first slash, to create an admin parameter. Now your first line should read as get/admin http/1.1. Now click on Send to send a request. Burp Suite will display the response. 301 moved permanently. Click on Follow Redirection on the right of the Send button to reveal a page referencing create.sql. This likely indicates a database file. This demonstrates how testing parameters can help uncover hidden files or admin pages. Let us now switch back to Firefox. In the address bar, replace search.php test equals query with admin. Then press Enter. You'll now see a SQL file containing backend data. This is a clear example of how Burp Suite can be effective in identifying sensitive paths. Now, return to the second request in the Repeater tab of Burp Suite. This request contains two parameters, query and search. Focus on the search parameter. It's the one we'll be testing. The query parameter is more common and typically less vulnerable to SQL injection. Next, switch back to Firefox and open a new tab. In the search bar, type SQL cheat sheet and press Enter. From the search results, locate the official Portswigger link, https:// portswigger.net. Click on the link. Once the portswigger page opens, scroll down and copy a basic SQL injection payload, such as select *from information_schema.tables. Now return to Burp Suite. In the Repeater tab, find a search parameter field and paste the payload into it. If the payload appears as plain text, without any syntax highlighting, add plus signs between the keywords to encode it for the URL. For example, select +*+from +information_schema.tables. This makes it URL friendly and readable by the server. Once your payload is ready, click Send to submit the request. When we send this payload in Burp Suite, we receive a 200 OK response. This means the request was processed successfully. Now, scroll to the bottom of the response. You'll see a message that says, "This is not a real shop." This confirms that the target site is a deliberately vulnerable PHP application, built specifically for testing and learning purposes. It's a warning built into the app to let users know that the environment is intentionally insecure. Now, let's validate this same behavior in Firefox. Open Firefox. Before testing the payload, navigate to the test website. In the URL bar, remove the part that says /admin/ from the address. Then press Enter. Once the page loads in Firefox, locate the search field in the left sidebar. Paste the same SQL payload you used earlier into the search box. Then, click the Go button or simply press Enter. You'll notice that nothing happens. There's no visible change or result on the page. So, let's try another payload now. Select *from information_schema.columns, where table name equals table name here. Copy this payload from the SQL injection cheat sheet, just like we did before. Paste it into the query parameter in Burp Suite. Once you paste the modified payload into the query field, add plus signs between the keywords to encode it for the URL. For example, select +*+from +information_schema.columns +where +table name +equals +table name here. You'll notice that everything appears in red color. This color highlighting in Burp Suite indicates valid syntax and that the payload has been properly formatted. Click Send to execute the request. Look at the HTTP response code. It still says 200 OK, which usually means the request succeeded. However, this time, you'll also see an error message in the response body. If you encounter an error here, it's important to verify the behavior directly from the test site. https://testphp.vulnweb.com. Paste the same payload into the search bar on the left sidebar. Then press Enter or click Go. If the same error appears in the browser, it confirms that your SQL injection attempt has triggered a response from the backend, possibly exposing an exploitable vulnerability. This confirms a SQL injection vulnerability in the application's data entry paths. In the Burp Suite, the Repeater tab is valuable because it allows you to try multiple payloads using trial and error. Next, we'll test the signup parameter. On the test site, click on Sign Up, located in the left sidebar. For both the username and password, type root. Now, switch to Burp Suite and make sure Intercept is turned on. Return to the test site and click Login. Go to Burp Suite. You'll see the request is now captured in Burp Suite's Proxy tab. Right-click anywhere on the request and select Send to Repeater. Then, right-click again, hover over Do Intercept, and click Response to this request. Let's now turn Intercept off. Now, review the response. You should see 302 found. This indicates a redirection, but we're not logged in. That's because we used root for both username and password, which are incorrect. The correct credentials are actually test and test. Let's try an SQL injection payload instead. Go back to Burp Suite and click on Repeater tab. In the last line, replace both the username and password with the following payload. Open single quote plus capital or plus, close single quote, +1 = 1. Use the same payload in both fields. Click Send. If the injection is successful, you'll receive a 200 OK response and see a message like 0 items in your cart. This means the login was bypassed. Now try logging in directly from the web browser. Paste the same payload in both the username and password fields on the login page. If you get an SQL error, remove the plus signs. Plus signs are needed in Burp Suite, but not for direct input in the browser. So input will be open single quote, capital, or close single quote, 1 equals 1. Once adjusted, the login will be successful. And that's how you can use Burp Suite to identify data entry points and perform basic SQL injection testing to uncover vulnerabilities in a website. In this demonstration, we'll use SQL Map to perform SQL injection testing. SQL Map is a widely used and highly powerful tool for SQL injection. It supports numerous advanced options and includes potentially destructive flags that can be used to test SQL injection. This tool is particularly effective for discovering critical security flaws in web applications. To begin, open your terminal by clicking the terminal icon in the top left corner of the screen. Since SQL Map comes pre-installed on your system, let's check its options. Type the following command: SQL Map-h. This will display a list of available options and flags. The general usage syntax for SQL Map is Python 3 SQL Map, square bracket open, options, square bracket close. However, if Python 3 is already installed and linked with your subsystem, you can simply run SQL Map, followed by the necessary flags. Some useful flags include --version to display the program's version and exit, then -v, capital verbose, to set verbosity level from 0 to 6, and -u or --small URL specifies the target URL, such as http://www.site.com/vuln.php ID equals 1. In this example, the URL includes a parameter, ID equals 1, which SQL Map will test for SQL injection vulnerabilities. You can also explore additional SQL Map flags, such as -g for Google dorking, --data to supply post data, -dbms to specify the backend database type, --level to set the level of tests to perform, and -risk to adjust the risk levels of the tests. Be cautious with the risk and level flags. You can increase or decrease these levels, but the default risk level is 1. Levels 1 or 2 are generally safe. Avoid setting them to higher values, like 3 or 5, as this can potentially harm the target website. Other helpful flags include -dbs to enumerate available databases, -dump to retrieve database tables and entries, and -batch to skip user inputs and automatically use default choices. Using -batch is especially useful for automated testing, where you don't want to be prompted at each step. Finally, clear the terminal again by typing the command clear. Now, we will demonstrate an actual injection using SQL Map. Now type the following command: SQL Map-u. To get the URL, open Firefox by clicking on the icon on the top left of the screen. Now open a new tab and close the previous one. In the address bar, type testphp.vulnweb.com. Then press enter. Once the site opens, click on Browse Artists from the left sidebar. Now, copy the URL from the address bar. It should look like testphp.vulnweb.com/artists.php. Now, navigate back to the terminal. Paste the URL after the -u flag in your SQL Map command, and then type the following flags: -batch, -risk2, -level2, -crawl2. Here's what each part does. -batch auto-confirms all prompts using default answers. -risk equals 2, -level equals 2, and -crawl equals 2 increases the depth and risk of scan. Then press enter. You'll notice the message. Do you want to check for the existence of sites? Sitemap? Type in, press enter. Once the scan begins, you may see a prompt asking for the number of threads. Type 1, since we haven't specified it manually. As the scan continues, you'll start seeing results appear on the screen. Eventually, SQL map will display. SQL injection vulnerability has already been detected against testphp.vulnweb.com. Do you want to skip further tests involving it? By default, the answer is Y, which skips repeated testing for efficiency. Here, you can see that payloads are provided. You need to test these payloads manually to confirm the SQL injection. And this concludes our demo on SQL injection testing. In this demonstration, we'll use Shell GPT in Kali Linux to assist with SQL injection attacks, specifically by working with the SQL map tool. Let's get started. First, open Kali Linux and click on the terminal icon located in the top left corner of the screen. Now we're ready to interact with Shell GPT. In the terminal, type the command sgpt. Then, within double quotes, enter the following prompt. Give me basic command of SQL injection vulnerability. Then, press enter. You'll notice that Shell GPT responds with a basic SQL injection payload, which often uses a single quote. This kind of payload is designed to test for vulnerabilities by injecting a single quote character at the end of a URL. For example, http://example.com/page?id equals 1, then single quote. Next, you'll see a classic payload, or 1 equals 1. This is used to bypass authentication or extract data from a vulnerable database. For example, single quote or 1 equals 1 semicolon dash dash. Following that, Shell GPT may suggest a union select payload. This is used to extract data from other tables in the database. For example, single quote, union select, username, password from users semicolon dash dash. To complete the SQL injection, we use the commenting out operator, which is a double dash. This tells the SQL engine to ignore the rest of the original query. So the full payload looks like this. Single quote or within single quotes 1 equals within single quotes 1 dash dash. Lastly, we see a blind SQL injection payload that uses conditional statements to infer data. Let's clear the screen again. Type clear and press enter. Now, we need a target URL to test our SQL injection payload. Start by opening Firefox. Click on the Firefox icon located in the top left corner of the screen. Once it opens, open a new tab and close the previous one. In the address bar, type testphp.vulnweb.com. Then, press enter. When the site loads, look to the left-hand sidebar and click on Browse Artists. Next, go to the address bar and copy the full URL. Now, switch back to the terminal window. Type the following command, sgpt-shell. Then, enter the following prompt within double quotes. Give me basic SQL injection and paste the copied URL, http://testphp.vulnweb.com/artist.php and use dash dash batch and dash dash crawl2. Then press enter. Let's type clear and press enter. Let's bring back the command by pressing up arrow and close the prompt by inserting double quotes at the end. Now press enter. Once the command appears, type E to execute it. SQL map begins executing the injection process on the target URL. Because we included the flags dash dash batch and dash dash crawl2, SQL map will automatically accept default options without prompting for user input and crawl up to 2 levels deep to discover additional injectable links. This allows for a smooth execution of the SQL injection scan. And that's how you can perform SQL injection using Shell GPT integrated with SQL map in Kali Linux. In this demonstration, we will use Shell GPT to perform SQL injection. Let's begin by opening the terminal window. Now, type the following command, sgpt. Then, enter the following prompt within double quotes. Give me latest CVE for SQL injection. Then, insert dash dash shell before the prompt and press enter. Once the response is generated, type E to execute the command. After execution, review the output carefully. In the output, you'll see Synchro 3.0.1.20 for social network message menu SQL injection. Alongside this, a URL reference will appear like php/webapps/36151.txt. Now go ahead and copy Synchro 3.0.1.20. Next, open Firefox browser. Once the browser opens, open a new tab and close the previous one. Paste the copied URL into the address bar and press Enter to load the page. This page links to the latest SQL injection CVE details on https://www.exploit-db.com. We can use this reference to better understand how SQL injection attacks are constructed. Now, return to your terminal window. Let's clear the screen again for a fresh view. Type the command clear and press Enter. Next, we will generate a SQL injection payload for a numeric-based input field. Start by typing the command sgpt. Then, enter the following prompt within double quotes. Write a SQL injection command for numeric-based. Once done, press Enter. After executing it, switch to Firefox. You'll see the entry for Synchro 3.0.1.20 Social Network Message Menu, SQL injection. Scroll down the page to view more detailed information. Now, we'll move on to the next command. Return to your terminal window and type sgpt. Then, enter the following prompt within double quotes. Write an error-based SQL injection payload for numeric parameter. Press Enter. At this point, you may receive a message that performing or promoting a SQL injection attack is unethical and illegal. This is a standard legal disclaimer issued by the tool to ensure ethical usage. Let's try modifying the prompt slightly. This time, write an error-based SQL injection payload for a numeric parameter. Then press Enter again. You'll notice that Shell GPT now returns a valid result without the legal warning. This happened because we added the word a between for and numeric in the prompt. The rest of the command remains the same. This subtle change demonstrates how Shell GPT interprets prompt variations and how slight wording differences can impact the response. Therefore, it's crucial to use a precise and well-structured prompt when working with your commands. By observing the differences in the outputs generated from various prompts, you gain valuable insight into how to effectively leverage Shell GPT for exploring SQL injection techniques, always within legal and ethical boundaries. This demonstrates how you can utilize this functionality effectively. In this case, we now have single quote capital or 1=1 union select 1 at version 3-. This is the output for an error-based SQL injection payload for a numeric parameter. You've now seen how to generate SQL injection payloads using Shell GPT. And that concludes our demonstration. In this demonstration, we'll explore how to detect hidden SSIDs. SSID stands for Service Set Identifier. It's the name given to a Wi-Fi network, such as your home network or any nearby wireless connection. The SSID helps distinguish one network from another within the same area. To detect hidden SSIDs, we'll use two tools from the Aircrack NG suite, Airmon NG and Aero Dump NG. To begin, open the terminal by clicking the terminal icon located in the top left corner of the screen. Now, move your cursor to the top left menu, click on Devices, then hover over USB and check if your Wi-Fi adapter is connected. Finally, go to the top right corner of the screen, click on the network icon, and verify that you're connected to a network. Now type the following command, airmon-ng. Press Enter. You'll notice that it runs with root privileges. Next, type the command, sudo airmon-ng. When prompted, enter your password. You should now see that the network interface is connected on WLAN 0. Type clear to reset the terminal screen. Now, enter the following command, sudo aero dump-ng WLAN 0. Since this command requires root privileges, we use sudo. The network interface is connected on WLAN 0. Once the command runs, you'll begin to see a list of SSIDs. For example, we can see an SSID D6 colon 3D colon 60 colon 0 6 colon 67 colon 80, with new ones updating every few seconds. In the output, you can observe various SSIDs along with their corresponding stations. Keep in mind, this process may take some time as it scans for your network and detects other Wi-Fi devices nearby. This is how you can detect hidden SSIDs in Kali Linux using AirmonNG and AeroDumpNG. In this demonstration, we will explore how to perform ARP poisoning attack using EtherCap on Kali Linux. To get started, open Kali Linux and launch the terminal by clicking on the terminal icon in the top left corner of the screen. First, type the command clear to clean up the terminal. EtherCap is a powerful network scanning and interception tool, widely used for man-in-the-middle attacks. It allows you to intercept and manipulate data flowing between two devices on the same network. With EtherCap, you can sniff network traffic, monitor active connections, manipulate packets, and analyze complete traffic data. Since EtherCap comes pre-installed with Kali Linux, launching its graphical interface is simple. In your terminal, type the command EtherCap -G, then press Enter. You'll now see the EtherCap graphical user interface. Next, we need to set your active network interface. To do that, open a new terminal window and type the command ifconfig, then press Enter. From the output, locate your IP address. In this example, it is 10.0.2.15. Once you've identified your interface, return to the EtherCap window to continue configuration. Navigate to the primary interface selection dropdown. From the list, select F0. Next, click on the checkmark icon in the top right corner of the EtherCap window to confirm your selection. At this point, you might see a message on the terminal that says, "You do not have permission to perform this capture on that device. Socket : operation not permitted." To fix this, we need to use sudo command. Now, in the terminal type, sudo EtherCap -G. Press Enter. Once EtherCap launches again, go back to the interface selection dropdown. Once more, select F0 and click the check mark to confirm. Once EtherCap restarts with sudo privileges, you'll see that it begins scanning automatically. It's important to always launch EtherCap as root using the sudo command. Otherwise, it won't have permission to capture packets and you'll encounter an error. Now, you'll see some key information displayed on the screen. In this example, 08:0:0:27:04:42:0F is the MAC address. 10.0.2.15 is the IP address. And 255.255.255.0 is the gateway range. EtherCap also provides details such as 34 plugins. These are small scripts that extend EtherCap's functionality. 42 protocol dissector, which EtherCap can recognize, interpret, and manipulate. Along with this, you'll find various other network and protocol details. To view the available plugins, navigate to the top right corner and open the three-dot menu. This is the EtherCap main menu. From the drop-down, select Plugins, then choose Manage Plugins. You'll now see a list of all available plugins. Now, let's scan the network for active hosts. Go back to the three-dot menu. Select Hosts, then click on Scan for Hosts. EtherCap will now begin scanning the network. Once the scan is complete, you'll see a message confirming that 2 hosts have been added. To view these discovered devices, return to the Host menu and click Host List. You'll now see a list of IP addresses representing the devices detected on your network. Click to select the first host, then choose Add to Target 1. Next, select the second host and click Add to Target 2. In the log section, you should now see messages like Host 10.0.2.2 added to Target 1, Host 10.0.2.3 added to Target 2. Now, let's set up ARP poisoning. Open the three-dot menu once again. Click on Targets, then select Current Targets. Here, you'll see Target 1 and Target 2 listed. You can also manually add or remove targets from this window. To add one manually, click the Add button. Then enter the IP address of the device you want to target. Now, let's begin the ARP poisoning attack. Click on the MITM menu, which is located just to the left of the three-dot menu. From the drop-down, select ARP poisoning. A dialog box will appear with a few options. Here, make sure to check the option labeled Sniff Remote Connections. Once selected, click OK to proceed. You'll now see a message in the log section that says, ARP poisoning victims, Group 1 and Group 2. To check whether ARP poisoning was successful, go back to the plugins on the top. Find and double-click on CHK_poison to check poisoning. A status window will appear at the bottom of the EtherCap interface. You should see the message, Poisoning process successful. For additional confirmation, you can check the MAC addresses of the targeted hosts using another device on the network. If one of the devices now displays the attacker's MAC address instead of the expected one, that confirms the ARP poisoning attack was successfully executed. And that's how you perform an ARP poisoning attack using EtherCap on Kali Linux. In this demonstration, we'll learn how to use the AirCrackNG tool to crack the password of a WPA2 secured Wi-Fi network. To begin, open the terminal by clicking the terminal icon located in the top left corner of the screen. Now, type the following command, sudo su, then press enter. This ensures that your system is running with root privileges. Let's now clear the screen using the clear command and press enter. Next, type the following command, airmon-ng, and press enter. You'll notice that the wireless interface is listed as WLAN 0. Now, type the following command in the terminal, airdump-ng WLAN 0. Then press enter. This will begin scanning for nearby Wi-Fi networks. As the scan runs, you'll start seeing a list of SSIDs along with their associated stations appearing in real time. Our target in this case is the SSID labeled test user. Once you've identified the target, copy the SSID, then press Ctrl+C to stop the scan. Now, type the following command in the terminal, aerodump-ng -C6-w aerodump1-d and paste the SSID, then type WLAN 0 to begin scanning for available wireless networks. Let's break this down. -C6 specifies the channel number, which is channel 6 in our case. -w aerodump1 tells the system to save the captured data using the file name aerodump1. -d SSID is where you paste the target SSID you copied earlier. Finally, WLAN 0 is our network interface. After pasting the command, press enter. The scan begins, and once a station appears, it indicates that a device is connected to the target network. Now switch to another tab in Kali Linux and open a new terminal window by clicking the terminal icon again. First, gain root access by typing sudo su. Enter your password if prompted. Then, clear the screen again by typing clear command. Next, enter the following command, airplay-ng -d auth0-a 6e:47:c8:b4:70:25-c 68:b9:d3:6f:-a5:4e WLAN 0. Here, 6e:47:c8:b4:70:25 is the target address. 68:b9:d3:6f:-a5: for E is the channel, and WLAN 0 is the network interface. Press enter to start the deauthentication attack. You'll see the process running rapidly. This attack quickly deauthenticates the client and helps capture the handshake with the target. You can verify the handshake by switching to the first tab of the terminal. Here, you should see that the WPA handshake has been successfully captured. Now return to the previous tab and press Ctrl+C to stop the process. Now type the command ls and press Enter to list the files and verify the handshake capture. Our capture file is named arrowdump-01.cap. Now, open the capture file with Wireshark by typing the following command: Wireshark arrowdump-01.cap. This will open the Wireshark application, where you can analyze the captured network traffic during the session. This is how you perform network sniffing on the target system. Now close Firefox. Then, clear the terminal screen by typing clear and pressing Enter. Now, type the following command: aircrack-ng arrowdump1-01.cap -w password.txt. Here, arrowdump-01.cap is the capture file, and -w password.txt specifies the word list file for password cracking. Press Enter to start the process. Once successful, you will see the key displayed, confirming that the WPA2 password has been cracked. This is how you perform WPA cracking using aircrack-ng. In this demonstration, we'll perform a MAC spoofing attack using Kali Linux. To begin, make sure you've connected a wireless adapter to your system. If the adapter is not yet connected, go to the Devices menu in Kali Linux, then select USB and check MediaTek 802.11n WLAN. Once enabled, you should see available Wi-Fi networks listed in your system's network manager. Now, open the terminal by clicking the terminal icon at the top left of your screen. Type the first command in the terminal, ifconfig, then press Enter. You will see a list of network interfaces. LAN 0. This represents your wireless network interface. Below that, you'll find the MAC address. For example, ether 00:2D:8C:5E:B3. Copy this MAC address. Then, open any text editor and paste the MAC address there for future use. Let's now clear the screen by typing the clear command and pressing Enter. Next, switch to root mode. Type the command sudo su, then press Enter. When prompted, enter your password. Once you're in root mode, clear the terminal screen again by typing clear, then press Enter. Next, to begin changing the MAC address, bring the wireless interface down. Type the following command: ifconfig WLAN 0 down, then press Enter. Next, run the command ifconfig, then press Enter. You'll notice that WLAN 0 is no longer active. Only F0 and possibly LO are available. Clear the screen once more by typing clear and press Enter. Now, we'll set a new MAC address. Type the following command: ifconfig WLAN 0 hw ether. Then copy and paste the MAC address which was saved in your text file, which was 00:E0:2D:8C:5E:B3. Here we will modify the original MAC address slightly. For example, change 00 to 20 and E0 to E1 to create a new spoofed address. Press Enter to execute the command. If there are no errors, the MAC address has been successfully updated. Now bring the wireless interface back up by typing ifconfig WLAN 0 up, then press Enter. This reactivates the WLAN 0 interface. To keep the terminal clean, type clear and press Enter to clear the screen. To verify the change, run the command ifconfig, then press Enter. You should now see the new MAC address. For example, 20:E1:2D:8C:5E:B3. Now open the text file where you save the original MAC address. You'll see it was something like 00:E0:2D:8C:5E:B3. This confirms that the MAC address has successfully changed. Please remember, this change is temporary. If you restart the terminal or your virtual machine, the original MAC address will be restored. And that's how you can perform MAC spoofing in Kali Linux. In this demonstration, we'll use the GoFish tool within the Kali Linux environment. GoFish is a phishing simulation and social engineering tool, and it comes pre-installed in your Kali Linux setup. To begin, open your terminal by clicking on its icon located at the top left corner. Now, Type the following command: gofish-h. Then press enter. GoFish will begin running, and you might be prompted for administrator privileges. At this point, you need to manually enter your virtual machine's password. Once authenticated, a browser window will open automatically, directing you to the following link: https://127.0.0.3333/login?next equals %2f. Here, 127.0.0.1 refers to your local host, and port 3333 is the default port used by GoFish to run its web interface. You'll be directed to the login page. The default username is admin. For first-time use, you'll be asked to create a password. The default password is Cali-GoFish. Enter all the credentials and click on Sign In. A prompt appears asking whether to update the saved password with the entered username. I am choosing the Don't Update option. You'll now see the GoFish dashboard, which features a simple graphical user interface. On the left-hand side of the dashboard, you'll find a main navigation menu with the following sections: Campaigns, where you can create and manage campaigns; Users and Groups, to organize your targets; Email templates for crafting phishing emails; Landing pages for redirecting users. In this demo, let's focus on creating a landing page. To begin, click on New Page. Next, give your page a name. For example, we'll name it as Test. Then, click on the Import Site option below. In the URL field, enter http://google.com. Finally, click Import to load the page. You'll see that the website has been successfully imported. Now, click Save Page. After saving, you'll have the option to view the source code. To do this, first click on the Copy Page option on the right. A new pop-up will appear. Then click on the Source option. Now, copy the entire HTML content. Next, switch back to the Kali Linux desktop. Right-click anywhere on the desktop, then choose Create Document and select Empty File. Name the file as test.html. Click on Create. Double-click the file to open it. Now paste the copied HTML code into the file, then save and close it. When you double-click on the file again, it will open a phishing replica of google.com right on your desktop. This demonstrates how a phishing page can be simulated. You can replicate any legitimate website in this way to test or trick users. Here's how a typical attacker's workflow looks. They create a phishing page, design an email template, and send the malicious link, often via a mobile device. When a user clicks the link, the attacker could potentially gain access to their system or capture sensitive information. And that's how you can use GoFish to simulate social engineering attacks and test mobile phishing scenarios. In this video, we will discuss Apple iOS, its various layers, jailbreaking iOS, its types, and the tools used for this purpose. Most people think of iPhones and iPads when we talk about Apple's iOS. It's known for being fast, secure, and smooth. But what makes it work that way underneath? Actually, iOS is built on layers, just like a cake. These layers handle various tasks, including managing hardware, displaying graphics, and running applications. If you have ever wondered what is going on behind that iPhone screen, then we will tell you in a simple way. So what are the main layers of iOS? The first layer of iOS is Cocoa Touch, now known as UIKit and SwiftUI. This is the top layer, or the uppermost layer, which deals with the look and feel of apps. Whenever you swipe, tap, or scroll through your iPhone, it's Cocoa Touch doing the work. It includes touch handling, alerts, notifications, and user interface elements. Developers use this layer to create apps that feel natural and smooth. The media layer is the second layer. This layer is primarily concerned with audio, video, and graphics. Whether you're watching a movie, playing a game, or using your camera, the media layer handles it. It includes frameworks such as AV Foundation for media playback and Core Animation for creating smooth visual effects. Core Services is the third layer. This layer works quietly in the background. It handles files, networking, location services, and basic functions every app needs. For example, if you use an app that finds your GPS location or connects to the internet, its core services doing the job. The fourth layer is Core OS. At the very bottom, we have Core OS. This layer connects the hardware, such as the screen, camera, and CPU, with the software. It also includes security features and low-level operations. Without this layer, the phone wouldn't know how to run apps or manage its memory. Next, we have kernel and device drivers. The kernel is the brain of the operating system, and it resides below all of these layers. It determines what to do, when to do it, and how to use system resources. The kernel is responsible for managing memory, processes, and system calls. It also communicates directly with device drivers, which are small programs that manage specific pieces of hardware, such as the touchscreen, Wi-Fi chip, or battery. The kernel of iOS is based on XENU, which stands for X is not Unix. This is a mix of Unix and other technologies. Apple maintains it locked down so that malware can't meddle with system-level functions. This is one reason why iOS is so safe by default. Let's now take a look at jailbreaking. Jailbreaking is like unlocking the gate Apple keeps shut. Usually, Apple doesn't allow full access to the iPhone's file system or certain customizations. Jailbreaking breaks those restrictions, giving you root access, like becoming the admin of your phone. Once the restrictions are lifted, users can install apps not available on the App Store, customize icons and themes, and utilize advanced features such as screen recording or tethering in some regions. But there are risks. Jailbreaking can compromise your device's security, void your warranty, or even render the device unusable, a condition known as bricking. Let's discuss types of jailbreaking. So, there's more than one way to jailbreak an iPhone, and each method works a little differently. Our first type is tethered jailbreak. In this method, the iPhone depends on a computer to boot up that if the device restarts without being connected to the computer, it won't function correctly. This type used to be common, but it's not very convenient for everyday use. The second type is untethered jailbreak. This is the most preferred type because it remains active even after a reboot. You don't need a computer every time the device restarts, which makes it more user-friendly. However, it's also the most difficult to develop, and Apple frequently patches the vulnerabilities that make it possible. The third type is the semi-tethered jailbreak. This is somewhere in between tethered and untethered jailbreak. The phone can restart, but the jailbreak features won't work until you run a helper app. It's safer and more stable than a tethered one. The fourth type is semi-untethered jailbreak. Here, the jailbreak survives a reboot, but you need to reactivate it using an app on the device itself. There is no need for a PC. Tools like UNC0ver and Checkro1n, uses Checkmate exploit, often fall into this category. So, how do people jailbreak their iPhones? Here are some popular techniques. The first step is to start with Checkro1n. This technique is based on a hardware exploit, specifically Checkmate. This tool can jailbreak older iPhones, A7, A11 chips. Since the flaw is in hardware, Apple can't patch it with a software update. Then we have UNC0ver. This semi-tethered jailbreak works on newer versions of iOS using software-based exploits. It's easy to install and doesn't need a computer after the initial setup. Taurine and Odyssey are next. These are jailbreak tools designed for newer iOS versions, developed with speed and battery performance in mind. All of these tools exploit security weaknesses in iOS that enable users to gain root access. That's why jailbreaking is always a game of cat and mouse. Hackers attempt to find an alternative route when Apple releases a fix. In other words, iOS is a strong and well-managed system. Its layered design makes sure that everything works well and safely, from the Cocoa Touch interface to the core OS and kernel. However, jailbreaking gives users significantly more control over their devices. It allows you to fully customize your device and utilize features that Apple typically restricts. Just remember that having that power comes with risk. In this video, we will discuss various iOS hacking tools used by attackers and security researchers. When we talk about iOS hacking, we're not simply talking about bad guys breaking into iPhones. Researchers, ethical hackers, and security testers routinely check iOS applications and systems for weak spots so they can be addressed before real attackers find them. Apple's system is regarded as being locked down and secure, so you need specific tools to gain access. Unlike Android, iOS doesn't give much freedom. That's why tools used for iOS hacking are often more advanced, and some even require the device to be jailbroken first. Let's explore the most popular iOS hacking tools and what they're used for in a simple and easy-to-understand way. The first tool is Frida, which is a dynamic power tool. As we know, Frida is also used in Android, and it's also essential in iOS. So Frida is one of the most potent tools for iOS hacking. It allows you to hook into apps while they're running, so you can see what's happening inside, without needing the source code. This tool can bypass jailbreak detection. Frida can also modify the behavior of app functions in real time. It can also trace which functions are getting called by an app. Additionally, Frida can monitor data movement inside the app. For example, let's say an iOS app has SSL pinning to block traffic sniffing. With Frida, you can bypass SSL pinning and inspect the app's traffic using additional tools like Burp Suite. Frida is loved by both ethical hackers and reverse engineers. This tool works on both jailbroken and non-jailbroken devices, with some limitations. Then there's Cycrypt. Cycrypt is another iOS tool that combines JavaScript and Objective-C, a programming language used by Apple for iOS and macOS apps. It allows you to run commands directly inside an iOS app. Cycrypt can inspect live app memory. Also, it can modify variables at runtime. It can interact with the app UI while it's running. It's mainly used on jailbroken devices and is great for testing how apps respond to unexpected inputs or security bypass attempts. Let's look at our next tool, which is Objection. Objection is a runtime mobile exploration tool built on top of Frida. You don't need to repackage or modify the app to use it, which makes it super handy for pen testers. Objection can bypass jailbreak or root detection. It can also be used to dig into memory to dump secrets, extract sensitive information. One can explore file storage using this tool. This tool also allows us to hook into the methods and modify them during runtime. For example, you can use Objection to pull sensitive files from an app's private storage, such as cached user tokens or logs that shouldn't be there. Objection works well with both Android and iOS and is often used in conjunction with Frida during app security assessments. Moving on, we have IRET, the iOS Reverse Engineering Toolkit. It's a collection of tools in one package, mainly made for jailbroken iPhones. It's used to analyze apps and understand how they're built. This toolkit includes class dumpers to see Objective-C classes. It also has a keychain dumper to extract saved credentials. Then, this toolkit has PLIST viewers to inspect app settings. IRET helps in static and dynamic analysis, and it's especially useful when trying to reverse engineer apps or test for insecure data storage. Next, we have Hopper, the disassembler. Hopper is a reverse engineering tool that disassembles and decompiles iOS apps. It works on macOS and can analyze ARM, iOS, binaries. Hopper can turn app binaries into readable assembly code. It can also help you understand how functions work. This tool can also spot security flaws or hard-coded keys. If you're trying to understand how an app works internally, whether it's a paid app, a free app, or even your own, Hopper is a great place to start. It's mainly used for static analysis, which means you don't need to run the app. Then, we have Burp Suite with iOS. Even though Burp Suite is often used for web app testing, it's also helpful when testing iOS apps, especially their API calls. How does the Burp Suite work? First, you set up your iPhone to use a proxy server, Burp. Once it's done, you intercept all the requests and responses between the app and the server. Next, you can modify the data to test for security flaws, such as broken authentication. There's one point to note. If the app uses SSL pinning, you'll need Frida or Objection to bypass it, or else the app won't let Burp Suite read its traffic. Burp Suite is extremely useful for testing how iOS apps communicate with backend servers. Lastly, we have ClassDump. ClassDump is a simple but powerful tool that extracts Objective-C class information from iOS apps. ClassDump reveals method names, class names, and structures from compiled apps. It helps hackers or testers understand what the app is doing behind the scene. This tool helps enumerate available methods, which in turn enables hooking into specific functions using Frida or Cycrypt. So, iOS hacking is not just about breaking things. It's about understanding how apps and systems work under the hood so we can protect them more effectively. Because iOS is so locked down, tools like Frida, Objection, Cycrypt, and Burp Suite are vital for digging deeper. Some tools require jailbreaking, while others can work on non-jailbroken devices with limited access. However, all of them share one common goal: helping ethical hackers identify security flaws before malicious actors do. In this video, we will discuss reverse engineering and the tools used for it. Imagine you have a mobile app on your phone. You didn't make it, but you want to know how it works. Whether you're a security tester searching for holes, you might want to see whether it's doing anything strange. To figure out how an app works, you have to reverse engineer it. So, why do people reverse engineer mobile apps? There are many reasons people reverse engineer apps. Some of them are legal, while others are not. Let's take a look at some legal and legitimate reasons. It is used for security testing to find vulnerabilities and fix them. It is also used for learning, which involves understanding how apps are built. Then, reverse engineering is used for debugging, which involves checking app behavior without access to the source code. Another reason is app recovery. It helps developers restore the app if the original code is lost or corrupted. Next, let's examine illegal and unauthorized reasons. Reverse engineering can be used for hacking, involving the theft of code or intellectual property. It can also be used for modding, changing app behavior, such as unlocking premium features. And lastly, it can be used for spying, which looks for hidden secrets like API keys or passwords. Next, let's discuss what happens during reverse engineering. Let's say you have an Android app in APK file format. You can't open it like a normal file, but with the right tools, you can. First, you need to unpack the APK, which provides access to files such as images, code, and configuration. Then, you have to decompile the code, which converts it from machine language back into something readable, like Java or Smalley. Always remember to analyze the logic. Once the code is readable, you can understand how the app functions. The next step is to modify and repackage, optional. You can modify and rebuild the code. On iOS, it's trickier because Apple devices are locked down, but with jailbreaking and tools, you can still inspect app behavior and code. There are many tools available, some designed for Android, some for iOS, and some that work on both platforms. Let's look at the most popular tools. The first tool is very famous, APK Tool, which is used for Android. APK Tool helps unpack and repackage APK files. It breaks down the app into Smalley code, a human-readable version of code, which allows for modification. This tool decompiles APK into folders. It also displays manifest files and resources, allowing you to edit and rebuild the app. For example, you can open a game APK, change the in-game currency value, and repackage it, although this should only be done for ethical testing or learning, not cheating. The next tool is JAX, which is used for reverse engineering Android applications. JAX is a tool that turns Android APK files into Java source code. It's great if you want to understand how an app works without needing to access the actual APK file. It converts DX, Dalvik executable, into Java and displays readable code in a clean interface. For example, you can find hard-coded API keys or understand login logic if you're auditing app security. Moving on, Ghidra is used for both Android and iOS. Ghidra is a powerful reverse engineering platform developed by the National Security Agency, NSA. It supports many platforms, including Android and iOS. Ghidra disassembles code into a low-level language, supports scripting and plugins, and aids in identifying vulnerabilities. For example, an advanced user can use Ghidra to trace how data flows through an app, especially in malware analysis. The last tool is ClassDump for iOS. ClassDump extracts class information from iOS apps. It's useful for developers who want to understand how the app interacts with different libraries. It lists all classes and methods, helping to reverse engineer apps without source code. For example, you might use this tool to understand how a social media app connects to its server. Reverse engineering is powerful, but it's not always easy. Sometimes, apps use obfuscation techniques that make the code hard to read. Developers may add anti-debugging checks, Legal issues can arise if you reverse engineer apps without permission. So, reverse engineering mobile apps is like lifting the hood of a car to see what's inside. You may use tools like APK Tool, JAX, and Ghidra to break down and look at even the most complex applications in great detail. Reverse engineering lets you discover how applications function, uncover problems, and make them safer, whether you're a developer, a security analyst, or just interested. In this demonstration, we will explore how to use the Shodan tool for gathering information about IoT devices and performing IoT-related reconnaissance. To begin, open Firefox by clicking the icon located at the top left corner of your screen. Once Firefox is open a new tab. In the search bar, type Shodan and press Enter. The first search result will be https://www.shodan.io. Click on this link to open the Shodan website. You will now see the main interface of Shodan. The official URL of the site is https://www.shodan.io. Shodan offers many features and options, but if you want to use Shodan for free, you need to log into your account. Without logging in, you can only access a limited number of results, typically just one page. To access more pages, you need to log in. And if you want to access more than 2 pages or unlock advanced features, you'll need to purchase a Shodan subscription. To log in, click the Login button located at the top right corner of the screen. Enter your credentials and click the Login button again to proceed. If you want to find IP cameras using Shodan, you can use specific search filters. In the Shodan search bar, type the following query. Port:554 has _screenshot:true. Then press Enter. This command searches for devices running on port 554, which is commonly used by IP cameras and filters for those that have a screenshot available. Once the results load, you'll see live screenshots captured from accessible IP cameras. This allows you to gather detailed information about exposed IP cameras on the internet. To find cameras streaming over RTSP, real-time streaming protocol, which is commonly used for video transmission, use the following query in the Shodan search bar. Type netcam in double quotes, country, UK within in double quotes. Here, netcam is the keyword for the camera type, and country UK filters the results to the United Kingdom. Press Enter. If no results appear, possibly due to limited availability or temporary issues, try replacing UK with US in the search query. Now, press Enter again. You should see a list of devices streaming over RTSP in the United States. If you get stuck while searching in certain countries or using specific queries, try adjusting the command slightly off and helps you get better results. This is how you can use Shodan to gather information about cameras streaming over RTSP. If you want to look for open telnet services, type the following query in the Shodan search bar. Port:23, OS:, type Linux within double quotes. This command searches for Linux-based systems with port 23 open. Press Enter. Once the results are displayed, right-click on the first IP address, 168.119.3.89, and select Open Link in New tab. In the results, you may notice a domain like yourbackup.de, along with a list of open ports. Port 21, used for FTP. Port 22, used for SSH. Port 23, used for Telnet. Since we specifically searched for Telnet, this result includes port 23. You'll also see details such as the organization, which in this case is Hetzner Online Gym BH. Only proceed with further actions if you have explicit authorization or permission. Unauthorized access is illegal and unethical. Once done, you can close the tab. This is how you can use Shodan to discover IoT devices in different locations. In this demonstration, we will explore how to use Shodan for OT and information gathering. To begin, open Firefox by clicking the icon located at the top left corner of your screen. Once Firefox is open a new tab. In the search bar, type Shodan and press Enter. The first search result will appear as https://www.shodan.io. Click on this link to open the Shodan website. Now in the Shodan search bar, type the following command. port:102, type Siemens within double quotes. Then click on the search icon. You may see an error message that says, "Please log in to use search filters." This is because port-based filters are only available to logged-in users. To proceed, click the Login button located at the top right corner of the screen and sign in using your Shodan username and password. Once logged in, enter the same command again in the search bar. port:102, type Siemens within double quotes. This query searches for devices using port 102, which is commonly associated with the Siemens S7 communication protocol, widely used in industrial environments and factory automation systems. Click on the search icon to run the query. You will now see a list of results related to the Siemens S7 communication protocol. Right-click on any IP address from the results. I'll be clicking on 86.122.194.254 and select Open Link in New tab to view detailed information. Switch to the newly opened tab. Here, you can view important details such as organization. In this case, it is listed as RCS and RDS business. Open ports. Ports 80, 102, and 2222 are visible. Port 102 indicates the presence of original Siemens equipment, confirming the use of the S7 protocol. This is how you can gather specific device and network information using Shodan. Now return to the previous tab in your browser. In the Shodan search bar, type the following query. port:20000 DMP3. Then click on the search icon. The DMP3 is commonly used in electric grids and water treatment plants. These systems should ideally operate in isolated environments. As you can see, Shodan returns only one available service for this query. Right-click on the search result and choose Open Link in New tab. Switch to the New tab to view detailed information about the device or system associated with the DMP3 protocol. This particular device is located in the city of Helsinki. If you scroll down the page, you will notice that TCP port 20000 is open, which indicates that the DMP3 device is active and operational, ready and running. Now return to the previous tab and type the following command in the Shodan search bar. Omrin, capital PLC in double quotes, port:9600. Click on the search icon. Omrin, automation controllers commonly communicate over port 9600. However, in this case, no results are found. This could be because the devices are currently offline or the port is not exposed publicly. To proceed, let's enter another search filter. In the Shodan search bar, type port:1911, then type Niagara within double quotes. This query targets building automation systems using the Niagara framework, which is typically deployed in energy management, fire safety, and HVAC systems. As you can see, one result is available. This demonstrates how you can use different port numbers and filters in Shodan to gather information on various OT devices. In this demonstration, we will explore how to use Nmap for information gathering and hacking on IoT and OT devices. To start, you need to have a target IP address. You can find this target IP either by using Shodan, which we covered earlier, or if you already have a specific target IP address, you can use that directly. Now let's proceed to learn how to use Nmap to scan and gather information about the target device. Open the terminal by clicking on the icon at the top left corner of your screen. Now type the following command. Nmap-p 20000 157.180.77.179. Here, port 20000 is used for the DMP3 protocol and 157.180.77.179 is the target IP address. Press Enter. You will see that the host is up and the TCP port 20000 is filtered, likely running DMP service. This shows how you can use Nmap to check if the DMP service is running on the target device. Type the command clear to clear the terminal screen and press enter. Now type the following command to scan specific ports such as Telnet, HTTP, HTTPS, and HTTP proxy. Nmap -small s capital S -small p 80, 443, 23, 8080 167.235.90.213. Nmap is the command to run the tool. -ss performs a TCP scan using synchronized packets. -p followed by the port number specifies which ports to scan. 167.235.90.213 is the target IP address. Press enter. You will see the scan results showing which ports are open on the target. Port 23 over TCP is open, typically used for Telnet. Port 80 over TCP is open, commonly used for HTTP. Port 443 over TCP is open, secured for HTTPS traffic. Port 8080 over TCP is open, often used for HTTP proxy services. This is how you use Nmap to check specific ports like Telnet, HTTP, HTTPS, and HTTP proxy on a target device. Type the command clear and press enter to clear the terminal screen. To check for Modbus discovery using Nmap, type the following command: Nmap -small p 502 -script Modbus discover 203.0.113.45. Here, -p 502 specifies port 502, which is the default port used by Modbus. Press enter. Once the scan completes, you will see output indicating the host is up and port 502 in TCP is filtered and commonly used for MBAP service. This is how you can use Nmap to perform IoT and OT hacking in your system. In this video, we will discuss various international OT security organizations. Let's examine some of the most significant OT security organizations worldwide. First is OTCC, which stands for Operational Technology Cybersecurity Coalition. The OTCC is a coalition that brings together companies from various industries that share a common interest in OT security. It was formed to help shape policies, raise awareness, and improve the overall state of OT cybersecurity. What makes OTCC special is that it includes both technology providers and industrial users. They collaborate to establish more robust security rules, share knowledge, and promote innovation in protecting operational technology, OT systems. It helps governments understand the unique challenges of OT, which differ from those of IT. For example, you can't always patch a machine on a factory floor the same way you update a laptop. The next OT security organization we have is OTISAC, which stands for Operational Technology Information Sharing and Analysis Center. OTISAC is mainly based in Asia and focuses on helping companies protect their industrial systems by sharing threat intelligence. It's like a central hub where different organizations report attacks, share lessons, and get updates on new threats. OTISAC connects industries like manufacturing, energy, shipping, and transportation. When a company faces a new type of malware or system vulnerability, OTISAC helps others learn from it so they can prepare before it affects them as well. This community defense model makes it stronger for everyone. It builds trust and encourages companies to help each other instead of staying silent about cyber incidents. Moving on, the next security organization is NERC, which is North American Electric Reliability Corporation. NERC is a major player in OT security within the electric power sector. Their job is to keep the power grid in North America secure and reliable. Under NERC, a set of cybersecurity rules known as CIP, Critical Infrastructure Protection, standards is in place. These standards help protect systems that manage electricity, from power plants to substations. NERC focuses on real-world, practical security. For example, they require utilities to identify critical cyber assets, monitor access to systems, and have robust incident response plans in place. These rules help prevent blackouts caused by cyberattacks and ensure the energy flow remains steady. ISA, which stands for International Society of Automation, is our next organization in the OT security space. ISA is a global organization that develops security standards specifically for industrial systems. They are well known for their ISA/IEC 62443 series, a set of cybersecurity standards designed just for OT environments. These standards cover everything from securing devices to integrating security into a comprehensive factory system. ISA also trains engineers and cybersecurity experts to apply these rules correctly in the real world. The main goal is to help industries secure their operations without affecting safety or performance, which is always a tricky balance in OT environments. IEC, which stands for International Electrotechnical Commission, is the next organization. The IEC works closely with ISA and is responsible for developing international electrical and electronic standards, including those used in OT systems. The IEC 62443 series, developed in collaboration with ISA, is now one of the most recognized frameworks for OT cybersecurity. These standards enable companies worldwide to follow a consistent approach to security, regardless of their location. This makes it easier for global businesses to stay secure and compliant. IEC's work ensures that OT systems in different countries can safely interact with each other, which is especially important in global supply chains and critical infrastructure. Also, we have ISACA, which stands for Information Systems Audit and Control Association. ISACA is mostly known in the IT world, but it has expanded into OT and industrial security, too. It offers certifications, training, and frameworks that help professionals audit, manage, and secure OT systems. ISACA's global presence enables professionals from diverse parts of the world to apply the same best practices. Its focus is on governance, risk, and compliance, GRC, which is important in industries where safety and uptime are critical. By supporting both IT and OT professionals, ISACA helps bridge the gap between the two worlds, particularly in organizations undergoing digital transformation. Lastly, we have NIST, which stands for National Institute of Standards and Technology. NIST is a US-based organization, but its cybersecurity guidelines are followed around the world. For OT, NIST created SP 800-82, which provides detailed guidance on securing industrial control systems, ICS. This organization also developed the Cybersecurity Framework, CSF, which helps companies across industries understand their risks, protect systems, detect problems, and recover after attacks. Although it's an American agency, many global companies utilize NIST's guidance because it's clear, well-researched, and adaptable to OT systems of all sizes. So, as OT systems continue to integrate with IoT technologies, the risk surface expands and becomes more complex. Machines that were once isolated are now connected to networks. This makes them quicker and smarter, but it also makes them prone to attacks. In this new world, worldwide OT security groups aren't simply useful, they're necessary. ISA, IEC, NIST, and OTISAC are all organizations that help develop global standards, share information about threats, and assist businesses in dealing with new hazards. They provide the structure, trust, and guidance industries need to stay one step ahead of cyber threats, especially when safety, uptime, and human lives are at stake. As we get farther into the digital era, the border between IT, OT, and IoT will get less clear. That's why working together on a global scale, sharing expertise, and having solid frameworks are no longer optional. They are the basis for safe operations all over the world. These groups work together to assist companies build systems that are not just smarter, but also safer. In this demonstration, we will use different commands for managing an AWS EC2 instance. To get started, you'll need an AWS account and Kali Linux installed on your system. You will also need to set up the AWS CLI command line interface in your Kali Linux terminal. Let's begin by logging into your AWS account. Open your browser and type AWS in the search bar. The first link you will see is aws.amazon.com. Click on that. Once the page loads, you will see the AWS website interface. Next, go to the top right corner and click Sign in to the console. Once signed in, you will see the AWS main interface. First, go to the AWS search bar at the top left corner and type IAM. You can find IAM appears in the search results. If you want, you can add it to your favorites for quick access. Then click on it to open IAM dashboard. Now click on Users from the left-hand sidebar. You will see the list of users you've already created. If you haven't created a user yet, click on the Create User button at the top right corner. Enter a username, set the permissions, review the details, and then click Create User. Once your user is created, click on the username to view and manage their details. Next, you need to create an access key for your AWS CLI. To do this, go to the summary panel of your selected IAM user and click on Create Access Key. On the next screen, select Command Line Interface, CLI, as the use case. Then, check the box to confirm, I understand the above recommendation. Click Next to proceed. You don't need to provide a description here, as the description tag is optional. Simply click on Create Access Key. Once done, you will see that your access key has been successfully created. Now download the access key file to your system by clicking on the Download.csv option. Once the file is saved, open it to view your access key ID and secret access key. Now go to your desktop and open the Kali Linux terminal by clicking the terminal icon located in the top left corner of your screen. To begin setting up AWS CLI, you'll first need to install the AWS CLI tool on your system. Type the following command, sudo apt install AWS CLI. Press Enter. Go ahead and type your password when prompted, then press Enter. After a few moments, you will see that the AWS CLI has been successfully downloaded on your system. First, type the command, clear, and press Enter. This will give us a clean terminal screen. Now that AWS CLI is installed, let's check its version. Type the following command, AWS -- version. Press Enter. It shows the AWS CLI version, which in our case is 2.23.6, along with the Python version 3.13.2. And Linux version is 6.12.13-AMD64. After that, clear the screen again by typing the command, clear, and pressing Enter. Now it's time to configure your AWS CLI. Type the following command, AWS configure. Press Enter, and it will prompt you to enter 4 pieces of information. AWS access key ID. Open your downloaded CSV file and copy the access key ID. Paste it into the terminal using Ctrl-Shift-V and press Enter. AWS secret access key. Go back to the same file and copy the secret access key. Again, paste it using Ctrl-Shift-V and hit Enter. Default region name. If you're unsure or don't have a specific region in mind, just press Enter to skip. Default output format. Similarly, if you're not setting a format like JSON or table, just press Enter. Once done, your AWS CLI is fully configured and ready to use. Now let's verify if AWS CLI is working correctly by checking your S3 buckets. Type the following command in the terminal, AWS S3ls. Press Enter. If no S3 buckets are currently available in your AWS account, nothing will be displayed here. However, if you do have existing S3 buckets, this command will list them along with their creation dates. If your AWS CLI was not configured properly, you might see an error message or permission denied alert at this step. Clear the screen again by typing the command, clear, and pressing Enter. Open your browser and in the AWS console, search for EC2 in the search bar. Press Enter. Click on EC2 from the search results. Locate and click Launch Instance on the right side of the dashboard. In the instance name field, type something like Demo EC2. Scroll down to Application and OS Images, Amazon Machine Image. Select Debian. Make sure it's marked as free tier eligible. The instance type will be set to t2.micro by default. After setting the instance details, The next step is to configure the key pair for secure SSH access. Under the key pair login section, click Create New Key Pair. In the key pair type, select RSA. In the private key file format, select .ppk. Enter a key pair name, for example, demo key pair. Note, if a key pair with this name already exists, AWS will ask you to provide a different name, such as demo key pair 1. Click Create Key Pair. The .ppk file will be downloaded automatically to your system. After creating the key pair, the next step is to configure security and storage. Click on Configure Security Group in the Network Setting panel and allow the necessary permissions, such as HTTP and HTTPS traffic, so your instance can handle web requests. For storage, make sure to allocate 8 GB of space. The default storage type is GP3. Once these settings are configured, click Launch Instance. You will see your instance starting to launch in the EC2 dashboard. If you see that the instance has successfully launched, go back to the EC2 dashboard by clicking on Instances in the top left corner. Here, you can see your EC2 instance running and ready to use. Now go back to your terminal and type the command AWS EC2 describe -instances. Note that you must specify a region for this to work. To set the region, type the command AWS configure and press Enter. It will ask for your access key ID. Open your CSV file, copy the access key ID, and paste it into the terminal. Next, it will prompt you for the secret access key. Again, copy this from your CSV file and paste it into the terminal. For the region name, open your browser and look at the top right corner. You will see the region listed, for example, United States, Ohio. Type that region name in the terminal when prompted. Press Enter, and then press Enter again to confirm. Now use up arrow key to bring back the command and press Enter. Go to your Kali Linux terminal and type AWS EC2 describe -instances. Then press Enter. This command will display details about your EC2 instances. In the output, you'll see information like reservation ID, for example, are -0D, 14A7D, 90A79, A21B4. Owner ID, such as 634183828652. Architecture, like x86_64. This is how you use the describe -instances command to get information about your EC2 instances. To exit, press Ctrl+C. Then type clear to clear the terminal screen. Now, type the following command AWS EC2 describe -volumes. Press Enter. This command will provide information about your EBS volumes. For example, you might see details like volume size, such as 3000 GB, volume type like GP3, multi-attach enabled status, which could be false, throughput, for example, 125 megabytes per second. This is how you can retrieve information about your storage volumes in AWS. Type the command clear to clear the screen and press Enter. Now type the following command AWS EC2 describe -snapshots. Press Enter. This command will list all available snapshots and help you check if any volume is public or not. This might take some time, so please wait. Once the output appears, you'll see details such as snapshot storage tier, usually standard for free tier, transfer type, standard, volume ID, hidden here for privacy, progress rate, 100%, owner ID, your AWS account ID, additional information related to your snapshots. Then press Ctrl+C. After that, type clear to clear the screen again. Now type the following command in your Kali Linux terminal AWS EC2 describe -fleets. Press Enter. This command will list details about any existing EC2 fleets in your AWS account. Since we haven't configured any fleets, the output will indicate that no fleets are available. So this is how you can use various commands in an EC2 instance and successfully set up the AWS CLI on Kali Linux. In this demonstration, we'll explore how attackers can exploit misconfigured Amazon S3 buckets. We'll walk through a step-by-step process for identifying and exploiting these misconfigurations, all within a safe, simulated environment. To locate vulnerable S3 buckets, tools like S3 Scanner and Lazy S3 are commonly used. Since this is a controlled demonstration, we'll create a misconfigured test bucket, as we do not have access to a real-world misconfigured bucket. To begin, go to your taskbar and open your preferred web browser. In the address bar, at the top, type AWS, then press Enter. Once the search results appear, click on the first link, aws.amazon.com. When the page loads, look toward the top right corner and click on the button that says Sign in. If prompted, enter your login credentials. You should now be successfully signed in to the AWS Management Console. On the home page, you may see Recently Accessed Services. If S3 is not listed, move to the top of the screen, locate the search bar, and type S3. When you see S3 in the search results, press Enter or click the S3 link to navigate to the Amazon S3 service page. If you have not created a bucket before, the system will prompt you to create one. Click the Create Bucket button. In the General Configuration section, you'll need to provide a name for your bucket. In the bucket name field, type Test45. Choose the bucket type as General Purpose. Leave all other settings at their default values. Now, scroll down and click the Create Bucket button. If you receive an error that says, "The specified bucket name already exists and please select a different name," and try again, it means that bucket name is already in use. In that case, we need to update the bucket name. Avoid uppercase letters. Let's try renaming it to Amazon Test 1. However, we receive an error message. A bucket with the same name already exists. To resolve this, rename the bucket to Amazon Test 156. This should create a unique and valid bucket name. Now, click on the Create Bucket button again. You will see that the bucket named Amazon Test 156 has been created. A confirmation message will appear on top stating, "Successfully created bucket, Amazon Test 156. Close the confirmation window and navigate back to the Amazon S3 dashboard and click on S3 at top left corner. Once the page loads, click on the name of the bucket you just created, which should be listed on the S3 page. Now, you need to upload a file. Locate and click the Upload button. In the Upload interface, click on Add Files. For this demonstration, we'll select a simple PNG file named test.png. You can also upload any file here. After selecting the file, click Open. Now, click the Upload button at the bottom. You will notice that the file named test.png is uploaded. Click the Close button at the top to exit the Upload interface. Now, let's create a folder inside the bucket. Click on Create Folder. In the folder name field, type Victim 189. Then click Create Folder. You should now see both the uploaded file, test.png, and the new folder, Victim 189, listed within your S3 bucket. Click on the terminal icon at the top left of the screen. First, let's check if the AWS command line interface is installed. Type the following command, AWS --version. Press Enter. In the output, we can see AWS CLI version is 2.23.6. Python version is 3.13.3. Linux version is 6.12.13, and also we can see the source file. Next, to list all the S3 buckets in your account, type AWS S3 ls. Then press Enter. This will display the S3 bucket, Amazon Test 156, you've created earlier. Finally, let's clear the terminal for a clean view. Type Clear and press Enter. Next, to view the contents of your Test S3 bucket, type the following command, AWS S3 ls s3://. Go to Browser and copy the file name you created. Now, switch back to the terminal and paste the file name. So your final command should be AWS S3 ls s3:// Amazon Test 156. Press Enter. This command lists all the files and folders inside the bucket. You should see the folder named victim189 and the uploaded file test.png in the output. For example, to move a file, type the command AWS S3 small mv. Now go back to AWS S3 dashboard in browser. In your S3 bucket, click on the first file, test.png. On its details page, click on Copy S3 URL. Switch back to the terminal and paste the copied URL after the mv command. Next, return to S3 dashboard again. Click on Amazon Test 156 on the top. Next, click on the folder victim189/. Click on Copy S3 URL. Paste the copied S3 URL into the terminal. Then type -no-sign-request at the end of the command. This technique is often used by attackers when misconfigured S3 buckets allow unauthenticated access. Press Enter to execute the command. If you see a 403 forbidden error, it means the bucket is properly configured, which is expected since we're working in a safe demo environment. Now press up arrow key and bring up the last command. Remove -no-sign-request and rerun the command. In the output, you can see the file S3:// Amazon Test 156/test.png has been moved to S3:/ Amazon Test 156/victim189/test.png. To confirm the file was moved successfully, return to your browser and refresh the victim189 folder inside your S3 bucket by clicking on the refresh icon. You should now see that the file test.png has moved inside the victim189 folder. And that concludes our demonstration of how attackers can exploit misconfigured Amazon S3 buckets. In this demonstration, we'll learn how to create a backdoor in AWS using the Paku tool. Paku is a Python-based AWS exploitation framework. It helps you create and manage backdoors in your AWS environment. Let's get started. First, open the Kali Linux terminal by clicking the terminal icon at the top left corner of your screen. Now let's install the Paku tool. Type the following command: pip3 install Paku. Then press Enter. This is the standard command to begin the installation. You might see an error that says externally managed environment. If that happens, start by clearing the terminal. Type the clear command and press Enter. Next, install and activate a Python virtual environment by typing source.venv/bin/activate. Then press Enter. You are now inside a Python virtual environment. Now reinstall Paku using the same command. pip3 install Paku. If Paku is already installed, you'll see the message, requirement already satisfied. Once again, clear the terminal by typing clear and pressing Enter. Now let's start using Paku. To display the help menu, type the following command: Paku-help. Then press Enter. This will show you all the available options and flags for using Paku. You will see options like -h and -help for general help, -new, -session to start a new session, and many more useful options. Clear the screen again using clear command. Now let's begin a session with Paku. Start the tool by typing Paku, then press Enter. You will see that Paku has launched successfully. Since Paku is a backdoor tool, to start a new session, type 0 and press Enter. Paku will then prompt you to name your session. For this demonstration, let's name it Hacking. Type the name and press Enter. You will now see the Paku prompt, which means the session has started. However, no AWS keys have been set yet. To set your AWS access keys, type the following command: set_keys. Then press Enter. Paku will now prompt you to enter an alias. You can type any name like hello or link it to a saved credentials file. In this case, we'll use our AWS account ID as the alias, 634183828652. Type it in and press Enter. Next, you'll be prompted to enter your AWS access key ID. After that, Enter your AWS secret access key and press enter. When asked for a session token, simply press enter to skip it. At this point, Paku is successfully configured and ready to use. Now type ls to list the available Paku modules and commands. You will see modules like acm_enum, ec2_enum, ecr_enum, and many others. If you have an EC2 instance, you can use the ec2_enum module to easily list its details. Keep in mind, Paku is a backdoor tool. It's not part of the standard AWS toolkit. That means it doesn't follow the usual security rules or behavior of native AWS services. So the output and operations you see may differ from official AWS tools. Now that we've completed these steps, let's move ahead. Copy the command iam_enum_users_roles_policies_groups using Ctrl-Shift-C. Scroll down, type run, then paste the copied command using Ctrl-Shift-V. Press enter. In the output, you will see 1 users enumerated, 2 roles enumerated. Now copy another command iam_enum_permissions. Once again, type run and paste the copied command. Press enter. In the output, you will see 1,115 confirmed permissions. Paku has now enumerated the permissions associated with users. In this demonstration, we will walk through the steps to use the GCP scanner using the command line interface. GCP scanner is a cloud security tool used to enumerate resources and permissions associated with a given set of credentials in Google Cloud Platform. It helps determine what level of access a user, service account, or token has, critical for understanding potential risk exposure in security assessments. This tool is primarily intended for security engineers and is particularly helpful when evaluating the impact of a compromised virtual machine, container, or leaked credentials. Let's begin by opening the terminal. Next, we need to download the GCP scanner tool. To do this, open Firefox. Once Firefox opens, navigate to a new browser tab and type GCP Scanner GitHub, then press enter. Look for the second link in the search results, https://github.com. It should lead to a GitHub repository hosted by Google. Click on it to open the link. Once on the repository page, you'll see the list of directories and files related to the GCP scanner. We can see a disclaimer which says, "This is not an official Google project. It is not supported by Google." Google specifically disclaims all warranties as to its quality, merchantability, or fitness for a particular purpose. To download the tool, locate the code button at the top and press enter. Then, click on the Copy to Clipboard option to copy the repository link. Now return to the terminal window. Type the following command: git clone, then paste the repository link. This command will clone the GCP scanner repository to your local system. Once cloning is complete, we will run the tool using Python 3. Clear the screen by typing clear and pressing enter. Now type source.venv/bin/activate. This activates the Python virtual environment. Next, switch back to the GitHub page. If you scroll down, you'll find a complete installation guide for GCP Scanner. Keep in mind, if you're using a virtual environment in Python, some steps might vary slightly depending on your setup. Return to the terminal. Change into the GCP Scanner directory by typing cd GCP_scanner. Press enter to navigate into the directory. Now install the required dependencies by running pip install. This command installs all the necessary packages listed in the project configuration, allowing the GCP scanner to function properly. As shown here, the installation is already complete on my system. If it's still installing on yours, please wait for the process to finish. Let's clear the terminal screen. Let's switch back to the GitHub page and copy the next command: GCP-scanner-help. Come back to the terminal and paste the command. Press enter. This will show a list of different usage options and flags available in the tool. The basic syntax for running the scanner is Python 3 scanner.py dash small o. Folder underscore 2 underscore save underscore results dash small g dash. Some commonly used flags include dash h for help, dash ls for light scan, dash k to specify a path to directory containing service account keys in JSON format, dash m to use metadata, and several other options. To start with a basic example, copy the above command and paste it into the terminal. Clear the screen. In the command replace, folder underscore 2 underscore save underscore results dash small g dash with a name like test to specify where results should be stored. After pressing enter, you might encounter an error message saying, please select at least one option to begin scan. Dash small k, dash small g, dash small m, dash small rt, dash small at. Let's try the dash small g flag, which requires a path to a Google Cloud profile. If you don't have a valid profile path, another error may appear. Instead, let's use the -m flag to attempt retrieving an access token from instance metadata. After executing the command, the tool will try to retrieve credentials from the instance's metadata. In our current setup, this fails because no metadata is available. However, if metadata were properly configured, the scanner would successfully extract the credentials. And that concludes our demonstration on using the GCP scanner. Please note that there is no output displayed in this demo because the main objective is to demonstrate the setup steps and usage instructions for the GCP scanner. In this demonstration, we'll explore two important cryptography tools, JWT.io and BC Text Encoder. JWT.io is a platform used to encode and decode JSON web tokens. BC Text Encoder is a tool used to encrypt and decrypt plain text files. To begin, open the Firefox browser by clicking the icon at the top left of your screen. Now open a new tab and close the previous one. Once the new tab is open, move to the address bar and type jwt.io. Then press enter. This will take you to the official jwt.io site at https://jwt.io. As you know, jwt.io platform is used to encode and decode JSON web tokens. A standard JWT consists of 3 parts: the header, the payload, and the JWT verification signature. Here's how a JWT token is structured. First, the decoded header identifies the algorithm used, such as HS256, and the token type, which is JWT. Next, the decoded payload. This includes fields like the subject, the username, which is John Doe, admin, set to true, roles, and the issued at timestamp, abbreviated as IAT. The issued at timestamp is important. It tells us when the token was created and helps determine how long it remains valid. This is critical for limiting access over time. Finally, the signature. In this case, it's generated using HS256, which is a 256-bit key. If this algorithm is weak or misconfigured, the JWT token becomes vulnerable to tampering, allowing unauthorized changes to the token. Click on the Maximize icon at the left of the decoded payload header. Select Claims Table to expand the view, making it easier to read and understand. Now try changing just one character in the JWT token. You will notice that a message saying invalid signature. This shows that the token has been altered and can no longer be trusted. It's a key feature that helps enforce secure authentication, because as soon as a token is changed, it's considered invalid. There's another feature available in jwt.io. Go to the JWT encoder located to the left of the JWT decoder. Here, change the algorithm value from HS256 to RS256. You will notice that the JWT token is no longer displayed. That's because when using RS256, provide a private key. In the payload section, type a message. Let's use hello as the private signature key. Now click on Generate Example on the right and select the RS256 algorithm. You will see that JWT tokens start generating based on your data. You will also notice that the private key is different. This change happens because of the RS256 algorithm and because you've entered custom data, in this case hello. And that's how you can use JWT.io to explore token generation with different algorithms. Now let's look at how to use the other tool, BC Text Encoder. On your Windows system, open your browser. In the address bar, type BC Text Encoder, then press Enter. Find the first link, Jetico.com, and click on it. This will open the interface of Jetico, the official site of BC Text Encoder. On the Jetico site, locate the free download button, usually centered on the screen. You will see several download options. From the available choices, go to Encrypt Text Files. Click on Free Download again. Choose a destination folder on your computer and proceed with downloading the installer. Once the download finishes, run the installer. Now open the installer in full screen for easier setup. With BC Text Encoder installed, let's explore the interface. Under the File menu, you can open existing text files or save your work. The Edit menu lets you modify the text content directly. Under the Key menu, you can generate a new public-private key pair. You can also choose a public key for encoding or manage your key database from this section. In the Options menu, you will find settings for copying encoded or decoded text to the clipboard, sending encoded text automatically, and clearing the clipboard. Now go to the Options menu again and click on Clear Clipboard Now to securely erase any sensitive copy data. Next, click on the Encoded by field at the top center of the screen. Here, you'll find two options. Password. Choose Public Key. By default, this is set to password. Let's leave it as it is for now. Now to begin encryption, type a message in the main text area. For example, enter hello. Then, click the Encode button at the top left of the screen. You will be prompted to enter a password. By default, you will see the session key algorithm set to AES 256, a strong and widely used encryption standard. For this demo, enter the password as 1234567 and confirm it. Click OK, and you will see the encrypted version of your message appear in the main window. You can now copy this encrypted text and send it securely to someone else. After copying, be sure to click Clear Clipboard to remove any trace of the data. To decrypt a message, paste the encrypted text back into the text box and click Decode. You will be asked to enter the correct password. So enter 1234567 and click OK. The decrypted message hello will appear. If you enter an incorrect password, such as 123456789, the system will return an error indicating that the password is invalid. So this is how you can use JWT.io for secure token handling and BC Text Encoder for text encryption and decryption. In this demonstration, we will explore how to use disk encryption with VeraCrypt. To begin, open your web browser. In the address bar, type VeraCrypt. The first result should be the official VeraCrypt download page, veracrypt.io. Click on that first link. Once the VeraCrypt website opens, you'll be automatically directed to the download section. From this section, locate the VeraCrypt Windows EXE installer download link. Click on the link. When prompted, choose a location and click Save to save the file on your computer. After choosing the location, the download should begin. As you can see, the download has started. VeraCrypt is a disk encryption tool that allows you to securely encrypt your sensitive files and disks, providing an extra layer of protection through access control and user authorization. Once the installer has finished downloading, navigate to the file location, double-click on the file to run the setup. A dialog box will appear. Click OK, then read and check the box to accept the license agreement. Click Next, select your preferred installation settings, and then click Install to begin the installation. Once installation is complete, you'll receive a confirmation message. Click OK, and then click Finish to exit the installer. You will be asked to restart your computer. Choose No for now. Now open the Start menu on your computer and type VeraCrypt in the search bar. When VeraCrypt appears in the results, select it to launch the application. Once VeraCrypt opens, it will prompt you to read the beginner's tutorial. So click on Yes. To open Beginner's Tutorial window, click on the tutorial and VeraCrypt will open the interface along with a step-by-step guide. Now let's follow the steps shown in the tutorial. First, click the Create Volume button. Then, select Create an encrypted file container. Then click Next. Choose Standard VeraCrypt Volume, and again, click Next. Now it's time to select the file where your encrypted volume will be stored. Click Select File. In the File dialog, navigate to your desired folder. Create a new file. For this demo, we will name it myvolume.hc. Click Save, then click Next to continue. For the encryption algorithm, choose AES. For the hash algorithm, select SHA-512. Click Next. Now define the size of your volume. For this demonstration, we'll use 300 megabyte. Also, please keep in mind that the minimum volume size requirements. For FAT, file allocation table, volume is 292 kilobyte. For exFAT, extended file allocation table, volume is 424 kilobyte. For NTFS, new technology file system, volume is 3,792 kilobyte. For refs, resilient file system, volume is 642 megabyte. Since we're using 300 megabyte in this case, now click Next. Then, we need to create a strong volume password. It is recommended to choose a password with 20 or more characters, as longer passwords significantly strengthen encryption and enhance overall security. So type in a 20-character password, confirm it by entering it again, then click Next. At this stage, volume formatting begins. Keep the default file system and cluster size options as they are. VeraCrypt will now collect random data from your mouse movements to strengthen the encryption keys. Use your mouse to move randomly within the window for about 30 seconds. Once the progress bar turns green, click Format to begin formatting the volume. A message will appear saying, "The VeraCrypt volume has been successfully created." Click OK. Your encrypted volume is now ready. Click Next, and then click Cancel to close the volume creation wizard. Now let's mount the encrypted volume we just created. In the VeraCrypt main window, choose a drive from the list, for example, Drive M. Now click on, select File, and browse to the myvolume.hc file we created earlier. Select the file, then click Open. Once it is done, click on Mount option. When prompted, enter your 20-character password again. Also choose HMAC SHA-512 from the drop-down below, and then click OK. You will now see that the volume has been successfully mounted. Details will show the size as 299 megabyte, encryption algorithm as AES, and the volume type as normal. This confirms your encrypted volume has been successfully mounted. Let's now scroll down in the beginner's tutorial window to cross-check our steps. You will see the same sequence we just followed, and in the final step, the tutorial confirms. The encrypted container is now successfully mounted as a virtual disk, example, Drive M. This matches our outcome in VeraCrypt. And that concludes our demonstration on how to use VeraCrypt for secure disk encryption. In this demonstration, we will explore the SHA-256 sum tool. SHA-256 sum is a command line utility used to generate and verify SHA-256 hashes. It helps ensure file integrity and detect any tampering with the file or the hash. To begin, open the Kali Linux terminal by clicking on the terminal icon at the top left of the screen. Once the terminal is open, type the following command: SHA-256 sum --help. Then press Enter. In the output, you will see the available options and usage syntax for the SHA-256 sum tool. The syntax is displayed as SHA-256 sum option file. You will also see flags like -b for binary mode, -c for check mode, which reads and verifies checksums from file, -w for warn, and many other flags. Clear the terminal screen by using Clear command. To begin, let's check which version of SHA-256 sum we are using. Now type the following command: SHA-256 sum -- version, and press Enter. The output shows the installed version. Here it is 9.5, part of GNU Core Utils. This is one of the most up-to-date versions of the tool. Type the clear command to clear the screen again. In the terminal, type SHA-256 sum password.txt. Then press enter. You will now see a long string, which is the SHA-256 hash, generated for password.txt. Clear the screen once again using clear command. Next, we will save this hash into a separate file. So, type the following command: SHA-256 sum password.txt into hash.txt. In this command, we are generating the SHA-256 hash for password.txt and saving it to a file named hash.txt. Then press enter. Let's now list the files and check whether hash.txt has been created. In the terminal, type ls, then press enter. This will display the contents of the current directory, allowing us to verify that hash.txt is present. To verify the hash, type the following command: cat hash.txt, and press enter. This displays the contents of the file, confirming that the hash has been saved. Clear the terminal again using the clear command and press enter. Now let's verify the file's integrity using the saved hash. Type the following command: SHA-256 sum -c hash.txt, then press enter. If the output says OK, it means the file matches the saved hash and there's been no tampering. However, if it says failed or shows both OK and failed, this indicates that data tampering may have occurred in the file. And that's how you can use SHA-256 sum to verify file integrity and detect unauthorized changes.